Welcome to AWS for DevOps full course. This is 8 plus hours of tutorial which combine theory as well as hands-on. So whole this tutorial is divided into 6 chapters. First chapter is about AWS identity and access management. As a theory, we will understand what is identity and access management, then IAM user, group, roles, policy and access analyzer. After that, you will be creating IAM user and group. Then we will move to chapter 2 on Amazon Simple Storage Service. Again, there is theory, but as a hands-on, you will be deploying a personal portfolio website on S3. Then we have chapter 3 on Amazon Virtual Private Cloud. So this is networking service in AWS, and there we have the hands-on creating high available network in AWS. Then we will move to chapter 4 on AWS Elastic Compute Cloud. There we have hands-on of deploying React application on EC2 Instance. Then we have chapter 5 on Amazon Relational Database Service. And again, we have a hands-on on deploying Monolith application. So in this hands-on, you will be combining all your knowledge what you got in chapter 3 and chapter 4 along with a database. So you will be creating network, EC2 instance and database. Then you will be deploying this Monolith application. Then we will move to chapter 6 high ability in AWS cloud, where you will understand auto scaling group, load balancer and many more services. Then as a hands-on, you will be deploying two-tier application. Then you will be making this two-tier application high available using all the services and features what we have understand in this chapter. This is very long tutorial, so I have also added time stamp in the description. We have to cover a lot, so without doing any further delay, let's get started.
Hello students, welcome back. Do you know why your educational institutes give you the ID card? Because an institute's ID cards give them control over who can access their facilities. Your ID card acts as proof of you studying in that college and hence you can use their facilities. Similarly, AWS has a service that helps companies manage their identity in the cloud. In this video, we will learn the identity and access management service concepts related to IAM, identification, authentication, and authorization. So let's start with what is identity and access management. Identity and access management is a framework that ensures that the right people in your organization can access the only service they need to do their jobs. Remember, it is not a good practice to use your root account for everything you and your team to do, as it could lead to some serious security issues. Let's take an analogy here. Suppose you are working in an organization and every day when you enter the main entrance, you have to show your ID card to the security guard or you need to swipe your login card. In this way, your organization ensures that you are the right person who can access the organization's premises. And this is exactly how IAM works. When you show your ID card, you prove that you are the right person. So you as a person is an identity. Now when you show your ID card to the security guard, he looks at your ID card photo and your face and verifies whether both matches. Once verified successfully, you get access. So through this whole process, you as a person gets access to the right premises. That's not it. This ID card serves as proof to access a lot of other services and facilities in your organization. For instance, some people can only use the account section, while some can only use human resources, and so on. There is a well defined system of who can use what. In the same way, Identity and Access Management, or IAM in short, is a service in AWS that makes sure that the right person has access to the right thing. AWS IAM provides access control across all of AWS services and resources. You can specify who can access which services and resources and under which conditions. There is also the concept of IAM policy, which you can use to manage permissions to your workforce and system to ensure least privilege permissions. If it is not making sense, then don't worry. I am going to cover all these in the next couple of topics. For now, let's understand three important concepts of identity and access management. Identification, authorization, and authentication. These three terms are closely related, but they are not the same. Now let's understand them. Identification is the ability to identify a user uniquely. It means how a person or system can be identified. In the last example, you identify yourself with an ID card, right? And that varies from system to system. When you log into your bank account, you use username and password. So you identify yourself to the bank portal with your username and password. So your identification is your username and password. So identification basically is to identify every unique user who is accessing your services or facilities. The second concept speaks about authenticity. Authentication is the process of recognizing a user's identity. When you show your ID card to the security guard, he verifies your ID card photo with your face. That's authentication. When you log into your bank account, you provide your username and password. The banking backend system matches your username and password against the username and password stored in their system. The system makes sure you are given the right username and password. If you know the correct username and password, you are the owner of the account. So, if you have been given a unique identity, there has to be a system to recognize it every time you use your unique identity. And that process of recognizing the authenticity of your identity is known as authentication. Finally, authorization is the process of giving someone permissions to have access to something. Once you are authorized, you can enter the office premises and can go to your office area. But you cannot go to the canteen kitchen because you are not allowed, or we can say you are not authorized to access the canteen kitchen area as per your job function. Now let's understand identity and access management in respect of AWS. AWS Identity and Access Management is an AWS service that helps an organization to manage access of their AWS account and services for their organization people. It provides fine grained access control across all of AWS services. Fine grained means you can specify who can access which services and resources and under which conditions. If you want person X to only access AWS EC2 service and person Y to access only S3 service, that's completely possible. And this will be done with IAM policy. Hello students, welcome back. In the last video, we understood AWS IAM. In this lesson, we are going to be talking about the elements of IAM, which includes user, group, and roles. So let's start with users. A user is a person who utilizes an AWS service in an AWS account. As we discussed in the previous lesson, AWS has two types of users: root user and IAM user. The root user name itself gives a clue that this is the special user. It is created when the AWS account was created. So when you create an AWS account, AWS will create one identity or user for you. That identity user is called the AWS root user. This user has access to all AWS services and resources in the account. Some important points about AWS root users. You can sign in as the root user using the email address and password that you used to create the account. Root user has complete access to all AWS services and resources in the account. Hence, it is not a good practice to use the root user for everyday tasks, and you should never ever share root user credentials with everyone. Only very few reliable people should have the root credentials. Now we know that we cannot use root user for our day-to-day job. That's where the IAM user comes into the picture. IAM user is an entity that you, root user, create in an AWS account to represent the user who interacts with AWS resources in your account. Now let's understand this with an example. Let's say you are the team lead in an organization and you have an AWS account. You have two developers, Ram, Shyam, and two administrators, Sita and Geeta, in your team. Your team needs access to an AWS account to host an application. Because you don't want to give them access to your root account, you can create IAM users for your team members and provide them with the access to the services that they need for their job. So here each team member represents one IAM user, as each team member needs to interact with an AWS account to do their job. So you will create 4 IAM users for Ram, Shyam, Sita and Geeta. Okay, now we understand the IAM user. Let's look at the way IAM user works and how we assign permissions to different IAM users. When you create a user, the user has a username, password, and access keys that you share with the respective persons to access the AWS account. Username and password will be used to access AWS Management Console and access key for programmatic access with AWS CLI. You see, each user have been added to a single AWS account. Each user has their own credentials to access the AWS account. Now the important question is, what kind of AWS resources they can use? Well, any new IAM user does not have any default permission to access your AWS resources. To provide your IAM users with the necessary permission, you need to give them the required permissions. You can do it by adding IAM policies to each IAM user. IAM policy defines the permissions that are given to any user interacting with an AWS account. We are going to cover IAM policy in the next topic. In a nutshell, you create IAM users, attach policies to give permissions, and the user can use these credentials to access these resources. An important point here to note is that IAM user does not have to represent an actual person. It could be an application also. Let's say you have an application on-prem which needs to access an AWS service. You can configure the access key inside the application to access AWS services. That is another important use case of access key. Okay, let us now understand IAM group. An IAM group is a collection of users and permissions assigned to those users. Let's go back to the same example. In your team, you have two developers, Ram Shyam, and two administrators, Sita and Geeta, right? So both developers will be doing and accessing the same AWS services, and the same goes for both administrators as well. So instead of assigning permissions to individual users, you can group these users as well and assign permissions to that group at once. And in our case, you can create two groups, a group for developers and a group for administrators. IAM group provide an easy way to manage permissions for users according to their job functions. So when you create a user, you assign a policy to the individual user. But in the case of a group, you add a policy to the group and permission will apply to all users in that group. Let's take another good use case for IAM group. As you know, any user in a specific user group automatically has the permissions that are assigned to the user group. If a new user joins your organization and needs administrator privileges, you can assign the appropriate permissions by just adding the new user to that administrator user group. Similarly, if an existing employee is moving to a new project in a new role in the same organization, instead of editing that user's permission, you can remove him or her from the old user group and add him or her to the appropriate new user groups. So, the IAM group is a way to attach policies to multiple users at one time. When you attach an identity based policy to a user group, all of the users in the user group receive the permissions from the user group. Now let's understand IAM role. An IAM role is an IAM identity that you can create in your account that has specific permissions. An IAM role is similar to an IAM user attached with IAM policy that determines what a role can and cannot do in AWS. Now you must be thinking, what is the difference between IAM role and user, right? Let me explain to you. An IAM user is a unique person who has username, password and access key with the permissions attached to it. However, the IAM role does not have either a username, password or access key. So the IAM role cannot be directly linked to a person or a service. Instead, it can be assumed by a person or resource for a definite session. What does it mean? Let me explain with this image example. Let's say you have an application running on an EC2 instance and an EC2 instance needs to access an image from S3. In this case, EC2 assumes the role and based on policy, it will access image from S3. As I mentioned, roles don't have an access keys or credentials associated with them. The credentials are temporary and dynamically assigned by AWS. AWS gives the temporary credentials to the role to complete the task when it is needed. That's all for this video.
Hello students, welcome back. In this lesson, we will create IAM users and groups. By the end of this lab, you will be able to create these IAM entities and comfortably navigate through AWS IAM console. So let's get started. Here we are at the AWS console homepage. Let's navigate to IAM by using the search option at the top of the AWS console. As you can see, you can use the left navigation bar to navigate into user groups, policies, roles, and identity provided. For the scope of this lab, we will only work with users, groups, and their policies. Let's start by creating two users, Ram and Shyam. In our example, Ram is a developer and Shyam is an AWS administrator. You can navigate to the users page by clicking the user options in the IAM dashboard. This is the users page where you will see all the users created for your account. Now let's create our first AWS user by clicking on the Add Users button. We start by giving a username to your user. Let us call this user Ram. When creating more than one user with the same properties, you can simply add another username by clicking on this Add Another User button. However, for this example, we will do this one by one. The next option we see is the AWS credential type. You should select Access Key Programmatic Access to allow this user to be able to access AWS CLI commands or use AWS SDK and AWS API. We do not need this for our example, so we will only select Password AWS Management Console Access, which will give user Ram to access the AWS via Management Console. Selecting this gives us some more options. You can have AWS create an auto-generated password, or you can manually add a simple password for this user. For our example, we will let AWS give us an auto-generated password. The next option is Require Password Reset. You should check this box if you want your user to reset their password when they first access the console. We will uncheck for this demo. Click on Next Permissions. Here we have three options. You can add users to a user group. You can copy permissions from an existing user that you already have in your account, or you can attach policies directly. We have no users or user groups in our account, so we have no options. But if you click the third option, Attach Existing Policies Directly, you will see a whole list of policies, even if you have never created a policy in your account. These are the AWS managed policies. This means that these policies are managed by AWS and that if any changes is required, it will be made by AWS. These are highly useful for simple applications where you don't want to create and maintain your own policies and let AWS handle all this for you. We can select a policy here like Amazon S3 read-only access and give this permission to our user. Let us first create a user with no permissions. Click on Next Tags. Here we can add tags to our users. Let us add an example tag Department Finance. Then click on Next, which will open up the review page where you will see the final details about your user. Click on Create User. This takes us to the final step of creating an AWS user. Here we can see that the user Ram was created. You can even view the password of this user. Click on Download CSV, which will download a CSV file with user credentials to your computer. It is important to know that you should save these credentials somewhere after creating the user. If you navigate away from this page, you will no longer be able to get the credentials again. Click on Close and we can see that our user Ram is added to the user page. Let us create another user, Shyam. We follow the same process. Add the username Shyam. Allow AWS access via console. Leave all values to default except Require Password Reset and click Next. We will not be adding any permissions. Click Next. We will add the sample tag same as we did for user Ram, Department Finance. Click Next and click on Create a User. Download CSV to save credentials. Please note again that you won't be able to get credentials back after closing this page. Now that we have created our two users, Ram and Shyam, let us create our users group. Click on user groups and then click on create group. To create our first user group, add the name developers. We can add users to this group from the table below. Let us add Ram, who is a developer, to this group. The next step is to add policies to this group. We want our developers to be able to fully access EC2 and S3, so we will check Amazon EC2 full access and Amazon S3 full access from the policies table here and click on create group. We now have a developers group that has only one user. Let us create an administrator group as well. Click on create group. Enter the group name administrators. This time we will not be adding Shyam to this group right now. Let us create a group without any users. Let us now attach policies to this group. We will attach the administrator access policy. Click on create group and we can see that our group are created. But the administrators group does not have any users as of now. Now let us add Shyam to this group. Go to the users page. It has both the users Ram and Shyam. Click on Shyam. You can see that this user does not have any permission. Move from permissions to the groups tab. Click on add user to groups. This will give you a list of user groups. Let's add Shyam to his administrator group here. Now if you go back to the permissions tab, you can see that the permission has been added to this user. Shyam now has the administrator access policy attached from the administrator group. So we have created two users, two groups, provided with AWS access to these users assigned AWS managed policies. That's all I wanted to cover in this lesson.
Hello students, welcome back. In this lesson, we will log in with IAM user to the AWS console and create role. I assume you have completed the last demo and you have a user named Shyam and his password. So let's get started. Let us first log in as administrator Shyam and use it to create a role. Now let's open the CSV file you downloaded while creating user Shyam. Here you see this contains username, password, access key ID, secret key ID and console login link. As we have not selected programmatic access, that is why the access and secret key is empty. Let's copy the console login link and open it in the browser. Here you see the account alias is already filled and this is something we have created in another demo. You can also use account ID in case you remember. Add your username and password as shown in the CSV. This will take us to the AWS console. Now we can see the AWS console as before, but if you see the top right corner of your screen, you can see that we are logged in as a user Shyam. Let us navigate to the IAM console again. Click on the roles option from the left dashboard and click on the create role button. The first option we have is to select the trusted entity. This means we should select what this role is for. Who or which service is going to use this role? The first option is the AWS service. You should choose this when you want to assign this role to AWS services like EC2, Lambda or ECS, which is what we will do here. The next option is the AWS account. This is used to create a role that can be accessed from other AWS accounts. So if you want someone to be able to log in from another account to yours, choose this option. The next option is web entity. This is when you want users to be able to assume this role and access AWS console via a web entity like Google Facebook login. The next option is SAML 2.0 Federation. SAML is a user maintenance service that is used by big organizations to allow their employees access to different services in the organizations. This can be integrated with AWS to give access to the AWS console. The final option we have is a custom trust policy. You can use this to define a custom JSON trust policy. Don't worry if the last three options did not make sense to you. The first two options are important for this course. Choose AWS service and select EC2 from the options below. We will create a role that can be attached to an EC2 instance. Click Next. Here we can see the list of policies we can attach to this role. Attach the Amazon S3 full access policy and click Next. Enter the role name. You see a description already filled with a meaningful message. Allow EC2 instances to call AWS services on your behalf. Review the role and click on Create Role. It will take a few seconds. Now you can see the role you created on the roles page. We will be using this role in upcoming demos. So students, IAM users are the best to give access to your AWS account, and even you should use it. I will recommend creating an IAM user for yourself with administrator permission and use going forward. And also make sure to enable MFA for IAM users as well. I believe you already deleted your root user access and secret key, which we created in the last demo. At this stage, you can also create an access and secret key for your IAM as well. You can find the link in the resource section. That's all for this session. Welcome back, students. The last session was all about IAM users, groups, and roles. We also briefly discussed IAM policies to give permissions, but that's not enough. Understanding policies is crucial to effectively working with IAM. In this lesson, we will talk about IAM policies in detail, including their definition and types. So let's get started. Let me ask you a question. What comes to your mind when you hear the word policy? If you thought about rules or guidelines, you have got it right. IAM policy is more or less the same thing. In the previous session, you would have noticed that we gave certain permissions to users, groups, and roles that we created, and then only they could perform the actions as per those permissions granted. These permissions are nothing but policies that we are going to talk about in this session. By definition, IAM policy is an entity when attached to any identity or resources defines its permissions. As I earlier said, policies contain permissions that determines whether a request is allowed or denied. It means whatever action is performed by an identity, the permission is given by its policy. So you can use the IAM policy when you have to set the permissions for an identity in IAM. Now let's understand this with the same example. You have a team of two developers, Ram and Shyam, and two administrators, Sita and Geeta. So you created two groups, developer group and administrator group. As per the job role and permission, the developers in your organization can list, start, and stop the EC2 instance, and the administrators can create and delete the EC2 instance. EC2 is nothing but a compute service in AWS. We will talk about it in the coming modules. So you will create two policies. One policy for the developers that will allow list, start, and stop EC2 instances, and another policy for administrators which would enable them to create and delete EC2 instances. And you will attach these policies to the respective groups. So, what would happen here is that the policy would be applied accordingly to everyone in these groups. That means both Ram and Shyam will have permissions as developers and Sita and Geeta as administrators. Hence, in this example, by attaching developer policy to the developer group, we are allowing the members in the group to perform specified actions and nothing more than that. Now we know how policies work. Let's understand the different types of IAM policies. If we go back to the policy definition again, IAM policy is an entity that, when attached to any identity or resource, defines its permissions. According to the definition, a policy can be attached to either identities or resources. As you already know, identity is nothing but IAM users, groups, and roles. And the resource means AWS services like EC2 Instance, S3 bucket, Lambda, which we are going to cover in later modules. So, based on the two ways a policy can be attached, it is of two types: identity based policy and resource based policy. Now, we will understand both one by one. Identity based policies are attached to an identity that are IAM user, group, and role. These policies control what action an identity can perform on which resources and under what conditions. Please note that these policies are user specific, which allows user to access the AWS resources in their own accounts. An IAM user, group, or role can have multiple policies that together represent the permissions for that particular user. For example, you can attach the policy to the IAM user named Ram, stating that he is allowed to perform the Amazon EC2 run instance action. You can further state that Ram is allowed to get items from an Amazon S3 bucket, my bucket. Combining both the permissions, Ram can only launch EC2 instance and access my bucket. The other type is resource based policy. These policies are attached to an AWS resource such as an Amazon EC2 instance, S3 bucket, etc. These policies control what action a specified AWS service or identity can perform on other resources and under what conditions. Let's understand with an example. At times, there will be scenarios where EC2 instance would like to access the S3 bucket. So you also need to attach the policy to EC2 instance and give the required permission to access S3. Now further, identity-based policies are of two types: managed policies and inline policies. The managed policy is further classified in AWS managed policy and customer managed policy. Now let's look at them one by one. AWS managed policies are policies that are created and managed by AWS. As the name suggests, you would be clear that this policy is created and managed by AWS and you cannot make any changes. For example, Amazon S3 read only access or S3 full access. Essentially, they are designed to align closely with commonly used IT industry job functions like administrator, developer, or reader. So you can give S3 full access permission to the administrator and S3 read only access to the auditor. The objective is to make granting permissions for these standard job functions easy. AWS managed policies cannot be changed, and AWS will manage and update the policies as necessary. Customer managed policies are created and managed by the customer. Basically, as a customer, you can create and manage these policies. If you want a fully controlled policy that you can maintain, you can use a customer managed policy, which you create and manage in your AWS account. It provides more precise control over your policies than AWS managed policy. Another advantage of customer managed policy is that you can attach to multiple entities within your account, making it much easier to scale. For example, you have 4 reader users in your account for a different team that all need the same type of Amazon EC2 read only access. You can create one customer managed policy and attach it to all 4 users. If you need to change that policy, you can change it in one policy which applies to all. So it provides you built in and centralized change management for those managed policies. You have complete control and you can manage permissions at any level you feel is necessary. Next and last is inline policy. Inline policy is directly attached to the user or group. It maintains a strict one-to-one relationship with policy and identity. That means an inline policy is attached to a single entity. It is generally created when you create an identity and deleted when you delete the identity. It is beneficial when you have to give permission to a temporary user or group. So you create an inline policy while creating a user or group, and when you delete the user, the policy will also be deleted. Alright, so that's pretty much about the policies. Let's quickly summarize what we learned in this session. A policy is basically permission that decides what action should be taken in the AWS accounts. And we learned about the different types of IAM policies, which are identity based policies and resource based policies. Identity based policies are further divided into 2 types: managed policies and inline policies. Managed policies could be AWS managed or customer managed.
Welcome back. In previous session, we have understood IAM policy, and so far in this session, I have mentioned multiple times IAM policies because we use policy to give permission to IAM user. Now in this session, we are going to understand IAM policy with example. So let's get started. So IAM policy is a nothing but a JSON template, and this is plain text where we write some keys and values, and these policies define what access will be given to someone. Before we go in detail, let's take an example and we'll try to understand with the example. Let's imagine there is a librarian, and this librarian is managing the library, and in the summertime she needs an intern who can help her manage the catalog. So this all catalogs of the books is stored in Amazon S3, and as I said multiple times, S3 is nothing but a storage service in AWS that we are going to cover in the later module. So to store any data, and in this case a book catalog, we need a bucket. Again, bucket is the AWS S3 resource we create, and in this bucket we put our data. So we need to create a bucket. So she want to give access of this intern to this bucket to store data. Then how she can do? For that, she need to create a policy, and this policy she will attach to this intern IAM user, and then it will decide what permission is given to this intern while he's accessing this S3 bucket and this data. Now on same line, I have designed this JSON policy
Now let's go ahead and understand this. So as I said, IAM policy is a JSON template, and this looks like this, and it has couple of statements, and this is very important, and this is what we need to understand. So let's start one by one. So IAM policy start with the version, and this version is not important for you. This is for the AWS. So you know when this policy is going to execute, so on backend there is a software, and this software has the version. So the engine where this policy is going to execute, so this denote that version, and this is not important for us, so ignore for this point of time. Now next we see here we have the statement, and we see here we have the one statement, but within this policy we could have the multiple statement, and one statement denotes set of the permission. So here we have only one statement, so one set of permission. Here we could have the multiple as well. So again, this is something important we need to understand and keep in mind. Now within this statement we have some keys, and regarding these keys we have some values, and this is most important. So here first is the effect, and this effect is allowed, and this effect again in terms of the IAM policy, this is called attributes. Okay, so effect attributes current value is allowed, it could be also denied. So in current case we are saying if this is the intern and this policy is going to attach to this intern, so this intern is what effect, he is allowed, this intern is allowed to do something. What then we have this action, and this action decide what he can do. So this intern what is going to do is going to access this S3 bucket, right? S3 bucket, and for that we have attached this policy to him. So he is allowed to access this bucket, and what action he can do, he can in S3 list object, he can list object in this bucket. So in S3 when we create a bucket, and bucket when we store any data, this data is called object. So again I will cover in detail in the later module. For the time being just understand data in the S3 bucket is called object. So he can list the object, and also he can get the object, means he can get the data from this S3 bucket. So effect is allowed to list the object and get the object. Now where, that's where resource attributes came into the picture. So here we are saying, so in AWS you could have the multiple bucket, right? We are saying which resource is library catalog bucket, and here we see this is ARN. I have again mentioned in the earlier, ARN is nothing but AWS resource name. This is unique identifier of our AWS resources. In this case, this S3 bucket. So we are all saying this intern can allowed to get object, get data, and the list data from this bucket, library catalog bucket. And also here we have another resource, and this resource is same. The difference is here after the bucket we have the asterisk, and this asterisk means he can access everything, all data within this bucket. So this is what asterisk denotes here. So bucket / asterisk means all data from this bucket. So to summarize here, this intern allowed to, okay, let me clean the screen. So now this intern is allowed to access, list all the data and get the all data from this bucket. So if we attach this policy to him, so we are giving this permission to this intern. So this is how IAM policy looks like, but this is the simplest policy. It could be more complex. Here Another attributes could be like some condition, some rules, and based on that rules, this policy will be executed. And again, as I said, we could have the multiple statement like this. So I hope now you understand what is IAM policy and how IAM policy looks like. Thank you so much. See you in next session.
Hello students, welcome back. In this video, we will learn a few IAM best practices to ensure the security of our AWS accounts. So let's get started. The first IAM best practice is to avoid sharing login credentials. So instead of sharing root user credentials with different users in your organization, you should create IAM users for individuals who are going to use your AWS resources. Let's understand this with an example. Suppose you have two developers and two administrators in your team. What people sometimes do is create one IAM user and share user credentials with all these four people. But it is not a good practice. Instead, we should create four different users according to the roles of these team members and share the user credentials with them. The objective here is that every user should have their own IAM credentials to access your account. It does not matter whether they are accessing the account through Management Console or using AWS CLI or any SDK. The next best practice is to create groups. It is always recommended to create groups and assign only the required permissions to these groups. That means if there are multiple users in your organization with the same job role, instead of assigning permissions to individual users, you can create a group, assign a permission to this group, and add all the users who have the same job role in the group. Every user will assume these permissions. Let's understand this with the same example. Suppose you have two developers and two administrators in the team. So instead of giving permissions to these four individual users, you should create two groups, one for the administrators and another for the developers, and add the required permissions to these groups. You can now add users to their respective groups. The users will automatically assume the permissions assigned to their respective groups. This practice will help you manage the permissions at the group level instead of the user level. Let's move to the next best practice, which is permission. AWS recommends that we should always create permission for what the user needs according to their role. These permissions are known as least privilege permissions. For instance, if a user's job is to start and stop the EC2 instances, then instead of giving full access to EC2, we should only give permission to start and stop the EC2 instance. So, we should always create least privilege permission and policy while designing permission. Now, going forward, the one more best practice is auditing. AWS says that we should always enable CloudTrail inside each and every AWS account. If you don't know CloudTrail, it is an AWS service that's free of cost except for storage. So whenever a user interacts with your AWS account, CloudTrail will log each and every activity, which eventually will help you during audit. We will learn CloudTrail in detail in AWS Security and Management module. Let's understand with an example. Say a user logged into your AWS account, created an EC2 instance, and then terminated it. AWS CloudTrail will log all the three activities. This way, you will have a record of all the activities that users are doing inside your account. The next best practice in the list is adding password policies. AWS says that you should always configure password policies, which we have done in the previous video. Password policies ensures that every user has a strong password. The next best practice is MFA, multi-factor authentication. You should always enable multi-factor authentication for privileged users. I would recommend that you enforce MFA for every user. You can create a policy and attach that policy to all groups. Now, whenever any users log into an AWS account, they will have to authenticate their identity twice. Then only they will be able to do anything in your account. This is very good practice to ensure your account and AWS resources are secure. The next best practice is to rotate the login credentials. Everyone accessing your AWS account needs to change their user credentials every now and then. You can even enforce this policy on the users that they will have to rotate their credentials every 2 months or 3 months or 6 months. This is a part of your password policy inside your AWS account that we have been seen in the previous demo. Under this policy, user will not only have to rotate their passwords but the access and secret keys as well. Last but not least is root user. You should not use root user for your day-to-day activities as it might expose your root user credentials. Additionally, you should also limit the access of the root user. As soon as you have an AWS account, store the root user credentials somewhere private and create an IAM user event for yourself. So students, I hope you now understand that account security is a real issue and you should employ these practices to safeguard your account from any possible threat. That's all for this video.
Welcome back. In previous session, we have discussed different IAM best practices. It means you communicated these best practices to your entire team and you also documented in your Office Confluence page so they can follow it. But does that mean everyone will follow this? Probably not. In this case, how do we ensure your organization is compliant and secure? That's where proactive monitoring come into the play, and this is very detailed topic, but when we are talking about the IAM, here we can talk about one IAM tool and feature called IAM Access Analyzer. Now let's get started and understand what is IAM Access Analyzer. IAM Access Analyzer is a tool or service that streamline your journey towards least privilege. This is very simple term as I have already explained in the previous session. So what it means when we say least privilege? It means, let's say if we have a user and we want this user can only start a EC2 instance, so we only give permission to start EC2 instance and nothing else. So this is called least privilege. Another example, let's say we have another user and this user can only list data from our S3 bucket. So we can only give access to list data from this S3 bucket, nothing else. So this is called least privilege. So now let's understand a bigger definition of the access analyzer. So IAM Access Analyzer is a tool that helps you ensure resources within your organization or your account that are shared with maybe internal or external entity, which could be the IAM user or federated user, are secured and compliant. So now it's very important to understand IAM Access Analyzer is AWS tool and service that help us to follow least privilege, and where It will do in your AWS account, single AWS account, but it can also work on your organization. And we understood in earlier session, AWS organization is a way to manage multiple AWS accounts. And this is what happens when we work with the real-time customer. So it will help us to maintain least privilege, maybe for single account or your AWS organization, where it will analyze access of internal entity. Internal entity could be IAM user, IAM group, and roles. So this is internal. So this identity we create in our AWS account with IAM. So this is called internal. Or also could be for the external entity. And the external entity means when we do federated access. So when we allow your organization Active Directory user or maybe Okta user to access your AWS account, or maybe your G Suite users to access your AWS account. So those are called external entity. And also this is very detailed topic, and you don't need to go in the that detail for AWS certified cloud practitioner, but this service and feature you need to know, and you can expect a direct question in your exam. That's why I'm touching here, but I'm going a little bit details, so don't worry, but only what you need to know for your AWS certified cloud practitioner. This tool help you to analyze access of your AWS accounts to maintain least privilege. So this is very simple. This is what you need to know, but little bit more details. When we say this external entity, it means it works based on a resource-based policy. So a resource-based policy is the policy which we attach to AWS resources. So let's say S3 bucket. So it's also allow if S3 bucket has the public access or not. What does it mean? It means if S3 bucket is public, mean anyone can access, right? If anyone is accessing your S3 bucket, it means that other people are external entity, right? So this is also do consider. So based on the resource-based policy, it's identify who else is accessing your resources, and this is something I will show you in demo as well. So S3 bucket could be another options. Other could be Amazon SNS topics, Amazon SQSQ, AWS KMS key, AWS Lambda function, and many more. So you also analyze access of these services and the resources for external user. It also do cross account access. It also checks cross account access. So to summarize, IAM Access Analyzer is a tool that help you maintain security and compliance of your AWS account for your internal and external user, and it goes for the AWS organizations as well as for individual account. Now how do we do that? For that, there is a configuration settings that we'll do in the next session. We can set, it's give the capability to set, verify, and redefine the permissions. Now let's understand this in detail. So how does it work? So first things first, to get this feature of IAM Access Analyzer, we need to create Access Analyzer in your AWS account. This is basically two types. One is for the internal, another for the external. I'll show you in the demo session. So we create a analyzer. So when we create an analyzer, so it will monitor external or unused access of your resources within organization and individual account, and then we can review it. So it will create a dashboard, and from dashboard we can review it. So once you review it, then you can get our findings, and based on these findings we can take some action. and this action could be either automated or manual as well. So once you enable, it generates the findings. Then based on this finding, we can take some action and say yes, this is okay and this is not okay, and based on that we can go ahead and we will redefine our permission. So now let's look into some benefits of the IAM Access Analyzer. So first benefit is it's help us apply least privilege to our permission, and this is already we discussed. Now what is the next benefits? Next benefit is it's help us to centralize review of policies and access. So it generate the report, and this report is available in our IAM dashboard. So centrally from one account, let's say if you're working for the customer, they have hundreds of AWS accounts, and we know each account has the permission, right? So from one account, your master account, you can manage and review these permissions. Next is permission redefinement, and this is the next step. So when we have the list of the permissions, this is unused, or maybe we are given the more access than needed, then we can go ahead and redefine it. And again, this redefining could be manual as well as we can automate it. Again, it helps us to validate IAM policy. So this is follow IAM best practices. So AWS is gathering information across industry, across customer, and they define the best practices. So that's follow these best practices and help us to validate the IAM policy. And you can also define your own best practices. Now take an example. So let's assume in your organization you don't want to give S3 full access permission to any user. So you can define your best practices, and this will validate it. Now let's go to the next. Next is automate IAM policy review. As I have mentioned, we can automate it. So let's assume, so when anyone creating a policy, so in your organization you have the CI/CD pipeline, and this we do for the customers, and I have done for one of my customers. So in our customer premises, when someone need to create a policy, so they need to define with the CloudFormation template, and they need to commit. Once they will commit it, it will go with the pipelines. In the pipeline, we will have the way where we check the permission this user is creating, this is really allowed or not. If not allowed, then we don't allow them. Then he will get the message, okay, your permission is over permissive, this is not allowed. Okay, so again we can automate the review. And last and very important, as I already mentioned, so this integrate with AWS organization. So this is very important feature, and I will tell you from my experience, I have been struggling a lot with my customers. Okay, I worked with the customers, they have 300s of the AWS accounts, and then we have to give permissions. And it's become very hard over time to monitor these permissions. Okay, sometimes means we don't have the time and we have to give someone access, we do that and maybe we forget. So this is a very good way to go ahead and check and get the dashboard of all permission and manage from the central place for your AWS organization. So that's really good feature. So that's all about IAM Access Analyzer, and this is very important topics. As I said, you can directly expect question in your AWS Cloud Practitioner exam, also AWS Solution Architect Associate as well. So keep in mind. So that's all for this session, and next session I will show you in the demo how this looks like in AWS Management Console and how do we create it. Welcome back. In this session we are going to do hands-on and understand IAM Access Analyzer from AWS Management Console. So directly let's go to the AWS Management Console. and this is my account, and currently I am in one of my child account. So I have the master account, and within that master account I am in the child account. So I have already enabled Access Analyzer in the master account, but here I wanted to show you how do we create Access Analyzer. So first things first, if you will log into your AWS account, so you will be mostly in your dashboard. It will look something like this. Then from here you need to go to the IAM. So either you can search from here, or as I have been using this, so I can go from here. So let's click. Then once we scroll down, in the left panel you see the access reports, and in this access reports everything is here. Okay, so expand it. Then here we see Access Analyzer. So let's click, and now here we see some details about the Access Analyzer, how it works. You can go ahead and read it. This is really good information. Now here we have the button to create it. So let's click Create Analyzer. Now here you see we have two types. One is for the external access analysis, and another is for unused access analyzer. So as I have mentioned earlier, external access analyzer used for external users and the resources which has access of the external user, whereas unused is used for the IAM user roles and groups. So here you can select any of them. So I have already created, so I'm not going to create it, but just you can select any of them based on your needs. And now most important things here you see here. Okay, now let's go to here, external access analyzer, and here you see where you want to enable it. Okay, you have to give the name and all these details. Now if you select this one, unused access analyzer, okay, then you can select the tracking period. So it's 90 days by default. You can increase it based on your needs. Then here you can select where you want to implement it. So currently this is going to implement it in your current account. Okay, but here you don't see option to implement in your AWS organization, because this is not account where I am managing my AWS organization. Okay, so when I take you to in my AWS organization account, there you will see there is also option for AWS organization. So if you enable this in your child account, okay, non-master account, non-AWS organization account, then you won't see option to select AWS organization. You only see current account. But when you go there, you will see the organization as well. Okay, then very simple, go ahead and create it. Once you create it, it will start finding the result. Now let's go back to my master account, and there I have already created, and we will look into some of the reports. So let's go to Access Analyzer, and here currently I cannot create it because already I have created. So here we see we have the external access, we have the one report, and for the unused access we have around 57 reports, and we can look into them. Now here in access settings, okay, we see this is used for the external user, okay, and this is created for the unused access. Now let's go ahead and try to create it, and here I wanted to show you in this account. Here you see when we are creating this access analyzer, then we see the zone of the trust, and here you see the AWS organization and as well as your current account. But AWS organization option was not visible when you are doing from your non-master account, but here I can do it, and now this is going to create this external access analysis for my entire AWS organization. Now let's go in my AWS organization activity, and here you will see I have around 5 to 6 AWS accounts, and now this is going to apply for all these AWS accounts. So this is one of the really good benefits of AWS Access Analyzer. It works for the across accounts. Now let's look at some of the example. So for the Access Analyzer, let's open this. This is saying here findings is there is the S3 bucket. In this account we have this S3 bucket parvinmishra.in, and it has the given access to the read access to the all public. Okay, so here we need to check, does it really needed? If not, we can go ahead, okay, take the appropriate action. Otherwise, if you think this is fine, we can go ahead and archive it. So this is how it looks like. In this account there's no much information, that's why we cannot see so many findings. Now let's go back to the unused access. So here unused permission, again we see the unused role. Okay, so these are some role is created but it's not used at all, right? And this means for this IAM user there are some permission that's not used at all, though it's given but it's not used. So we go ahead and remove that. Let's look into, so let's click here, and here we see, here we have given access to the firehose, IAM, pinpoint email and S3, and here this user never used the S3 any of the action which is given here. They also never used the firehose permission and also IAM as well. So you go ahead and remove from here. Okay, so here is the recommendation step. Go ahead, review, then take the appropriate action. Okay, again we can review from here. Now let's go back and look at the different example. Now this role, let's open this role, and it's saying this role is not used at all. So it's not used at all, right? You can go ahead and delete it. This is how Access Analyzer looks like, and here if you go here you'll see really good dashboard, but currently I have just enabled 1 hour before, so there is no more information. But in your customer account, if you go and enable it, there's so many data, you will see a really good dashboard. So that's really good things. Another important things you need to know about this report is, here we have credentials report. So here you can go ahead and create and download the credentials report, and this report has the some of the information about your user who is accessing your AWS account, from how long they are using, they have created any keys, and these keys are not in use. So this kind of information is there. But again, this is old way of doing that. So IAM Access Analyzer came in 2019, and before that there was no such a way. So there was only one way to go ahead and create these reports. So I have been using this, okay, earlier before 19, when I used to do AWS well architected review. So this is a really good place for me. Go ahead and download this report from the customer account, okay, and then see how many IAM users they have. They have created some access keys, they are not using it, okay. So again, this is not so useful, but you can expect some question in your AWS certification exam. So this is important for you to know as well. Now I have already downloaded one of the report. Now let's look into how this looks like. So here you see is something like Excel sheet, and this Excel sheet has the different headers. So one is here user, we see, so that many users we have, and here we see this is the ARN of the user, and when this user got created, and password is enabled. So there's two types of user in AWS account, right? One is the system user, another is human user, right? So here we have some system users, for that there is no password. So this is what we can check from here, okay. Then when is the last password used, okay, and when last password changed, and you see the access keys when got created, okay, access keys last used, okay. So all these kind of details are available here. So this is really handy, okay, to quickly go ahead and look at the report and get the report of your AWS account. Again, this is very important for your AWS certification. This is pretty much about IAM Access Analyzer. So I hope you got now also theory and practical aspect of how this is looks like and what it is. Thank you so much for watching this session. See you in next one. Welcome back. This is last video of identity and access management, and from here we are going into the different module, and those modules are AWS core services like storage, compute, networking and database, and there you are going to create AWS resources. So here I just wanted to ensure and make sure you are flowing with me. You have created your AWS free tier account. You have created budget and set the alert so you get notified when bill exceed in your AWS account. And third, you really understood AWS free tier service and its offerings. If you not, I will highly recommend, please go ahead and watch those videos once again and do everything what I have said, because as I mentioned earlier as well, I have noticed 30 to 40% of my students do this kind of mistakes, and they see some bill in their AWS account and they ask, what should I do now? So this most important things you should be doing before going to the next section. Why? Because here I'm going to show you some real-time example. So in previous session, we have understood IAM Access Analyzer, and IAM Access Analyzer is not free tier service and there is some cost, and I am aware of it, and I was knowing that when I'm going to do that there will be some bill, okay, and this is what happened. So there is some cost in my AWS account. I'm going to show you. So lesson is, before doing anything, you have to ensure you're looking into AWS free tier dashboard, websites, and understanding AWS services cost. It's very, very important whether you are preparing for AWS Cloud Practitioner or AWS Solution Architect Associate. So what I'm going to show you, I will take you on AWS Cost Explorer dashboard. And this is very good service. I will be covering this in AWS Management Service section. Okay. So don't worry, as of now, I will cover in very detail. I'll give you theory and also do the hands-on. But here, just I wanted to take you on that dashboard and show you how builds looks like. So let's go to the AWS console. Well, so this is my AWS account where we have created IAM Access Analyzer. Now you see this is the current month bill, and if you notice this bill was something different. Anyways, now to see the billing information of our AWS account, you know, as of now, because we have already discussed in earlier sessions, you go here and go to billing and cost management. So let's click here, and this will take us to the AWS billing and management console. And here we have Cost Explorer. Okay, you see the cost analysis, and also we have the Cost Explorer. So this is something we need to enable it. I will cover in very detail. Okay, but for time being, let's look into this. So this is how this looks like. And other side, if you see, we have the different filter. We can filter it. So for the time range, so let's go, and here I'm going to go just for the current month. So July 1st to 5th and apply. Now we see this is getting all the data, and this is bill of the current month for the last 4 days, 5 days. Okay. Now here we have the different filter. Okay. You want monthly, hourly or daily. For us, let's go to the daily. So we know how much I've been paying to this account on daily basis. Okay. Then in the dimension, we can see AWS services, we can see linked account, region, and the different options. For this, we'll select AWS service. Now here in this account, I have a different charges type. Okay, and here let's select this. I want to select all and exclude credit because I have some AWS credit, so this bill is going from there, so I want to exclude that and apply. Now we see our daily expenses, right? So July 1st we see expenses was around $14, and one of them, no, $21, and out of them $14 was for the AWS registrar. So this is domain name that I renewed. Okay, and the remaining coming from the different services. You see this one, and this one is constant, and this is what I expect, around 1.9 $1.8 daily expenses of my AWS account, because I know I'm running some services. Okay, but on the 4th we see we have some unexpected cost, and this cost is coming from identity and access management services, and here is saying access analyzer. And yes, so when I have enabled that, then it's scanned all existing IAM user roles and also external resources which access is given with the resource policies. So when it was scanning, so there is the cost per scan. Okay, and for that it charged $11, though I have deleted that after the demo, but you see this is the bill. Okay, so what I'm trying to bring your attention here, this is very important, right? So this is $11. If it could be $100 and $500, it could be the big amount for you, right? So it's very important for you to set up AWS budget and configure alert and really have good understanding of AWS free tier services. I hope now you get the understanding of what is consequences of this if you don't set up the budget and alert and understand AWS free tier. So that's all I wanted to cover here. You just make sure you set up everything before you go to the next section. Thank you so much. See you in the next section.
Welcome back. In this video, we will learn about one of the core AWS services, the simple storage service known as S3. We will start with the S3 overview, understand the S3 bucket, and also the folder. Let's start with what is S3. S3 stands for Simple Storage Service. As you can see, the first characters of simple storage and service are S. That's why it is called S3. It allows you to store, retrieve, access, and backup any amount of data at any time from anywhere over the internet. S3 is a perfect storage solution for storing massive amounts of data. For example, audio files, movies, large-scale photo storage, big data sets, etc. We can access S3 either from Management Console, AWS CLI, or AWS SDK. Now let's talk about how we store data in S3. To store any data inside S3, we need to create a bucket inside an AWS account. An S3 bucket is a logical container in which data is stored inside S3. So, to store any data in S3, we need to create a bucket. We can also create multiple buckets to organize our data. Bucket is identified from its name and it should be globally unique across all regions and accounts. For example, if I create a bucket and name it my bucket, then no one else can use it in any AWS account. In other words, once an S3 bucket is created, no other AWS account can create the S3 bucket with a similar name. S3 bucket simply works as a storage, in which we can store unlimited data either directly inside the bucket or create a folder and then put the data into that folder. Now let's understand what a folder is. Folders are used for grouping and organizing files. Unlike a traditional file system, Amazon S3 does not use hierarchy to organize its files. For the sake of organizational simplicity, the Amazon S3 console supports the folder concept as a means of grouping data. So you can have multiple folders or files inside a single bucket. Basically, the folder is a namespace inside the bucket. Let's understand this with an example. Inside the AWS account, we have S3 service. In this service, we can create buckets as we have learned so far. And inside this bucket, we can store our files, images, videos, or data. Moreover, if we want to organize our data, we can create folders inside the bucket and also folders inside folders. And then we can store our data inside these folders as well. It will make more sense when we will do the demo in the next lesson. Another important concept in S3 is object. So when we store any data that could be files, documents, images, videos, etc., they are known as objects in AWS. Hence, the object is nothing but your file, document, image, video, etc. So anything sitting in your hard drive is known as a file. But when you upload this file into S3, it will be known as an object. And the bucket in S3 is similar to the file directory in your hard drive. Now we will talk about the characteristics of objects that you need to know. The maximum size of a single object that you can upload to S3 is 5 terabytes. Please note that 5 terabyte is not the size of total data that you can upload. Instead, it is the maximum size of a single file that S3 allows you to upload. But that doesn't mean that you cannot upload objects bigger than 5 terabytes. If you have an object bigger than 5 terabytes, then you have to split it into multiple parts and then use something called a multi-part upload to upload them. The max object size is 5 terabytes, but you must use a multi-part upload as soon as you upload an object of size more than 5 terabytes. Another characteristic is object versioning. It is nothing but keeping multiple variants of the same object when we are making some changes to it. In S3, you can version objects to protect them from any unintended actions or even the accidental deletion of an object. This means that you always retain the previous versions of an object. The next characteristic is the storage class. You can create multiple buckets and store them across different classes or tiers of data. Classes are different levels of storage with different costs. Based on how frequently you use your data, you can choose a class. If you don't use your data much, you could choose a cheaper class and leave your data there and so on. We will talk about it in detail in the coming lesson. Last but not least, you can then create permissions to limit who can access or see your objects. One of the most common policies in the bucket policy is a resource-based policy which you can use to grant permissions to your bucket and its objects. So in this session, we looked at the S3 bucket, folder, objects and their characteristics. Hello students, welcome back. In this video, we are going to understand three important concepts which are availability, durability and data replication that will be used a lot in the next session while understanding different storage classes. So let's get started with availability. It refers to the system uptime. This simply means that for how long the system is available. In other words, It's the time for which the system is operational and able to deliver data upon request. We measure this availability in percentage. This is also known as SLA, which stands for Service Level Agreement. It is basically a promise that service providers have with their customers for the availability of their services or systems. And if they keep their promise and customers get everything within the promised time, that means the SLA is completed. Let's take an example. Supermarkets say they are open 24 into 7. It means it's available round the clock for you. If they keep their promise and are open throughout the day, week, month, and year, then we can say that their availability is 100% and they fulfill the SLA. The next concept is durability. It refers to long-term data protection. That simply means how well is your data protected from any possible loss or corruption. So in addition to availability, your data should not be lost or corrupted if you store it in a storage device for a long time. Durability is also measured in percentage. Let's understand this with an example. Suppose you stored 1000 kilograms of potato in cold storage for 6 months. When you got them back, it was only 800 kgs. It means either 200 kgs of potatoes were rotten or eaten by rats, right? That means the cold storage service was not durable. So, next time you will make sure to store potatoes in a well equipped cold storage so there will be no loss. So, this is called durability. Now we understand what data durability and availability are. It's also important to know how data gets stored in S3. It is based on a concept called data replication. So let's understand this. If you remember from the last lab, we have created an S3 bucket inside the Mumbai region and uploaded an image. So when you upload any data in your bucket, this data will go to one of the availability zones in the region. In our case, we created a bucket in the Mumbai region. So our image was uploaded in one of the availability zones. But to secure our data, AWS makes additional copies of our data and replicates it in other availability zones. So the data gets stored and replicated in all the availability zones within the same region. Now the question arises, why does AWS do that? Here we need to remember that AWS promised 11 nines of data durability. It simply means AWS promises 99 points additional 9 number of 9% data durability guarantee. AWS does not ensure 100% data durability, but they say that there is a 99 point additional 99% chance that your data won't be lost. So how does AWS make sure when we are uploading any data inside S3 that it won't suffer any loss? For that, AWS maintains copies of our data in all the availability zones in the same region. In case of any data loss, they recover the data from other availability zones to the lost one. So that's how our data is always present in all the availability zones of one region, and that's the reason AWS promises 11 nines of durability. In extreme cases, if any availability zone goes down, our data will still be available in other availability zones of that particular region. Okay, so this is one of the significant benefits of using Amazon S3. This is a simple example of when we upload new data. Now, let's understand what happens when we make any changes to our data. Suppose we have this image in 3 availability zones and we change the color of this image and uploaded it. Then AWS automatically updates the remaining 2 copies of your data in other zones. The same goes for delete as well. So when you delete your data from one zone, it will be deleted from all availability zones in the region. So students, we understood data availability, durability, and how AWS promises 11 nines of data durability with data replication. That's all for this session. Hello students, welcome back. In this video, we will understand different storage classes. This session will be full of facts, so I recommend you all make notes. We have added some supplementary learning resources in the resource section. Please make sure that you make the best use of them. So let's get started. In one of the previous videos, we stored an image in an Amazon S3 bucket. While uploading the object, we noticed that the storage classes were showing under the properties. AWS offers various options to store our data in the cloud. These options are known as storage classes, and we can choose any class based on how frequently we access our data. These S3 storage classes are purpose-built to provide the lowest cost storage for different access patterns. It means different types of storage classes are designed to fulfill different purposes of storing data. Students, as a cloud engineer, it is very important to understand these classes as they can save your time and money. Let's understand them one by one. The first one is S3 standard. It is a general purpose storage class used for frequently accessed data. It offers high durability, availability, and performance. S3 standard is designed for 99.999 availability and 11.9% durability. In other words, they are just 0.001% chances that your data might be lost and so on. It gives you low latency and high throughputs, and it can sustain up to 2 concurrent facility failures. That means if 2 availability zones have problems, your data is still safe. As it delivers low latency and high throughput, S3 standard is appropriate for a wide variety of use cases like cloud applications, dynamic websites, content distribution, mobile and gaming applications, and big data analytics. The next one is the infrequent access storage class. As the name suggests, this storage class is used for less frequently accessed data. A data that you only access once in a while, but you also want this data to be immediately available whenever you need it. It must be available as soon as you request for it. If that is the case, you can use the infrequent access storage class. It is designed for 99.9% availability and 11.9% durability. Availability of infrequent classes is lower than the S3 standard, and because we don't access our files very frequently, it is cheaper than the Amazon S3 standard. But when we access the files, we pay a per GB retrieval charge. So this is the trade-off in this class. We pay less for storage but need to pay a retrieval fee every time we access our data. This low cost and high performance combination makes S3 standard infrequent access ideal for long-term storage, backups, and disaster recovery. Our data in this class is also resilient against the events of an entire availability zone failure. Next, we have one zone infrequent access. So this is very similar to the infrequent access storage class. But the only difference is that in one zone infrequent access class, the data is stored in a single availability zone, whereas in the infrequent access class, it is stored in at least 3 availability zones. Basically, your data is less available because it is present in just one availability zone. The best part is that you still have low latency and high throughput performance. Also, since the data is stored in one availability zone, it is 20% cheaper than infrequent access. So, S3 one zone infrequent access is ideal for customers who need a lower cost option for frequently accessed data but do not need the availability and resilience of S3 standard or S3 standard infrequent access. This is a good option for storing secondary backup copies of on premises data or the data which can be easily created again. You can also use S3 cross-region replication to cost-effectively store data that is replicated from another AWS region. The next is S3 intelligent tiering. As the name suggests, this storage class comes with an inbuilt intelligence which automatically moves data to the most cost-effective access tier based on their access pattern. Here, the access pattern indicates how frequently one datasheet is accessed. Here, the objects will be moving automatically from one storage class to another storage class based on the changing access patterns of these objects. As a result, frequent access data will be moved to the frequently accessed storage and infrequently accessed data will be moved by S3 intelligent tiering into the correct category. It has the same low latency and high throughput performance as the S3 standard, but this is highly cost optimized. For example, if data is moved to the infrequent access class, it will save up to 40% on storage costs. And if it is moved to the Glacier class, it will save up to 68% on storage costs. It is also designed for 11.9 durability and 99.9% availability over a given year across multiple availability zones. As a user of this service, you only have to pay a small monthly monitoring and auto tiering charge. So this will give you the most cost optimization without thinking too much about it. It is also resilient against events that can affect an entire availability zone. Now the next storage class is Glacier. Amazon S3 Glacier is the lowest cost storage class in S3 and supports long-term retention and digital preservation for data accessed once or twice per year. It is helpful for customers, particularly those in highly regulated industries such as financial services, healthcare, and public sectors. These industries retain datasets for 7 to 10 years or longer to meet regulatory compliance requirements. It is designed for 11.9 durability of objects across multiple availability zones. So, as the name suggests, you expect that your data will be frozen, which means it will be maintained for a longer period of time. It means object retrieval validity is very long. Now, AWS supports 3 types of Glacier for a different access pattern. Moving forward, let us now quickly compare different Glacier types. Amazon S3 Glacier Instant Retrieval. S3 Glacier Instant Retrieval offers a retrieval time in milliseconds with the same performance as S3 Standard. Amazon S3 Glacier Flexible Retrieval. In Glacier Flexible Retrieval, the retrieval time can be configured from minutes to hours with free bulk retrieval. It is best suited for backup and disaster recovery scenarios when large amounts of data occasionally need to be retrieved quickly and cost effectively. Amazon S3 Glacier Deep Archive. In the S3 Glacier Deep Archive, the retrieval time of data is within 12 hours. It is the lowest cost storage class designed for long-term retention of data that will be retained for 7 to 10 years. It's an ideal alternative to magnetic tape libraries. So students, I hope you now understand the storage class. In case you have any doubts, I recommend you go through this session one more time. Welcome back. In this demo session, we will learn how to create an S3 bucket, folder, and upload data into it. So let's go to the AWS Management Console. Remember, we first need to select the AWS region. So I will select the Mumbai region. After that, we will go to the S3 console. There are three ways we can find the S3 service in the console. The first method is by searching for S3 in the search box, and it will give us S3 in the result. The second method is by finding the S3 in the All Services menu. Just expand the menu, locate the S3 service, and click to open it. And finally, if you have previously used S3 in your account, it will be listed under the recently visited services. So let's type S3 here and click to confirm. When we first arrive at the S3 console, we will see a list of buckets within this AWS account. Since S3 uses a global namespace, you don't have to select a region while using the console. Now, if you are thinking why did we select the region if S3 is a global service? Well, selecting the right region every time when you are working in your account is a good practice. It does not matter whether the service is global or region sensitive. Now let's move ahead and create an S3 bucket. To do that, click on Create Bucket and choose a name. Now one thing to note here is that the bucket name should be unique. So to make this name unique, let's add some random numbers at the end. Now there are some rules that we need to follow while naming buckets. The first rule is that the bucket name should be between 3 and 63 characters. Second, the name must have lowercase letters, numbers, dots, and hyphens. It should begin and end with either a letter or a number. Last, your bucket name should be unique across AWS. Select the region where you want your bucket to be created and leave the rest of the default settings and go ahead and create the bucket. Now the bucket has been created and it did not take more than a second. On this page, you can see the bucket name, the region where you created the bucket, and access to the bucket object. Now let's go to the bucket. Now here, you can see the different tabs including properties, permissions, metrics, management, and access points. And here is the object inside this bucket. So this is the place where we upload our files. And as we have learned in the last session, we can either upload objects in the S3 bucket or we can also create folders inside the bucket to organize our data. So let's go ahead and create one folder and name it as demo. Now we can upload our object in the bucket or this folder. Let's click on upload. Here we have two options. Either we can upload files or upload folders. We will upload a file here, so click on add files. Here we can do some additional settings to our object. Just click on properties and you will see storage class. It is standard by default. We will cover this in detail soon in this module. So let's skip this for now and click on upload. Now our file is uploaded successfully. So I will exit by clicking on close. Now I have one object in my S3 bucket with the name demo.jpg. If we click on our object demo.jpg, it will take us to the object dashboard, where we will see the object properties, permission, and version. Let's go into the properties tab. Here we can find all the details about our object like who is the owner of the object, in which region the object is uploaded, and when was the object last modified, the size of the object, the type, object key, the S3 URL, the Amazon resource name, E tag, and here is the object URL. It is the link to the file. We can open it by clicking on this. But let's open it in a new tab. As you can see, I get access denied because this bucket is not public and I don't have the right to access this object. So if the bucket is not public and you try to open the file using its public URL, it will not open. Now let's go back to the object dashboard. We have another way to open this object just by clicking on Open. It will open a new tab and show us our demo picture. Now you must be thinking, why does this work even if the bucket is not public? Well, when we open an object through the open, it opens because this is a unique URL. As you can see, the URL is much longer and not similar to a public URL. This is a special URL for me as an owner of this object. So I am authorized to access this object through this URL. Now the last thing I wanted to show you is how to delete an object from S3. For that, I will go back to the bucket and select the object. Then click on delete. Here you will have to type delete to confirm that you want to delete the object. Then click delete object. This will permanently delete this object. So students, I hope you now have confidence in S3 and its scope. In this session, we have seen a demo where we have created an S3 bucket folder, uploaded objects successfully and deleted them. Now go ahead and do it yourself.
Welcome back. Amazon S3 has a very amazing feature called hosting a static website. And I have already mentioned this in my previous sessions. I'm running my company website using this feature and I'm paying nothing. Not only that, with my customer also we are using this feature a lot and I'm going to talk in detail in some time. So before we take all those examples, in today's session I'm going to talk about what is exactly hosting a static website in Amazon S3 and how it works. So as we know, Amazon S3 is a object storage and it has the capability to host application. And one point you need to keep in mind that this is suitable for hosting a static content. And I've mentioned this word many times. It's only used for hosting a static website or a static content. Now, what does it mean, a static content? So when we say it's suitable for hosting a static content, it means S3 is ideal for serving content that doesn't change dynamically or require server-side processing. Now let's take some example. So let's say you have a PDF file or maybe text file and you want to send this PDF file or text file to someone else, or maybe you want to showcase from the browser. Okay, so content of PDF file, content of text file will not be changed, right? And it could be download as well. Other example could be a resume, right? Any report. So this kind of content don't change. So these are called a static content. And top of that, that's not only. If you have a HTML file, CSS file, a JavaScript file, so these are also static. So if you don't know, HTML and JavaScripts are code that's run on the browser. It's not need any server. So if you have any application or the website that build on HTML and CSS, this is called a static website, and this kind of application we can run from AWS S3 feature, a static hosting. Now let me give you an example. So For one of my customer, we have built a application, and this whole application is built on React.js. And the backend, it's calling API gateway, and for the server side processing, it's running Lambda function. Now this whole application that's built on the React.js, so when you build your application on the React.js with npm build or the yarn build, then it's generate the static content, and again it's become static. And as it's become static, now using this feature hosting static websites, we are running this application in Amazon S3, and from there it's calling API gateway and running Lambda function. And using this feature, we are saving thousands of dollars for my customer every month. So this is a really good feature. Now let's understand how this exactly works and some important points regarding S3 static website. First and most important point, so far we have been accessing this S3 either from AWS Management Console or AWS CLI, right? In all cases, we have been using API. We are doing API call to Amazon S3 service. So whether we use Management Console or CLI to create S3 bucket, to upload data or access those data, all was the API call. But when we are going to enable a static website hosting, then this is going to enable HTTP protocol for the S3 bucket. What does it mean? It means once it will enable HTTP protocol for S3 bucket, it means we'll be able to access data from S3 bucket from the browser, right? So that's where HTTP works. So this protocol is going to be enabled while enabling a static website hosting on the S3 bucket, and we will do it practically in the next session. So do remember, this is very important point. So in general, when we access S3 bucket, upload data, download data, get data, we use API calls. But once we enable S3 static website hosting, then it's enable HTTP protocol and we access data using HTTP. Along with that, another important point, when it's enable static websites, then it's create a endpoint for us, and this is called website endpoint. And this endpoint looks like two way. One way is, so you see, this is our website endpoint. So once we enable a static website, so endpoint will be looks like this, right? Because we know we have the HTTPS, and that's how we access any data from the browser, right? So it need to be HTTPS. So it will be HTTP, then it will be bucket name. So whatever bucket you are going to give name, then S3 website, then we will have the region, then Amazon AWS.com. But one important point you notice here, between this S3 website and the region, we have the dash here, okay? This another way, okay, or not another way, in some AWS region, when we enable this website endpoint, then there will be the dot instead of the dash. So that's something you have to keep in mind. So everything will remain same, but only between this S3 website and the region, it could be dot. So there's no major difference, but this is something you should know when you are going to enable a static website hosting for your application. Other than that, you must be thinking, right, Praveen, this is something looks like some domain name, right? But this is not exactly what I want when I'm going to run my application from S3. I need a custom domain. And of course, you can do that as well. You could have the custom domain for your S3 website, but for that we will use route 53. So we need to do this domain mapping from route 53 to our S3 domain name, this DNS name, what we are going to get. But one important point you have to keep in mind, your bucket name should be same as your custom domain name. So take an example. If you have seen my website, thecloudadvisory.com, so that is my custom domain where I'm accessing my S3 website, right? So your bucket name should be same as your custom domain name. It means my bucket name where I have enabled static website hosting, bucket name is also thecloudadvisory.com. So your bucket name should be same as your custom domain name. So this is important point, and this is something you can see in your exam as well. So that keep in mind, this very important point. Now let's look at some example of using static websites where we can use it. So it's very good for the building a portfolio where you want to showcase your skills, maybe some of your sample work, or maybe your contact information. In that case, we can use static website hosting. If you take an example, there is a photographer, right? He want to display a gallery of his work, so he can go ahead and use a static website hosting for making his portfolio. Another use case could be the building a landing page. What is landing page? So landing page is a single page website where we capture information about the website visitor. So again, it's good for building a landing page. Another could be for the documentation sites. If you know Amazon documentation, this is completely statics. If you want to build some documentation, so again you can use S3 static website hosting. So another example could be the blog which don't generate any dynamic content. So if you go and look at my mastering AWS DevOps, again this is my another blog for my book mastering AWS DevOps, and there is around 22 hands-on session, and all those blogs are running again on Amazon S3. So again, this is good example of creating your own blog. Well, now let's look at the some feature of using Amazon S3 as a static website hosting. First and most important thing is scalability. So when you are running your website from Amazon S3, you don't have to worry about the scalability. Where your website is accessed by 1 people or 1 million people, it didn't matter. So S3 will make sure this content will be served and there won't be any problem, because S3 is a scalable solution. We don't have to maintain any servers. So that is the first feature. Second important feature is high availability. So in generally, when we run our web application from the server, we try to ensure that our servers are high available. But in Amazon S3, we know S3 is the high available service, so you don't have to worry about this. And AWS makes sure our S3 service and S3 bucket is available all the time. So this is high available by default. And next is cost effective. As I said multiple times, so in S3 we only pay for amount of data we store and for number of requests, and this is not going to be huge as compared to running a website from the server. When we run a website from the server, you have to do the maintenance, you have to ensure you have the enough capacity, and there's so many things involved, updating the servers, patching, so many things. So again, this is the cost effective. So this is pretty much what I wanted to cover over here. In next session, we are going to do hands-on and create a static website from our AWS Management Console. Thank you so much. See you in the next session. Welcome back. In this session, we are going to do hands-on on hosting a static website in our Amazon S3. So to do that, we are going to follow a couple of steps. So first things, we are going to create a S3 bucket. Then inside this S3 bucket, we are going to upload website files content. After that, we are going to enable website hosting. So this is a specific feature. We are going to use that. Then we need to configure index for our website. That's called index document. After that, we need to enable block public access, because we know our bucket cannot be accessed publicly if you don't configure these settings. After that, we are going to create a bucket policy to make our bucket publicly accessible. So let's go to the AWS Management Console. Well, so I'm in my AWS S3 dashboard, and first thing first, we need to create a S3 bucket. So let's click create a bucket and give the name of the bucket. And here I'm going to create this in the Mumbai region. So make sure you are selecting the region where you want to create this static website for yourself. So I will give name of this AWS Cloud Certified Practitioner 10002. Then scroll down, every settings I will leave as it is and create a bucket. It's going to take couple of seconds. Now we see this is ready. So this is here. Now we don't have any data. Now second thing is to upload the data over here. And for that, what I did, I went to the website called freecss.com, and from here I have downloaded this template on my local system, and this template we're going to use. Okay, so if you click on the live session, you see this is the website, and this is completely built on HTML CSS. So now we are going to deploy this one. Okay, so now let's go to the AWS Management Console, and here upload the data. So here I can click upload the data, and here we have so many files. So instead of that, I'm going to use AWS CLI. So let's go to the AWS CLI, and you see I'm here, and here let me do pwd. Now you see I'm in my download folder, and there this website name is, if you see, this template name is Instance, and I have downloaded it here, and now I'm in this folder, right? And here, as I did ls-al, we see the all files. So all these files are here. So we have index.html, service.html, contact.html, about.html, and some folders. Well, now to upload the data, I'm going to use AWS CLI, and for that we will use the command AWS. Okay, before that, let's list the all bucket in this account. So AWS S3 LS, and you know I'm going to do this hands-on in my Epicbook AWS account, right? In Epicbook, and for that I have set up a profile called Epicbook and hit the enter. No, something is wrong here. Do clear, and okay, AWS should be S3 LS Epicbook, and we will see our 4 bucket over here, correct? So all looks good. Now what we'll do here, I want to upload all these files from here. So AWS S3 and syn sync dot means from this current folder to where S3, then I'm going to use this bucket name and hit enter, and it's going to upload, is saying access deny. Okay, AWS 3 sync S3 bucket. Let me do like this. If this works, okay, looks like I don't have enough permission. So, and let's do one thing. Let's go and check the permission together. So let's go to the IAM service, and let me open it. And here I have the user, Mac user, okay, Praveen, okay, and here I don't have any permission. Okay, I have administrator permission. Maybe I'm missing some command over here. Let me double check. AWS S3 sync, AWS S3 sync from dot S3. So here what we are missing now, so here I need to pass the profile, right? So profile Epicbook, hit the enter. Now it's uploading all file, all data. Now let's go to AWS console. Looks like it's already uploaded. And now let's go here to our S3 bucket. Go to the S3 and open the bucket. Now we see everything's got uploaded here. Now let's look at what steps we have completed. So we have created S3 bucket, uploaded all the data. Second step is to enable website hosting. Let's go to the AWS management console, and here we'll go in the property. In the property, if you scroll down, here we see option static website hosting. So this is disabled. So let's click on the edit and enable it. And here we have to do couple of settings. First settings, we need to give the index document. So here index.html, and this is also we have seen. Let's do clear, and if you do ls -al, then we have index.html, and this is file what we want to serve when someone will try to access our website. So index.html, and if you have any error page, then you can also give it here. For us it's not, so let it be, and let's go ahead, save this. And this is got enabled. If you scroll down, now we see this is the URL of our website. This looks something like, as I have mentioned, the endpoint, right? So here we see http, then bucket name, then s3 website dot, here we have ap, right? A region name, then Amazon AWS.com. Now we have enabled static website hosting. We also configure index document. Next, let's go ahead and disable block public access. So let's go to the AWS console and we'll go back. Let's close this, go to the permission, and this is on. So let's click here and disable this and save and confirm. And that's done. Now next things is we have to set bucket policy, right? So let's go back, and here, okay, this is again in the permission section. Scroll down, bucket policy, click edit, and we have to give bucket policy. So again I will go ahead and get the bucket policy which I have used earlier. Okay, so let's copy the bucket policy from here. Let's go to the AWS management console, paste here, and by now you know we need to use this ARN, and make sure here you are leaving this /strict because this is very important. Okay, now you see principal is all, so it's public for the everyone. Save the changes, and that's pretty much. So sometime you will see it will take some time, okay, because there is the DNS comes into the picture, right? So DNS need to be propagated, so it takes couple of minutes, but wait for a couple of seconds, maybe minutes, then refresh this, and now we see this whole website is running from the S3, right? So very nice. Click here, services, contact us. So once again, this very great feature of using S3 for hosting your static website. So that's all for this session. See you in next session.
Hello students, welcome back. In this video, we are going to learn about Virtual Private Cloud, or VPC in short. It is the networking aspect of cloud computing, and it may be a little difficult to relate it with our day-to-day life. So we will try to make it as simple as possible. Since this is a very important section and building block for the rest of the topics in this module, I recommend that you pay special attention to this topic. Let's take an example. Suppose there is a residential building and it has many flats. There are hundreds of people living in these flats. Let's say I own flat number A10 and you own flat number B20 in this building. We can also say that flat number B20 is your private section of the building where you keep your stuff, and you have complete control over it. You can also add security features such as a lock, camera surveillance, etc. In the same way, other people have private areas that they own. So now let's connect this example with AWS and VPC and replace the building with AWS and flats with VPCs. In our AWS account, we create and manage all types of resources like EC2, RDS, and so on. We will get into what these specific resources are in the later modules. These resources in your VPC are just like your stuff in your flat, and the AWS VPC is like your private area in AWS in which you can place your resources and services. And just like an apartment has different level of security, you can also put a level of security over these resources. In other words, we can say that there are ways for you to either grant people access to your database or your cloud resources, or you can also prevent them from doing so. Now let's understand the definition of AWS VPC. A virtual private cloud A virtual private cloud is a virtual network dedicated to your AWS account. It is logically isolated from other virtual networks in the AWS cloud, in which you can launch your AWS resources such as Amazon EC2 instances. VPC stands for Virtual Private Cloud. It is nothing but a virtual data center on the Amazon Web Services. This is private because it's only for you and you have complete control over it. This is a completely isolated logical network that you can use the way you want. So when you create VPC, basically you create a logically isolated network. If I am creating a VPC in my account and you are creating a VPC in your account, these are two isolated networks. Even two or more VPCs with different IP addresses within the same account will also be isolated. You can understand the IP address as the address of your flat. This IP address is called CIDR, which stands for Classless Inter-Domain Routing. It is a set of Internet Protocol standards that are used to create unique identifiers for networks. So when you create a VPC, you specify a range of IP addresses for the VPC in the form of a CIDR block. For example, 10.0.0.0 by 16. As of now, you understand VPC is a network within your AWS account. You can also create subnetworks within a network, which are also known as subnets. We will cover subnets in the next lesson.
Hello students, welcome back. In this video, we are going to understand subnet, internet gateway and route table. So let's get started. As we discussed in the previous video, VPC is a network in our AWS account and we can also create subnetworks inside our VPC. These subnetworks are also known as subnets. Let's look at our previous example. So we own a flat in the apartment and this flat is our private section. We have a bedroom, a living room and a kitchen in this flat. Essentially, these are different subsections of our flat used for various purposes. Similarly, in AWS VPC, we create a subnetwork like public subnet and private subnet. When we create a subnet, we specify the CIDR block for the subnet, which is a subset of the VPC CIDR block. If the CIDR of our VPC is 10.0.0.0 by 16, we can use 10.0.0.0 by 24 and 10.0.1.0 by 24 as the CIDR of our subnet. We can launch AWS resources into a specific subnet, such as EC2 instances. One important point to remember is that each subnet must reside entirely within one availability zone and cannot span across zones. This we will see while doing the hands-on lab. There are two types of subnet, public subnet and private subnet. We could relate it to our flat. We have a guest room with direct access from outside. It is like a public subnet, while our bedroom is completely private for us. Now let's understand what public subnet is. It is a subnet that interacts with the internet and can be accessed through the internet. It means any resources created within your public subnet, for example web servers, would be accessible through the internet. Since public subnets interact with the internet, we will deploy our load balancer or internet-facing applications in the public subnet. I will cover this in detail in the EC2 module. The next is private subnet. It is a subnet that cannot be reached from the internet. It means we can create the AWS resources which are only used inside the VPC for internal purposes. Now let's put it all together. We have a region in our AWS account and there will be a VPC in that region. The VPC will have what's called a CIDR range, which is a range of IP addresses allowed within our VPC. The VPC can also go across two availability zones, availability zone 1 and availability zone 2. Availability zone AZ1 contains a public subnet and a private subnet. Similarly, availability zone AZ2 also contains a public subnet and a private subnet. Hence, we have two availability zones, one VPC and 4 subnets in this example. Now you must be thinking, what is the difference between a public subnet and a private subnet? Well, there is no difference in these architectures. The process of creating them is exactly the same, but what you configure inside them determines whether a subnet is public or private. You need to make two changes to a subnet to make it public. First, you need to add an internet gateway. It is an AWS managed component that is attached to your VPC. It acts as a gateway between your VPC and the internet, basically the outside world. So let's add an internet gateway here. We now have an internet gateway attached to our VPC which will establish connection from the internet. Now, if you are thinking that a public subnet now has access to the internet, well, that's not true. There is another component called router inside VPC, which determines where the incoming traffic will be directed. This process is known as routing. Router uses something called route tables to control network traffic. Therefore, each subnet inside VPC must be associated with a route table. Whenever we create a subnet, it will come with a default route, which is a local route. As we can see, this route table has a destination field and a target field. The destination field contains the destination address that you are trying to reach, and the target specifies the route to that destination. That means any request within the VPC IP address is local. So to make a public subnet, we need to add destination address as internet, which is 0.0.0.0 by 0, and the target as internet gateway. This new route here in the route table has a destination of 0.0.0.0 by 0. It means that any IP address not known within the route table sends it to this target. And in this case, this target is the internet gateway. And this part here is simply the ID of the internet gateway. It means any traffic other than the VPC network will go to the internet gateway, and hence this subnet is now a public subnet. Now these two subnets are public subnets and the rest two are private subnets. Hope that's clear to you. If you have an instance in a private subnet, it will not be accessible through the internet. However, you might want to give it access to the internet to download files or to get the operating system updates. In this case, we can use what is known as a NAT Gateway, which is managed by AWS or NAT Instance. It can also be self-managed. That way, you can access the internet within your private subnet. So, NAT Gateway is a highly available AWS managed service that enables your instances in private subnet to connect to the internet. So, we create a NAT Gateway in our public subnet and we create a route from the private subnets to the NAT Gateway and from the NAT Gateway to the Internet Gateway. And this will allow your private subnets to get internet connectivity. That's all for this session. I hope you now understand VPC and its elements. In case you have any doubts, I recommend you go through this session one more time, as this is very important for your certification, interview, and in general also. Hello students, welcome back. In this demo, we will create a VPC in our AWS account. We will also look at the parameters and options that AWS offers to create a VPC. We will also create an internet gateway and configure public and private subnets. So by the end of this lab, you will have a complete understanding of how to create VPCs and make private and public subnets. So let's start by going to the AWS console. First, we need to select the region. I will choose Mumbai as I want to create a VPC in the Asia Pacific Mumbai region. Now, to go to the VPC dashboard, we will search for the VPC in the search and click VPC to open the dashboard. As you can see here on the dashboard, we already have a VPC created in our account. This is the default VPC that AWS creates. This VPC has a routing table and internet gateway in all the regions. We can use the default VPC for demo purposes, but it is always recommended to create your own VPC for development, test, and production environment for the most suitable configuration. If you go to any region, you will find one VPC and some route tables and an internet gateway associated with it. Let us now create our own VPC. Click on VPCs and then click on Create VPC. We will be giving it the name Path Up. The next option for us is to select if we want IPv4 or IPv6 addresses in our VPC. We will opt for IPv4 and give 10.0.0.0 by 16 as the private IP range for this VPC. Then we have the tenancy, which specifies where your infrastructure is provisioned. If we select default tenancy, our EC2 instances will be on shared hardware with other AWS users. If you want a VPC where all EC2 instances are on dedicated hardware, you can choose to create a dedicated VPC. The next option is tags. As you can see, AWS has already created a name tag for us. We won't need any more tags. So let's click on Create VPC. We now have our own VPC created in this region. Let's go back to the VPC page. You can see that now we have two VPCs in this region. We will now create an internet gateway and attach it to our VPC. For that, click on Internet Gateway, and as you can see, we already have
an internet gateway for the default VPC. Let's click on Create Internet Gateway and give it a name Backup IGW. Now click on Create an Internet Gateway. Next, we have to attach this Internet Gateway to our VPC. We can do that directly by clicking Attach to VPC in the top green bar here, or by clicking the Actions button here. Click on Attach to VPC and select your VPC. If you are using AWS CLI, you can click on this scroll bar and attach it to your VPC. But as we are not using AWS CLI, we can click here and attach this internet gateway directly. We now have a VPC with an internet gateway, but we still cannot create infrastructure in the VPC. For that, we need to have subnets. So let's create subnets. Click on subnets here, and based on which region you are in, you will see 3-4 subnets here. These are the default public subnets attached to the default VPC. Next, we will create subnets. For that, click on Create Subnets. First, we need to choose the VPC. So we are choosing the Backup VPC that we created. Now, add a name to our subnet, Public Subnet 1. We will select the AP South 1A availability zone and give an IP range of 10.0.0.0 by 24 to the subnet. Let's skip tags for now and click on Create Subnet. We can now see our subnet in the list. We will create 3 more subnets. Select the Backup VPC, give the name Public Subnet 2, select AP South 1B availability zone and give an IP range of 10.0.1.0 by 24. Click on Create Subnet again and repeat the process. This time we will give the name Private Subnet 1 availability zone AP South 1A and the IP range of 10.0.2.0 by 24. I am repeating this one final time. Give the name Private Subnet 2, availability zone AP South 1B and IP range of 10.0.3.0 by 24. Please note that you cannot have overlapping IP ranges in subnets. Now we have 4 subnets across 2 availability zones in the Mumbai region. But what is the difference between our private and public subnets? We created them using the same method, just their names are different. As of now, all 4 of the subnets we created are private. The difference between private and public subnets is that the route tables of the public subnets have an internet gateway entry. If we see the details of the route tables in our subnets, we only have one entry, 10.0.0.0 by 16, local. This simply means that any requests going to routes within this range are to be routed within the VPC. Let us go ahead and create a public route table for our subnets. For that, click on the route table and as you can see, we already have 2 route tables in our account. One is attached to the default VPC of the region and the other is attached to the new VPC we created. If you see the default route table of the default VPC, in the route section, you can see that there is an entry to the internet gateway. This means that all the default subnets of the default VPC have this route which makes them public subnets. And if you see the route table of our VPC, we only have the local route which makes our subnets private. Now click on Create Route Table and give it the name Backup RT Public. Next, we select our VPC and click on Create Route Table. We now have another private route table. Now we need to add the Internet Gateway path to the table. For that, click on Edit Routes and click on Add Route. Select 0.0.0.0 byte 0 as the destination. Choose the Internet Gateway as the target and select the backup IGW we created. Then click on Save Changes. We have a new public route table in our VPC. Let's now associate our route table to public subnets. We can do that by clicking Actions, Edit Subnet Associations and selecting the public subnet 1 and 2 and then click on Save Associations. Let us go to the subnet page and have a look at our subnets. You will see that the public subnets are associated with the new route table which has the Internet Gateway entry. You can also do that by clicking on this Edit Route Table Association button to change route tables for a subnet. Now we have created a VPC with 2 public and 2 private subnets that we will be using throughout this session. As I said, creating and keeping VPC, Internet Gateway and route tables is completely free, so you do not need to delete them. So students, I hope you understood all that what we did in this demo. That's all for this session.
Hello students, welcome back. In this video, we will learn why we need a security group and NACL, what are these and the differences between them. Security groups and NACLs both act as virtual firewalls. They control traffic to and from the resources in a VPC by following some inbound and outbound rules. Inbound or outbound represents the direction of the traffic between networks. The direction is defined with respect to a reference network. Inbound traffic refers to the information coming in to a network. Here, the reference network is your internal network. It could be your computer also. As you can see, data is flowing from the internet to your computer. So it's called inbound traffic. Outbound traffic refers to the information going out of the network. Again, here you see data is flowing outside from the reference network, which is your computer again. So data traffic flow is from your network to the internet. So it's called outbound traffic. Now let's come back to security group and NACL. We will begin with the security group first. A security group is an AWS firewall solution to filter the incoming and outgoing traffic from an EC2 instance. It acts as a virtual firewall for EC2 instances to control the inbound and outbound traffic based on some defined rules. It ensures instance level security. Both inbound and outbound rules work independently. For example, an inbound rule might allow traffic from a specific IP address only to access the instance, whereas an outbound rule might allow all traffic to go out of the instance. As security groups function at the instance level in a VPC, we can apply a security group to one or more instances as well. Similarly, an instance can also be associated with one or more security groups. Let's look at NACL now. It stands for Network Access Control List, which controls the traffic to or from a subnet according to some defined rules. This means it adds an additional layer of security at the subnet layer. For example, an inbound rule might deny incoming traffic from a range of IP addresses, whereas an outbound rule might allow all traffic to leave the subnet. As NACLs work at the subnet level of a VPC, we can apply a NACL to one or more subnets. However, each subnet must be associated with a single NACL only. Now let's have a look what is the difference between the security group and NACL. Security group operates at the instance level, but NACL operates at the subnet level. Security group supports allow rules only, but NACL supports allow rules and deny rules. Security group is stateful. It means return traffic is automatically allowed regardless of any rules. As we have discussed already, there is no way to add an outbound rule, so all allowed traffic returns by default. It maintains a state of allowed traffic. That's why it is called stateful. NACL is stateless. It means return traffic is not allowed by default. There should be explicitly allowed rules to allow them. Security group applies to an instance only if someone specifies the security group when launching the instance or associates the security group with the instance later on. NACL automatically applies to all instances in the subnet that it's associated with. Therefore, it provides an additional layer of defense if the security group rules are too permissive. However, security groups and NACLs operate at different layers in the VPC. So, which is the best way to secure your network, security groups or NACLs? In-depth defense is about layers of security, and security groups and NACLs are just two of those layers. Therefore, a better solution is to implement both to lock down your network. That's all for this session. Hello and welcome back. Compute is another one of the core offerings in cloud computing, and there are various cost-effective and flexible compute services available in AWS for different requirements. So in this lesson, we will understand what exactly is compute and what are the different compute services available in AWS. Let's take an example. Imagine you have got your dream job as an architect at a space technology company, where your job is to work with the data science team and process the data to make some sense of it. The research team of your company has collected huge amounts of image data that might lead to the discovery of water on Mars. Now it is the job of your team to process that image data and come up with the findings. But when you started processing this data, you realized that you don't have any free servers to do the work. What does it mean to not have free servers? Well, we need powerful computers to process the huge data, and in this case, the processing power that you need to process the data is not available. This processing power is known as compute. For any program or application that you want to run, you need some memory to open the program and some CPU to process the commands that you give inside the program. Hence, the combination of memory and CPU is what we refer to as compute here. It could also include other resources like networking, storage, etc., depending upon the type of application you are running. Cloud computing has made it very easy to get the compute power whenever you want. Configure them based on your requirement and pay only for what you use. AWS has various compute services for different requirements, but it is important to understand which compute resources best suits your workload and what are different compute options available in AWS. First of all, let's understand what AWS compute is. AWS offers an on-demand computing service for running cloud-based applications. These are applications that can be deployed on a remote server and accessed over the internet. AWS provides computing resources like instances and containers. Instances are nothing but virtual machines. AWS also provides serverless computing to run applications where you do not require infrastructure setup or configuration when you go for a serverless compute option. AWS compute resources are available on demand and can be created with just a click of mouse. You will only pay for the resources you use and only for as long as you are using them. AWS compute resources are broadly classified into three categories: instances, which are virtual machines, containers, and serverless computing. In this module, we will discuss them all. It will help you to decide which is the best compute service for your requirement. If you want to learn more about AWS compute, check the link provided in the resources section. The document has different examples and scenarios of where you might use different compute services. Now we are aware of what is compute and the compute services that are available in AWS. So with that, let's end this video. Hello and welcome back. A couple of times so far in this training, we have used the term virtual machines, and I hope you already have an idea about it. But before we dive deeper into the things, let's understand virtual machines in detail. So what is a virtual machine? A virtual machine is a virtual environment that works like a computer within a computer. Sounds complex, right? Let's break it down. Basically, a virtual machine is commonly known as VM. It is no different than any other physical system like a laptop or a smartphone. It has a CPU, memory, disks to store your files, and a network to connect to the internet. Your laptop and smartphone sounds real because they are physical. VMs can be thought of as virtual computers within a physical computer. Now you must be thinking about how it is possible to have a virtual computer within a physical computer. Let's say you have a laptop and it has Windows operating system on it. Now you feel like learning Linux. For that, you need a Linux operating system. So what would you do? Would you buy a new laptop and install Linux operating system? No. A simpler and more efficient way to do is you can use the virtualization technique to virtualize your existing laptop and install the Linux operating system on it. Basically, you can use both operating systems on the same laptop. Now, how do we use virtualization techniques to create a virtual machine? Let's understand this animation. Here is your physical computer. This physical computer can be your personal computer, a remote server, or a server in a cloud provider's data center. We use software called hypervisor, which is also known as virtual machine manager. In your case, you can use Oracle VM VirtualBox. The hypervisor will create a software based or virtual version of a computer with desired amount of CPU, memory, and storage. The virtual machine always borrows CPU, memory, and disk from the physical host computer. That means a part of your computer's CPU, RAM, and storage will now work as a standalone computer. To understand it better, assume you have a physical computer with 8 GB RAM, 2 CPUs, and a 40 GB hard disk. You can use a virtualization tool to create two or more virtual machines and distribute CPU, memory, and hard disk between these two virtual machines. Here, we have two virtual machines, VM1 and VM2. They have 4 GB RAM, 1 V CPU, and 20 GB hard disk each, and more important, two different operating systems. As you can see, a virtual machine acts like an actual computer and it has a different operating system. Despite using the same hardware, the virtual machine is completely isolated from the rest of the system. The software inside a VM cannot interact with the host computer or other virtual machine on the same physical computer. The virtual machines run like individual computers with separate operating systems. They remain completely independent from another virtual machine and the physical host machine. As VMs are independent of each other, they are also highly portable. That means you can instantly move a VM on a hypervisor to another hypervisor on a completely different machine. Virtual machines are flexible and portable. They offer many benefits such as cost saving. You can run multiple virtual machines on a single physical host. This can drastically reduce your physical infrastructure cost as you will have to buy fewer physical computers. Agility and speed. Spinning up a virtual machine is a relatively easy and quick task. It is much simpler than provisioning an entirely new physical machine for your developers. That's how virtualization makes the process of running dev test scenarios a lot quicker. Next is lowered downtime. Virtual machines are so portable and easy to move from one machine to another. This means that they are a great solution for backup if the host machines goes down unexpectedly. Scalability. Virtual machines allow you to easily scale your applications as creating a virtual machine is easier than setting up a physical machine. You can simply add virtual servers and distribute the workload across multiple VMs. This is how you can increase the availability and performance of your apps. These are all the benefits of virtual machines. Hello and welcome back. In this lesson, we are going to start with the most common compute service that AWS has to offer. It is the Elastic Compute Cloud, commonly known as EC2. So let's get started. EC2 stands for Elastic Compute Cloud. It provides a scalable computing option in the Amazon cloud. But what is compute capacity? Well, we have already learned that it is nothing but virtual machines, and EC2 is a compute service in AWS. EC2 is scalable. That means you can increase or decrease the size of a virtual machine based on your requirements. And if that doesn't work, you can create additional virtual machines as well. By using Amazon EC2, you can completely avoid setting up the hardware to run your application and can develop and deploy applications faster. Another benefit of using an EC2 is that you do not need to invest in hardware. You can have virtual machines of desired capacity that can be accessed using your normal computers. EC2 is an IaaS, Infrastructure as a Service. Because you rent a virtual machine from AWS and AWS will take care of purchasing and maintenance of hardware. You can get the desired capacity without having to worry about the hardware. It is designed to make web scale cloud computing easier for developers. To understand this, let's go back to the times when cloud computing wasn't there. To host an application, you had to set up a data center or rent a physical server. That's entirely possible for big organizations. But think about mid-sized companies, startups, or even individual developers like you and me. They cannot afford to get the data centers and hardware. But after cloud computing, it became significantly easier for the developers to go and get virtual machines, all thanks to cloud computing. You can use Amazon EC2 to launch as many or as few virtual machines as you need. There is no limitation. If you want one virtual machine, you can get one. If you need 1,000 virtual machines, you can get 1,000 virtual machines. Amazon EC2 makes it easier to scale up or down the virtual machines to handle unexpected loads. You don't need to forecast traffic. You can scale up and scale down virtual machines based on traffic and the popularity of your applications. Amazon EC2 has an auto scaling feature that we will understand later. We can configure auto scaling to increase or decrease the number of virtual machines based on the load on your application. It provides you with complete control of your computing resources and lets you run on Amazon's proven computing environment. As we know by now, EC2 virtual machines are located in the Amazon data center. And since security is very important for your applications, AWS gives you complete control of these servers so that you can secure your application as you wish. There are other ways as well to secure those servers that we will cover in later videos. It supports Mac OS. Recently, Amazon Web Services have also started supporting Mac operating system based virtual machines. So if you need Mac OS based virtual machines, you can also get them on AWS. So students, these are some of the major benefits of Amazon EC2. Welcome back students. In the last video, we understood Elastic Compute Cloud, EC2 and its benefits. We will continue with the same discussion and understand the elements of Amazon EC2. But before we start, let's recap the definition of EC2. It is a virtual machine in Amazon Web Services. But AWS does not call them virtual machines. Instead, it uses some specific terms for the EC2. One of these terms is the instance, which is nothing but an Amazon EC2 virtual machine. So when we launch a virtual machine in Amazon, we say that we launched an EC2 instance. Going forward, instead of calling it an EC2 virtual machine, we will call it an EC2 instance. Another important element in Amazon EC2 is AMI. It stands for Amazon Machine Image, which is basically a template that contains an operating system and additional software needed to launch EC2 instances. Let's make it simple. An EC2 instance is a virtual machine, right? And a virtual machine is similar to your laptop. Let's assume you bought a new laptop. You need to install the operating system and some general software like drivers, browsers, media players, etc., right? Because without these operating systems and softwares, your laptop is just a box. The same is the case with EC2 instance as well. It is also like your computer, and that's why it requires an operating system and additional software in order to use it. In AWS, you can do so by using AMI. So once you launch an EC2 instance, you would want to access it so that you can install your application or do some configuration. So to access your EC2 instance, you need some kind of credentials, and those credentials are nothing but a key pair that we are discussing right now. A key pair consists of a public key and a private key. It is a set of security credentials that you use to prove your identity when connecting to an Amazon EC2 instance. When you launch an instance, AWS asks for a key pair. You can choose an existing key pair or create a new one. When we create a key pair, AWS lets you download the private key and it will keep the public key. So when you launch an EC2 instance, by default, Amazon stores the public key on your instance. Basically, you will use your private key to log into your instance. We will see this when we do the demo of EC2. An important thing to note here is that since you use a private key to log into your EC2 instances, hence anyone who has this private key can also connect to your instances. So make sure that you store your private key at a secure place. Another essential element of EC2 is the security group. This is another service that you can use to further secure your instances. Security group lets you control who can access your EC2 instances. It acts as a virtual firewall for your EC2 instances, which controls the inbound and outbound traffic. Inbound means you can configure who can connect to your EC2 instance from outside, and outbound means what your EC2 instance can connect with. Another element of EC2 is tags. A tag is a label of your AWS resources. It can be assigned by you or AWS, and each tag consists of a key and a value. So when you create an EC2 instance, you can tag your virtual machines with different names. It could be the environment, cost center, owners, or application name. These tags will help you identify your servers when you have thousands of servers running in your account. Each tag key must be unique for each resource, and each tag key can have only one value. You can use tags to organize your resources in your account and to track your AWS costs by using cost allocation tags. Let's understand cost allocation tags. Some organizations used to have a cost center, and when you will be running multiple applications in one AWS account, you can tag EC2 instances with cost center key and value, which will help you track the cost per cost center. So far, these are the different terms and features you need to know and understand regarding Amazon EC2. Let's conclude this lesson here. Hello students, welcome back. In the last lesson, we learned the instance type naming convention. You learned about EC2 instance size, family, generation, and additional capabilities. All these will help you while deciding the EC2 instance type for your application. In this video, we will dig a little deeper and understand different EC2 instance types. Once you successfully complete this lesson, you will be able to decide which instance type best suits your requirements. So let's start with a quick recap of what the EC2 instance type is. It is a combination of CPU, memory, storage, and networking capacity. Having different combinations helps while choosing the appropriate mix for your applications. So when you launch the EC2 instance, instance type is one of the mandatory elements you need to decide. But why it is so important? Let's understand with an example. When you buy a laptop, you first define your requirements, and based on these requirements, you select a configuration for your laptop like memory, storage, graphics, etc. The same goes for the EC2 instance as well. When you launch an EC2 instance in Amazon, you need to provide CPU, memory, storage, and networking configurations. So to make it easy for you, AWS has instance types with different instance sizes in terms of CPU, memory, storage, and networking. Each instance type has multiple size options for different workloads. We have already covered instance size in the last lesson. You should launch instance types that are the best fit for your applications. Now let's understand what we mean by best fit here. So each application is designed differently and they require a specific hardware configuration. Some need more memory, others need more CPU, and so on. Therefore, you should use the appropriate compute capacity for your application. It is easy to select the best configuration for your applications in AWS as Amazon instance types are grouped into families to meet different use cases. We are going to look at 4 basic and essential EC2 instance types. They include general purpose instance, compute optimized instance, memory optimized instance, and storage optimized instance. Let's start with the general purpose instance type. It provides a balance of compute, memory, and networking resources and can be used for a variety of workloads. As its name suggests, this is the most basic and all-rounder AWS EC2 instance type. We use general purpose instances where we are not sure whether the application needs more CPU or memory, because this comes with a balance of memory, compute, and networking. If we find out later that this application is more memory optimized or compute optimized, then we can go for specific types of instances. Now let's have a look at the best use cases of general purpose instances. They are suitable for web servers, caching fleets, and distributed data store applications, as these applications require a good balance of memory, CPU, and networking. They are also suitable for development, test, and demo environment applications. The next instance type is compute optimized instance. They are ideal for compute bound applications that benefit from high performance processors. This instance type is optimized for CPU in comparison to other compute powers like memory, storage, and networking. Therefore, the instance type which has more powerful CPUs comes inside this category. Let's talk about their use cases. This is best for applications that need high compute power. The compute optimized instances are well suited for batch processing, media transcoding, high performance web servers, high performance computing, scientific modeling, dedicated gaming servers, ad server engines, machine learning inference, and other compute intensive applications. Next is memory optimized instances. They are designed to deliver fast performance for workloads that require huge memory to process large data sets. These instances are optimized on memory. So here, when we go and look at instance types in the memory optimized category and memory optimized family, they have more memory than storage, CPU, and networking. In other words, memory optimized instance types are optimized for memory over other features. Let's look at their use cases. Memory optimized instances are used in applications such as open source databases, in memory caches, and real time big data analytics. The next is storage optimized instances. Storage optimized instances are designed for workloads that require high sequential read and write access to massive datasets on local storage. They are optimized to deliver tens of thousands of low latency random input-output operations per second to applications. This instance type is optimized at the network side of the EC2 instance. So it supports more read and write actions to the disk. When our application does a lot of reading and writing to the disk, database, or network, we should use a storage optimized instance type. This instance type maximizes the number of transactions processed per second for input-output intensive and business critical workloads. Transactions per second means the number of transactions the network can process in a second. If the EC2 instance is able to complete 10 transactions to and from storage without any delay, you can say that the instance can process a max of 10 transactions per second. Let's look at its use cases. The application has medium-sized data sets that need high compute performance and high network throughput. These include relational databases including MySQL, MariaDB, PostgreSQL, and NoSQL databases including KeyDB, ScyllaDB, and Cassandra. This instance type is also ideal for workloads that require very fast access to medium-sized data sets on local storage such as search engines and data analytics workloads. It's so much information. Let me summarize it so it will help you to make the best decision on the instance type. The most important thing is to understand these four main classifications, and once you understand these, it will serve your most common use cases. Also, while selecting any instance type for your application, ask yourself whether your application does memory heavy work or it's compute heavy work. Does it need high IO work or it's just the generic work it will do? Once you have an understanding of the main classification, the sub-classification can come naturally. Like in a memory optimized instance, you may need higher RAM or higher optimized memory. At last, once you know the instance type, you should always choose the smaller size instance to run experimentation. Based on the experiment and test, decide on the actual instance size. As a thumb rule, always choose a smaller instance size which saves money. That's all for this lesson. Hello students, welcome back. In this video, we will launch our first EC2 instance via the AWS console. We will also look at the different steps and features AWS offers while launching the EC2 instances. By the end of this video, you will be able to launch EC2 instances through the management console. So watch the video till the end and then try it yourself. Let's go to the AWS management console. Type EC2 in the search bar and click on the EC2 search result to go directly into the EC2 dashboard. As you can see, I have no instances in my account. If we click on instances here, it will take you to the instance page. This page contains the list of all instances in this region. Since we don't have any instances, the list is empty. So let's launch our first EC2 instance. First thing, please make sure you choose a region that is close to you or your customer. Since I am in India, I will select the Mumbai region. Let's click on Launch Instances. First, we have to choose an AMI called Amazon Machine Image. So here we have a list of AMIs to choose from. It has Amazon Linux 2, Mac OS, Red Hat, and many more. If you look at the dashboard on your left, you will see other options. Let's go to My AMIs. Here you will see the list of your own custom-made AMIs. As of now, we do not have any AMIs created in our account. So we cannot see any AMIs listed here. The next option is AWS Marketplace, where we have thousands of AMIs created by third-party vendors. Then we have community AMIs, which are developed by AWS and its users. They are free for everyone to use. Please note that you should always be careful when using AMIs created by people other than AWS or trusted AWS vendors. There could be security holes in them. There is also a filter to show free tier only. This will show us only the free tier eligible AMIs if we check it. For the purpose of this demo, we will create a Linux EC2 instance with Amazon Linux 2 AMI. This AMI is free tier eligible, which means that we will be able to launch the instance without spending any money on this. So select Amazon Linux 2 and it will take us to step 2. Choose an instance type. Now, as you can see, we have many instance types available. Just scroll down and you will see a long list of instances. We have an option to filter these instances based on their family and generation. We have varieties of instances based on different requirements. The list includes instances with RAM optimized, CPU optimized, GPU optimized, and so on. In this demo, we will use T2 point micro because we don't have any special requirements and we also want to stay in the free tier. And as you can see, T2 point micro is the only instance available for free. In some regions, you will see T3 point micro as well. If you are just practicing, make sure that you always choose the free tier eligible instance type to avoid any code. We can now go ahead to review and launch our instance immediately just by clicking here. But before doing so, let's go to Configure Instance Details. This will open up a whole lot of options. Let's explore some of the important parameters one by one. The first option is the number of instances. If you require more than one instance, you can change this and create multiple EC2 instances with the same configuration. We can also launch an EC2 instance in Launch into Autoscaling group by clicking the link Launch into Autoscaling group. For now, let's stick to one instance. This is something we will cover in the next module. Next, we have the network option to choose our VPCs. Let's choose the PatCup VPC that we created in the previous lab. Select the subnet where we want to launch the instance. Since we want our instance to be accessible from the internet, we should choose a public subnet. The next option asks us if we want AWS to assign a public IP to this instance. Let's leave this enabled for now. The next important parameter is the role. This role is used to give permissions as to who can access this EC2 instance. Let's select the role we created in our first lab. In case you want to create a new role, you can navigate to IAM by clicking on the link Create New IAM Role and then create a role. Click on Next to go to the next page. Add storage. As you can see, we already have one EBS volume selected for us. This is the root volume that holds the operating system and other software for this instance. Let's add a new storage to our instance. Click on Add a new volume. Specify the parameters of our volume. Under the device column, we can see the dev SDB path. It is the path where our volume will be attached. Let's leave it as default for now and move on. In the snapshot option, we can choose to create a new EBS from a snapshot that we created before. Since we have no such requirements, we will leave it empty for now. Next is the volume size. So let's change our volume to 10 GBs. The next column is the volume type. We have all SSDs, HDDs, and magnetic storage to choose from. If we look at the volume type for root volume, you will see that we have lesser options here. This is because only SSDs can be a root volume for an EC2 instance. We do not have the HDD option for the root volume. Coming back to our new volume, let's leave this as GP2, which is the general purpose SSD. The next option is IOPS. As you can see, we have no option to change this. Let's go back and change our volume type. If we choose IO1, IO2 or GP3, we have the option to provide IOPS. This is because IOPS are fixed for GP2 volume at 3 IOPS per GB. Let's understand this. If we select GP2 again, you can see the IOPS are 100, which is more than 3 IOPS per GB. Since our volume size is 10 GB, 3 times 10 means we should only have 30 IOPS. This is because we have a minimum of 100 IOPS for GP2. If we change the volume size to say 100 GBs, you can see that we have 300 IOPS now. Let's change the size back to 10 and choose the GP2 volume type. The next option is throughput, which will tell us the throughput of our volume. I will cover throughput in the EBS screen. We can change this for only one volume type, the GP3 volume type. The next option is the delete on termination checkbox. This is the option where we specify what to do with the EBS volume after the EC2 instance is terminated. So if we have delete on termination checked, the volume will also be deleted when our instance gets terminated. Please remember, if you want your data to remain even after termination on instance, don't forget to uncheck this. For this demo, let's leave it as default, which means that when EC2 is terminated, the root volume will also be deleted. The next page is Add Tags. Let's skip this for now and move on to the next page. Configure security group. The first option is to either create a new security group or use an existing one. Since we have not created any security group in our account, let us create one here. You can change the security group name and description as you want. The next and the most important option is to configure security group rules. As you can see, AWS has already added a default SSH, that is Secure Shell Security Groups. This group allows us to SSH into our EC2 instance. But why do we still have a warning? That's because if you see the source column, this SSH rule is open to all IP addresses. This is an issue. Let's change this value to something like 123.123.123.123 and the warning disappeared. Since we have no mission critical systems here, let us change it back to 0.0.0.0 by 0. It is not the best practice to allow SSH from any IP in the world. So if you have production EC2 instances, make sure to change this value to your own IP address range. Let us add a new rule to allow HTTP connections to our instance. As you can see, choosing HTTP fixed our protocols to TCP and port to 80, which is the default HTTP protocol and port. We want everyone to be able to make HTTP connections to this instance. So we will leave source as default here. The last column is to add a description to the rule. Let's not add any rule here. Now that we have configured the security group of the EC2 instance, let us move on to review and launch. You can see all the parameters for our EC2 instance here. Click on Launch. Now we need to specify a key pair. Since we don't have any existing key pair for our account, let us create one. Choose to create a new key pair and add a key pair name. For our example, we will name the key pair Packed Up. Click on the Download key pair. You will see that a .pem file is downloaded. It is important to keep this file safe as this will be needed to access our EC2 instance. Also remember, it cannot be downloaded again. Click on Launch Instance and that will take us to the final page. If you click on the View Instance, you will see AWS is creating an EC2 instance for you. The whole advantage of the cloud is that I could launch 100 instances like this in just a few clicks. Cloud computing is very flexible and provides you with quick access to computing power whenever you need it. As you can see, the instance is running now, and if you click on the checkbox, you will find all the instance details, the public IP security groups, health checks, and so on. So whenever you need any details about EC2 instances, this is where you will look for them. If you click on the volumes options from the left dashboard, you can also see the two EBS volumes that we created, an 8 GB root volume and a 10 GB extra volume that we created separately. With this, we have come to the end of this lab. In the next lab, we will install HTTPD on our EC2 instance and see a small HTTPD website. So students, that's how we launch EC2 instances. In the next lesson, we will continue this discussion and see how we can SSH into our instance and so on. Thanks. In the previous video, we created our first EC2 instance and looked at multiple parameters and options while creating the instance. In this video, we will SSH into the EC2 instance using Linux or Mac operating system, install the HTTPD service, and start a test application on EC2. We will also see how to terminate the instance to avoid any unexpected costs. If you are wondering what SSH is, then SSH is a way to control a remote machine using the command line. By using SSH, we can log into the EC2 instance and perform any kind of operations as we do on our laptops. Let's start by going to the AWS console. Now let's type EC2 in the search bar and click EC2 to go directly into the EC2 dashboard. As you can see, we have our instance in the running state. If you remember the previous lab, I told you to preserve the .pem file that was downloaded while creating the instance. Note that without the PEM file, we cannot SSH into the instance, and in case you have lost or deleted the file, you will need to recreate the instance with a new key pair. The next important thing that you should ensure is that your security group has rules to allow SSH on port 22 and HTTP on port 80. Let us find the public IP of this instance. Click on the checkbox here. Now you can see all the details about the selected EC2 instance. Here is my public IP. Let us copy this value. Now let us go ahead and SSH into our instance. For this, you need to open a terminal and type in the command ssh ec2-user@IP address. EC2-user is the default username for all the Amazon Linux AMIs. Let us run this command. As you can see, the command failed with permission denied. This is expected as we don't want anyone to be able to access our EC2 instance just from a public IP. This is where we will use the .pem file we downloaded. We will go to the folder where I have stored the file. Type IS. As you can see, I have my .pem file in this folder. Now we will run the same command, but we will also add the key file. So now the command is ssh-i ec2-user@IP address. So now we are doing the same thing as before, but here we are also telling AWS that we have a key file to SSH into the instance. Click enter. Now we get another permission denied error. This is an important stage and a popular question in AWS exams. Why do we get this access denied? It says warning, unprotected private key file. So when we first download the file from AWS to a Linux instance, it has the permissions 0644 as you can see here. These permissions are too open for a key file. Since your permissions are inappropriate, AWS does not allow you to SSH into the machine. The fix you can run is chmod 0400 packedup.pem. This will change the permissions of the file from 0644 to 0400, which is the appropriate permission. Let us run the same command again. As you can see, the command now ran successfully and we are in the EC2 instance. So the first thing to do when we log into the EC2 instance is run the command sudo yum update. This command will update any outdated packages in the instance if there are any. To install httpd, run the command sudo yum install httpd-y. Now we have httpd installed on our EC2 machine. But we also need to start the httpd service. To start the httpd service, we need to run another command sudo systemctl start httpd. This command has no outputs. Let us check the status of httpd by running sudo systemctl status httpd. As you can see, we have a process running. Let's now go to the EC2 dashboard and select the EC2 instance. We need to copy the public IP address and paste it into our browser. You can now see the default httpd application deployed on your EC2 instance. Let us now terminate the EC2 instance. You can do this by clicking on the instance. Go to Actions. Click on Manage Instance State and terminate the instance. This will terminate your EC2 instance. If you remember, we attached an EBS volume to our instance in the previous lab, which had the delete on termination flag unchecked. This means that even though our instance is being terminated, one of the EBS instances will remain. Let us have a look. In the volumes dashboard, you can see both the root and the additional volume. If you refresh, in some time the root volume, which was 8 GB, disappears from the list, but we still have the 10 GB volume in the dashboard. Let us go ahead and delete the EBS volume as well. Let us now check the security group. As you can see, even the security group we created has also not been deleted. Let us not delete it. Security groups are free of charge, so there is no harm in having a security group handy for our upcoming labs. Similarly, the key pair packed up has not been deleted and you can keep it in your account without any charges. In this session, we were able to successfully SSH into an EC2 instance, install httpd, and access it from a browser. That's all for this session.
Welcome back. So far in these sections, you have learned cloud computing, a network, virtual machine, and I believe you have very good understanding of these AWS services. Now, this is good time to deploy a real-time application on virtual machine. So, we have one of our application, as I said, our React application. Now, in this session, we are going to deploy this React application in virtual machine. Then we are going to access from the browser. So I have already put a link of this application in the resource section. If you want to try, go ahead, try from there. Now, first things first, to run this application from the virtual machine, so we need to create a EC2 instance. So I have logged into my AWS account. I'm in the Tokyo region, and here I'm going to launch the virtual machine and where we are going to deploy our application. So first thing first, let's go ahead and launch the instance, and I will give here the name, my React app. So it will be hyphen my React app, and here I'm going to use the Ubuntu operating systems. So again, you can select another if you want. And if you use the different, let's say Amazon Linux too, then you need to use a different system tool to install the software, right? Because here we are going to install different softwares, right? Utils. So you need to use IAM or something, you need to decide, correct? And you already know all those, and we understood very well in the Linux section. So I'm selecting Ubuntu and I scroll down, and for the AMI is fine. Instance type, I'm going with the T2 micro, perfect. And I'm going to select existing key pair Linux VM I have created. This is on my local machine, so I'm going to do SSH using this key. Then I've selected the default network. So here I will recommend, as we already covered networking, so please go ahead and create a network for yourself, okay? Public network, private network, and then launch this instance in the public network. So I'm going to use the default network from this region, and here you see auto assigning public IP is enabled, and this is needed, so please do that. Scroll down, then this is going to create the default security group for me, and where I'm expecting SSH access because I want to log into the VM, right? And second, as I'm going to install React application, then I'm going to access this application on port 80, and for that I need to enable HTTP traffic as well. So I have selected this, and that's pretty much. And let me click the launch instance, and it will take a couple of seconds, and it's going to launch instance for me. And once it will launch, okay, it's launched, let's click here, and now we need to do SSH to this particular VM, and then we are going to install the different software to run our React application. Let me select this. We see the public IP address, our DNS, all looks good. Click connect here, and I'm going to do SSH, and I have this key, so let me copy this, and you have to make sure you change the permission of the key. I have already did, but again I will show you. So copy here, key is in my download. I'll go ahead and paste this command. So what this command do, this command change the permission of this PM key, and you already know this, right? We covered in the Linux section. And now I want to SSH. For that I will copy this command and let me paste here, and it's very simple, right? SSH, then -i. I'm passing the key. Ubuntu is the username, and this is the DNS name, public DNS name of the VM. Hit the enter, and we need to give yes for the fingerprints, and it will log in to me in the VM. Right now you see I'm in the VM. So let me clear the screen, and now we are going to follow some documentation to install our application. So let me scroll down here. So as I said, this is a React application, so for that we need to install Node.js. So first things first, I will go and do the sudo apt update. So it will go ahead and update all the Ubuntu package. So this is best practice. When we are using any operating system, we have to make sure the all packages system utils are up to date. So this command is doing its job. And then next we are going to install the Node.js. So I'll copy this command, and then I will run it from here. So we need to wait, and once we do that, then we're going to verify the Node.js using this command, then npm using -v command. So Node.js is the programming language runtime that what we are going to install. Then npm is the package manager for the Node.js. So when we use this command, so here you see sudo apt install, then -y means yes, go ahead and install it, because we don't want to give yes confirmation, right? Then Node.js and npm. So Node.js and npm, these two software we are going to install it, correct? So all looks good here. Let me clear the screen and paste this, and this is going to install this two software, and this is going to take some time. And as I said, it's going to take some time. Meantime, let me explain you some further commands. So here what we are doing, we are installing Node.js and npm. Then we are going to install the nginx, and you know what is nginx, right? Nginx is the web server. So we want to serve this application, this React application, with nginx web server. So for that we are going to install the nginx, and then once we install the nginx, then we are going to start it, and also we are going to enable it, right? And you know this command enable basically enable the nginx. So whenever we are going to reboot our this virtual machine, then it's going to make sure nginx is also up and running, right? Then we will check the status from here, very simple command. And after that we'll go ahead and check if we are able to access nginx from our virtual machine public IP address. Well, now we see Node.js and npm got installed, so we can quickly check here the version. So node -v, and now we see node version 18.190.1 installed, then simple npm -v, and now we see npm is also got installed. So we are quite good here. Now next scroll down, and now we are going to install the nginx. So let me copy this and go to command prompt and hit the enter. Again, it's going to take a couple of seconds to install it. Now okay, we'll run all these commands. Okay, so once this will be done, then we are going to clone our application. So we'll clone our application, and let me little bit minimize this so we can see if this is running. Okay, it's got installed once again, perfect. Now let's run these two command I have already explained to you. Well, now we are going to check the status of the nginx. Let's paste here, and this is working completely fine. Now let's go ahead and see if nginx, we are able to access nginx from the browser. So here either we can copy, okay, the public IP address, or maybe DNS from here. Okay, let me copy this and we can test from here. So http, then let me paste this, and well, now we see nginx is working fine. So this is quite good. Now next what we are going to do, we are going to clone our application. So we can either, you can use this command, or you can go ahead from here and clone the code from here, copy it, and let's go here and let me close this. And you see ls, we don't have anything here. Git clone, let me paste this. Is going to clone our application. Then we will do ls. We now see application is here. Clear the screen, cd my react application. Let's go to our documentation, scroll down, and now here, okay, we are going to install all the dependencies of the application. So as I say, npm is the package manager. So in this application, if you do ls -l, so here we have the package.json, and here if you do the ls -package.json, here we see all the software on which this application is depends. Okay, so these are dependencies, so all this need to be installed. So here as a DevOps engineer, you don't need to worry. All these steps what you see over here, this will be given by the application developer. If something is not working, you can go ahead, ask with application developer, and they will help you out. So let's run this, and this is going to install all these libraries on this virtual machine. After that, our next command is build the React application. So once this will get installed, we want to build this application, and for that we are going to run this command. And what it will do, it will build the production ready static file of this application in build folder. Okay, so this is still installing. Once it will done, I will show you. And then that build, what's going to build, this is we are going to move in the var www.html directory from where we are going to run our application. And so this is the specific directory from where we run our application, right? So application need to be put some specific directory. So this is where we are going to run our application. Let's go and check here. All looks good. Now let's go ahead and build the application. Run this npm run build, and it will take again a couple of seconds and it will be ready. And then okay, as I said, after that what we are going to do, we are going to move our application, this build, where in this folder, right? So then we have to make sure there is nothing is present in this folder, right? So for that we are running this command. So but yeah, I will show you. Let me copy here, we'll see if something is there or not. And it's got clear. Let me clear the screen. Now if you see ls-l, you will see build here. So actually build folder was not there, and what is present here, we can also see ls-l build, and now you see we have all these application files are here. Anyways, let's clear. Now do ls-l and paste this. So we wanted to check what we have. So here we have this index.nginx debian html. So currently what you see here, so this file is coming from here. This is coming from here. Okay, now we want to remove this because we want to place our application and application index file, correct? So for that we're running this command, not this command. Let's copy it. So if you go here, this command, let me copy it, I will explain, and paste this. Running sudo rm-rf means delete everything from var www.html. We deleted everything here. Let me clear the screen. Let's go to our documentation, and now here what we are doing, we are going to copy -r means recursive everything from the build folder to this path. Okay, let me copy this and paste here, and it's done. Now we can check it. ls-l, then var, it will be /var www.html. now you will see all file and directories got copied over here, correct? Now here we need to change permission of this folder. Let me show you what is permission of this folder, and this is very, very important, right? Again, you understood in the Linux section, when we are running any application, then folder should have the right permission, right? So ls-l, here see what we have in the HTML. You see this is folder, right? And this folder has root group, this owned by the root group, and user is root, right? So this is not ideal permission to run any application with the root user. So what we are going to do, for that we are going to change permission to www data group and www data user. Okay, so let me copy this and paste here. It's got changed. Now again, if you run this command, you see this got changed, right? So www data is the group and www data is the user. And again we are going to change permission here, okay, with chmod. So let me copy this. You're going to change here. Okay, now this permission is nothing but this permission, right? So this is the directory, then here the user, then groups permission, and this is the other permission, right? So this is what we changed over here. Perfect. Now let's go to the next steps, and all done. Now next things what we need to do, we need to do some configuration in the nginx configuration. Okay, and what we are doing here in this file, we are going to do some changes. So let me show you what is present here. So let's do ls ls, and this is the file. So this is the path, this is the path, and this is the file default. Okay, this is default nginx configuration. We see we have so many things here, so we can go ahead and change this. But what I'm going to do, I'm going to replace all the code of this file with this code, so basically what we are doing here, this code, we are saying, okay, so nginx is running on the port 80, then it will serve all the file from here with the index file. Okay, so this is nginx configuration. So let's go ahead and run this command. Now it's appended all these codes there. Now let's check it here. Now you see all configuration changed here, right? So all good. Let me clear the screen. Let's go to the next steps, and now let's start the nginx, because we have changed the configuration of the nginx, right? And that's pretty much. Now hopefully we will be able to access the application. So this is the command. If you want to get the public IP of your virtual machine from here, we can get it. This is IP address, right? So let's copy it, and of course we can go ahead get it this from our AWS management console from here, right? We know this is the public IP. Now let's go ahead and refresh this and see if this is working, and wait. Again, we can also check from the public IP address. So http, and please use http, not https. Okay, paste the IP. Now we see our React application, right? Our React application is working perfect. So now you see here we have run our this application from the virtual machine. So now our React application is live. So that's pretty much I wanted to cover in this session. What I want in the next assignments, I want you to run our mini project application. So let me show here. So this is our mini project, right? Sorry, this is our mini finance application, and this application we have already run as a static website, correct? Now I want you to run this application from the virtual machine, and here you have to figure it out how you are going to run this. So this is your next assignment. Thank you so much. See you in the next lesson, and hopefully you are going to deploy this application. And if you are stuck anywhere, go ahead and take help from the chat gpt. And yes, as I said, please give proper information to your chat gpt, and it's going to help you out. And if you are stuck anywhere, please go ahead and ask your question, and you know how to ask question. Please make sure you're asking question right way with proper information. Thank you so much. See you in the next lesson.
Hello students, welcome back. As you know, this module is all about databases, but before we get into databases, we will quickly understand data and its types. We decide on an appropriate database based on the nature of our data. Therefore, it is very important to understand data and its type. So let's begin with data source types. There are three types of data sources: structured, unstructured, and semi-structured. Let's understand structured data first. It is data that has predefined data types and is stored in a specified format. Let's understand the predefined data type and specific format with a phone book example. In this table, you can see that the top row has different names which define what kind of data is present in different columns. For example, the serial number represents the number of data sets we have. The first name column will have the first name of every entry in our data. So this is a format, and if we want to add any other personal detail to this data, then we will have to create a new column for it. Let's say you want to add an address as well. In that case, you need to add an additional header named address, and then only you can add addresses to this data. Basically, this is a specific format. Now let's understand the data types. As you can see that we have numbers in the serial number and phone number columns, and the first name and last name columns have characters. As per the defined columns, you are expected to enter numbers in the serial number and phone number columns and characters in the first name and last name column. That means it is defined what kind of data we can enter into different columns. So, structured data is stored as a series of data values in defined tables managed by a database engine such as MySQL. This data is highly structured, that's why it is very easy to analyze and can be used in highly complex queries. The next data type is unstructured data. Unstructured data has an internal structure but does not contain a predefined data model. Consider a video, for example. It is also data, but the way it is stored is different from structured data. This type of data is usually in the form of files that are stored in a storage such as Dropbox. Dropbox is like a storage unit where you can store text files, photos, videos, etc. The unstructured data as a whole is irrelevant information. Examples of unstructured data are text messages, word processing documents, videos, photos, and other images. These files are not organized. They can only be placed into a file system or object store. If you want to get meaningful information out of this data, you need to process it. You require special tools to query and process the unstructured data. The last data type is semi-structured data. Semi-structured data is a form of structured data. The only difference is that semi-structured data is flexible and can be updated without changing the schema for every single record in a table. This is an example of semi-structured data. As you can see here, there are two sets of data and they look the same, right? If you notice, the second data has one additional information, address. So, semi-structured data allows a user to capture data in any structure as data evolves and changes over time. Semi-structured data is stored in JSON files that are loaded into a database engine such as MongoDB. This data is highly flexible because the structure is not strict and can be changed as needed within the table. You can also analyze semi-structured data. That's all I wanted to cover in this session. Hello students, welcome back. In the last video, you understood three types of data types: structured, unstructured, and semi-structured. As the nature of this data is different, they will be stored differently. In this video, we are going to understand where and how this data will be stored. So by the end of this video, you will know why we store structured data in a relational database. Let's start with an example. We often use an Excel sheet to store data, right? That's because it is easier to organize and manage the data in Excel than in any other tool. This type of data is known as structured data. We discussed this in the last session. Excel sheets are fine for personal data, but if you think about big businesses, that's a different world altogether. They deal with huge amounts of data, which is very challenging to store and manage. When data grows, it often leads to data inconsistency and redundancy as well. Suppose we have a spreadsheet that stores student course registration data. Now take a look at Shyam Singh student. With student ID number 101 is stored more than once. This is called data redundancy. Another problem could be, let's say, Shyam Singh changes his last name. In that case, his last name must be changed everywhere in our data. Otherwise, it could lead to data inconsistency. For small data systems, it could be easier to solve. But when the data system is huge, it is difficult to manage the data. In order to avoid these problems, we use database technology. It is an organized collection of data so that it can be easily accessed and managed. Now let's say you want to send an email to Kishore Das. There is another sheet that holds students' detail like email ID, phone number, etc. From the first sheet, we know that Kishore is in HR, but we cannot find Kishore Das in the student details sheet. This means our data is inconsistent. We can solve this problem with some rules like a student cannot register in the course without registration. This way, we will have all the sheets populated for each student. The point here is that the two Excel sheets have a relation and follow a certain rule to organize data. This is known as relation data, which brings the concept of relational database. A database is an organized collection of related data. It is an organized collection because in a database, all data sets are described and related to one another. Data is organized into relations like table in a relational database. Each table has a set of fields that define the data structure, that is schema, stored in the table. A record is one set of fields in a table. You can think of records as rows or tuples of the table and fields as columns. In this example, you have a table of student data, with each row representing a student record and each column representing one field of the student record. A special field or a combination of fields that determines the unique record is called the primary key. For example, student ID, it is unique for each student. This key is usually the unique identification number of the records. It uses a structure that allows it to identify and access data in relation to another piece of data in the database. As you can see, each student has a unique ID that can be used to find the record of the same student in the student registration. As you see, these data have a certain structure which is known as a schema. Relational databases store structured data. They allow you to rapidly collect, update, and query data using a structured data model. The use of tables to store data in columns and rows makes it easy to access and manage data. AWS offers database solution for relational databases that we will cover in the introduction to RDS module. That's all for this session. Hello students, welcome back. In this video, you will learn about the Amazon Relational Database Service, commonly known as Amazon RDS. So let's get started. Let's have a look at Amazon RDS overview. It is a relational database service that lets you set up, operate, and scale a relational database in the cloud. As you know, managing a database in either an on-premise or EC2 instance is not an easy task. Amazon RDS is designed to minimize the efforts involved in managing relational database tasks such as hardware provisioning, database setup, patching, backups, and etc. You just have to select the database that you want to launch, and we'll have a database ready in just a few clicks. Let's understand with an example. Suppose you have a team of 4 people and you want to launch an application that will be backed by a MySQL database. So you installed MySQL on the EC2 instance. Since we know that it requires a lot of work to set up OS, database, backup, patching, it is likely that the development work might fall behind that could further delay the application launch, as only two people can focus on development. Imagine the same example again, but this time with Amazon RDS. As RDS is a managed service, AWS will take care of all database related work for you, and your developers can focus on application development. RDS was designed to help you reduce the database management cost. It is a managed service that automates the provisioning of databases. AWS will do the patching of the operating system. You will have continuous backups and restore options with a point in time restore. You will also have monitoring dashboards to see if our database is doing good. You can scale the reads by creating a read replica and improving the read performance. You will have a way to set up multi-availability zones to make sure that your application has a plan for disaster recovery in case an entire availability zone goes down. And finally, you can also set up maintenance windows for upgrades and can scale vertically or horizontally. The only thing that we cannot do with an RDS database is that we cannot SSH into your RDS database instance. Now let's look at some features and elements of Amazon RDS. Let's have a look at first RDS availability. Amazon RDS provides higher availability and durability through the use of multi-availability zones deployments. This means that Amazon RDS creates multiple instances of the database in different availability zones. In case of any infrastructure failure, Amazon RDS automatically switches to standby in another availability zones. Database operations will resume as soon as the failover is complete. Since Amazon RDS uses a DNS service to identify the new master instance, you do not need to update your database connection endpoint. That's a very good feature. The second one is RDS instance type. When you build your first Amazon RDS database, you have to make a few key decisions. First, you need to decide your database instance type, which determines your database resources like CPU and memory. It's somewhat similar to the AWS EC2 Instance type. The next is RDS database engine. Next is the kind of database engine you want to run. You can choose from PostgreSQL, MySQL, MariaDB, Oracle Database, SQL Server, and Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud. The database is designed and developed by AWS to provide enterprise-class database performance. Each database engine has its own unique characteristics and features. You can select based on your application and business requirements. Now have a look on RDS pricing. Now, one of the biggest benefits of Amazon RDS is that you pay as you go. The Amazon RDS billing process consists of two parts. Instance cost. The first thing you pay for is the instance that hosts the databases. There are two pricing models, on-demand and reserved. On-demand instance pricing lets you pay for the compute capacity on an hourly basis. This is great when your database runs intermittently or is a little unpredictable. Reserved instance pricing is great when you have a good understanding of the resource consumption of your database. With this type of instance, you can secure a 1 or 3-year term and receive a significant discount over on-demand pricing. Now let's have a look on the storage cost. Second, that you pay for the storage and I by O consumed by your database. Storage is billed per gigabyte per month and I by O is billed per million requests. I hope you have a good understanding of Amazon RDS. Watch the video again if you have any doubts. That's all for this video. Hello students, welcome back. In this session, we will be creating a MySQL RDS instance. We will see what other resources and configurations are needed to spin up an RDS MySQL instance. So let's go to the AWS console. Now type RDS in the search bar. Click on the RDS option and it will take you to the RDS dashboard. The first thing you need to do when creating RDS instances is to create a subnet group. A subnet group is simply a logical grouping of subnets where you provision the RDS instance. Let us go to the subnet groups page by clicking here. As you can see, I have no subnet group in my account. Click on Create DB Subnet Group. Assign a name to the subnet group. You will need to add a description here as it is a required field. I will add subnet group for MySQL DB. Next, select VPC. I have only one and I will choose this one. Here, you need to select the availability zone. Select the availability zones where you want the RDS instances to be deployed. For me, I only have subnets in AP South 1A and AP South 1B. If you have subnets in the other availability zone, you can select AP South 1C as well. Next, we select the subnets in these availability zones. As you can see, I have a public subnet and a private subnet in each of the availability zones. Usually, you would want to create RDS instances in private subnets, so select the private subnets here. RDS instances are usually created in private subnets and accessed from within VPCs. In production applications, you do not want your databases to be accessible over the internet. Now click Create. As you can see, we have now successfully created a subnet group for our database. Let us now create the RDS database. Click on Databases. As of now, I have no RDS DBs in my account. Before we move on to the Create Database button here, if you see next to this button, we have a Restore from S3 button. When we take up backups of our RDS DBs, they are stored in AWS S3. And by clicking on this button, here we can create a new instance from one of our backups in S3. Moving back to creating the database, click on Create Database. The first option you can see is Standard Create or Easy Create. If you choose the Easy Create option, AWS will use some default values for creating your DB. Let us have a look. I have selected Easy Create. Now the only options I have are the database types and some other options here. If we scroll down and open the drop down, View Default Settings for Easy Create, we can see that AWS has hard-coded some values for us. We don't want to create our DB like this. Let us move back to standard creation and choose the parameters ourselves. Click Standard Create at the top. Choose the MySQL engine type. Next, we have the option to choose the MySQL version. I will choose the latest version available for me right now, which is MySQL 8.0.28. The next option we have is to choose the template as per our use case. If you choose production here, AWS will choose some default options for us for simplicity. Like when I have a production template selected and I scroll down to availability and durability, you can see the default option selected for me is to create a standby instance. Now, when I change the template to dev and scroll down again, you will notice that the default value chosen for me now is not to create a standby DB. Selecting a template will simply set some default values for us. Let us stick to the free tier and select the free tier template. The next option we have is the DB identifier. This is the name of our DB instance. You should note here that this is not the name of the database but the name of the RDS instance. Let me change it to the Cloud Advisory MySQL DB. Next, we have to create the master username and password for the RDS instance. Changing the username to RDS master and I will type my password here. We can have AWS auto-generate password for this username here. For now, let me add my own password. The next option we have is to select the instance class for our DB. Since we selected the free tier template, we cannot change the instance types here. As you can see, we only have one option, T2.micro. If we select dev or prod templates, we will get all the instance options here. Next, we have to select the storage type for our RDS instance. The current option we have is the general purpose SSD GP2. We can change this value to IO1 for more complex workloads. For now, let us stick to the GP2 SSD type. We can also enable auto-scaling for our RDS storage. So if this checkbox is selected, we can add the maximum storage we want our RDS instance to scale up to. The default value for this field is 1000 GB. So if my database storage gets filled up, AWS will automatically scale the storage to up to 1000 GBs. The next option is availability and durability. We saw earlier that we had this option when we had selected the dev and production templates. However, this option is not supported in free tier. Next, we have the option to select the connectivity for our RDS instance. We can select the VPC in which we created our subnet group and then select the subnet group in the next option. We have the next option if we want our RDS instance to be accessible outside the VPC. AWS gives us another option here to not allow public access for our DB. Next, we have to specify the security group for our RDS. Let us choose to create a new SG and give it the name RDS MySQL SG. We can see the default port for MySQL database here. Let us leave this as it is. The next option is database authentication. We have three options here and for us, we will be choosing password authentication. If you want more security and control over RDS access, you can choose the other options here. Let us also see the additional options for RDS by clicking this drop down here. The first option is the database name. If you remember earlier, we had the option to add the database identifier, which was the name of the RDS database instance. Here we can ask AWS to create a database like users, employees, etc. Inside the Cloud Advisory MySQL DB, if we leave this value empty, AWS will not create a DB for us and we will have to do that using MySQL commands when we connect to this instance. Let us create a users database for our example. I am leaving the other values as default. Next, we have the automatic backup option. We can choose here how frequently we want to take backups of our DB and even specify the time window for the backup. The next option is enhanced monitoring. This is a popular question in AWS exams. The difference between normal CloudWatch monitoring and enhanced monitoring is that in the case of normal monitoring, RDS gathers the metrics from the hypervisor for a DB instance, and enhanced monitoring gathers its metrics from an agent on the instance. So, if you want OS level metrics, you will need to enable enhanced monitoring. For our use case, we will not select enhanced monitoring option. Now we can choose the log exports. You can have AWS send logs to CloudWatch logs by selecting the options here. We have the next option to allow AWS to do minor version upgrades on our DB and select the time windows for these upgrades. Let us leave these values as default. The final option we have is to enable delete protection. This simple option will not allow us to delete our RDS instance. Click Create Database. Now on the databases page, we can see our MySQL database creating. Let me skip the video till this instance has been created. As you can see, now my RDS instance is created. Let us now click on the instance and see the connection details. In the Connectivity and Security tab, you can see the endpoint and the port of this RDS instance. These values will be needed to access the RDS instance. With this, we come to the end of the session. We looked at all the parameters we have when creating the RDS subnet groups and databases. We created our own RDS database. That's all for this session. I will see you in the next lesson.
Welcome back. So far in these sections, we have understood networking, compute, storage, and database. Now this time to install and configure our monolith application, the Epicbook application, as I have mentioned earlier. So what we are going to do, we are going to deploy this application in EC2 instance, and I'm going to show you. Then I will have assignment for you where you are going to do same. Well, so this is our application, a source code, each and everything is here. And if you go here, then here we have the installation and configuration guide. So that's something you can follow. I'm going to follow same documentation here. So first thing first, what do we need? We need a virtual machine. So let's go ahead and create a virtual machine here. And I'm going to give name of this virtual machine the Epicbooks. And for this virtual machine, I'm going to select Amazon Linux 2 operating system. So let me go here, select Amazon Linux 2. So do remember, this time I'm selecting Amazon Linux 2, not Ubuntu. Okay, so when you are going to do, then you will be using Ubuntu. Now let's scroll down. I'm going to use T2 micro instance type. Again, I'm going to use same key pair, Linux VM I have already created. This is on my local system. And once again, I'm going to use a default network. But again, I'm saying, so I believe you are very confident with the networking and you have your own network. So please use your own network and deploy this in your public subnet. And make sure this instance has the public IP address. So this is enabled. And by default, we need this SSH traffic to our EC2 instance. Also HTTP to access our application. Now that's pretty much a simple configuration of what we need. Let's go ahead and launch this. Your next assignment going to be really interesting because you're going to do a lot of things based on this application. So now this is up and running. Let me open this. And now we need to do SSH. Then we will start installing the application. Then we do the configuration. So click on the connect. And this I don't need to do that because already I did earlier. Let me copy this, go to the terminal and now you see I'm in my download folder because here I have downloaded my key, this linux.vm.py. So let me hit the enter and yes, acknowledge, and I will be in my VM. Yes, now you see I'm on my VM and this is the private IP address. Let me show you. So you see this is our private IP address. So this is what we see over here. Well, now we are here. Let's go ahead and follow the instruction given here to install our application. First things first, what we are going to do here, we are going to install git because we need to clone our application. So let me run this command, and before running this command ideally we should run a yum update to make sure all utilities or packages are updated here, but no problem, is fine as of now. Now I'm going to clone my application. Okay, Epicbooks, and it's going to be pretty straightforward. Clone, and then we need to cd there. I will do the cd the Epicbook. Okay, do ls minus l. We will see our all application source code here. Perfect. Let's clear the screen. Now we are going to install MySQL Server 5.7 on this virtual machine. Well, please try to understand this. So now we know we can create a MySQL in the RDS. You understood very well. But as I said, this is a monolith application. So I'm going to install even MySQL in the same VM, and we're going to access our application and configure our application. Because of that, I'm going to install MySQL on the same VM. So let me follow all these steps. Let's go ahead again, do the yum update. It's very important to do when we are creating, when we have the new VM. And here a couple of commands. We are going to add the repository, Linux repository. So it will go ahead and get the, sorry, it was MySQL repository. So it will download a MySQL software from there. Then we need to disable all MySQL repo version except 5.7. So we want the latest one. Let's do that. All good. Now here we are going to install the MySQL community version server, and this is going to take some time. Then we will start it. Well, so guys, here one thing I'm trying to tell you. So currently I'm installing MySQL on this virtual machine, but in your assignments you are going to use RDS. So this is what I'm going to test your knowledge on that. So for you, you will not install this MySQL on this VM. Your only application will run here, but you are going to use MySQL from the RDS. So that I'm going to test it. And once again, when you create this, then I'm expecting you should have the, okay, before let me run this command again. I will continue our discussion in a moment, and then we need to check the status if MySQL is running or not. Well, MySQL is running fine, like we are quite good, and we need to get the temporary password of our MySQL. So let me get this password, and here this is our password of the MySQL. Let me copy this because we need this, and let me temporarily paste here. And now let's go on our steps. Now next, what we need to do, we need to change this password. Okay, so otherwise we cannot do anything. So simply I'm running MySQL minus u root minus p, and then we need to pass our this password what we copied here. Let me copy this and paste this. Now here from this prompt, now we are going to change the password, and now we are going to set new password. So let me copy this and paste here. It's got change, and now let's check the all available database, and here we see it's all working fine. Okay, now let me do one more things. Here I'm scrolling down, and we need to create the database here for our application. This is bookstore. So let me complete these steps as well here, otherwise I need to come and do it later. Now you see all good, we have bookstore database. Let me exit from here. Okay, again something going wrong. Let me clear the screen. All good. Now let's go back to our documentation. We created the database. Now let's go up, and what we did, we have followed step till here, and all looks good. Now this application, if you go in the technology stack in the readme, so this application is again built on the node.js. Scroll down here, so backend is on the node.js, so we need to install node.js here, right? So for that we have these steps. Let's go ahead, and again this is very simple command. Let me copy all, and this is going to install node.js here. Paste this, and it will take couple of seconds, and this is going to complete it. Now node minus v, we see it's installed at 17.9.1. okay, all good. Let me clear the screen. Let's go back to our documentation, and now again, we need to install the all dependencies for this application. So we're going to use npm install, and that's pretty much. And after that we have a step to create this database. Okay, so here I hope at this stage you are very comfortable with the Linux. You know from which directory, from which folder we need to run which command, right? So if you see here, when you need to create the database, so you need to go to the MySQL prompt. Okay, so for that, basically what you will be doing here, MySQL minus p, right? Then you will be going, then you will be running this command, otherwise this will not work. I hope you are quite clear at this stage. So we have followed that, so we don't need to log in once again. Now what we are going to do, we are going to put some data in our database, and for that we are going to run these commands. So let me copy this, and let's go here and paste here, and again it's going to ask the password. And you know what is our password? Our password is here, new. Let me copy this and again paste this here, because I'm going to use again for the other commands as well. Hit the enter, and this got created. We need to repeat this again for author data sheets. Again, let me do it. Again, is asking for the password. Let me get password from here. Now we have one more book sheets. So again we are putting some data for the books in our tables. Hit the enter. Again we need password. Let me copy password from here. Hit the enter. Now we are all good. Now this done. Now we can run the server, node.js server, and mostly we will be able to access our application. Let's see if all goes well. Okay, no, so we are getting some error because in the configuration file we need to change the password of our database, right? So again here in the troubleshooting you see that, so in the config we need to change the password of our database. So let's go here, open vi config.json, hit the enter, -i, everything is good except this password. This password we need to change it, and now we know our new password. Let me get this password from here. Let's go ahead and change here. Okay, perfect. Now if we run our application, then this must going to run. Is working fine. Now we can go ahead and access this application from the public IP of our VM. So let's refresh this. Okay, maybe let's go here, get the public IP, and here let me type this http and public IP. But one thing here, we need to put 8080, because let's go here. You see our application is running on port 8080, right? And go ahead, hit the enter, but it's not going to work because we need to open inbound and outbound traffic at port 8080, right? So let's go here in the security group of this VM and open the security group, and inbound role, let's add port 80 8080, and from anywhere, and we know security group is stateful, so it's going to maintain the state, so we not need to add outbound rule, and mostly this is going to work. Let's see if this is working. Let me close this. Meantime, we do not need this, we also do not need this, and here we see application is working now, right? So we can go ahead and add the card. It got changed, right? We can add more books over here. It will become 2. Now go and check out, and all working fine, right? Check out, all working fine. Now technically, right, we should not be accessing application at port 8080, correct? So for that, what we can do, we can install web server nginx, right, as a reverse proxy. And let's do that. And for that, again, I have given the all steps here in the documentation. Scroll down. Now let's install nginx for the reverse proxy. So let me copy this command and let's stop here. Now let's run these commands, and after that, again similar, we need to start the nginx, then we need to enable it, then we will check the status, and again, you know, we need to do some settings in our nginx configuration, correct? All good. Now run these commands. Okay, looks like this is not working, right? So let's do one thing. Okay, so basically when we are running any commands, we have to make sure we are running commands one by one and we are checking this. Okay, so let me clear my screen. Let's see if you are getting any error. We'll try to fix it, and this all looks good, no error. Maybe we need to run this command as well. Okay, this is latest one. Run this. Yes, so I think that was the problem. Now after that, we will install the nginx. Yes, do that. Perfect. Now let's install the nginx. And guys, this is very important. So when you are running any commands, make sure command is running. Okay, it should not fail. Just you copy and paste the command, hit the enter, don't read the logs, then mostly it's going to break it, right? So it's ideal to running command one by one, and also keeping close eyes to see if all's going well. So now you see this is working fine, and again enable it, then we will check the status, and nginx is working perfectly fine. Now we need to do the configuration for the nginx, and now here you see we can open the, we are going to create the configuration file with the this name, the epicbooks.conf. okay, and here is written, replace this with your domain name or IP address. Okay, so currently we are going to access this application with the IP address here, right? So we will be creating this with the public IP. So let me copy this, I will show you. Let's go here and paste this, and now I'm going to change this with the IP, and let's go to the browser and copy the, okay, we can copy the public IP from here. Let's go back, select it, scroll down, let me pull it up a little bit and copy, and let's go here, and this configuration file we're going to create with the public IP address, and press I. Now we are going to copy this, now paste this. Let me save this first. Now let me open once again, and here we need the public IP of our server. press I. It could be domain name as well. Now let me get public IP of our VM, paste here, and now application is running on localhost 80 and all looks good. Let's save this, and quickly I wanted to check if configuration is fine. So instead of VI we will use less, and all looks good. Now let's check our configuration, all good. Now we can check the nginx using this command, and if we see success means all good. If there's any error we need to fix it. Looks test is successful, all good. And as we have changed the configuration of the nginx, we need to restart it. Perfect, all good. Now we can go ahead and start our application using node server, right? This command, run this, and it's running perfectly fine. Now we should be able to access our application without giving this port 8080. So open this, let me copy this from here, and http / here. What happened? Okay, I need to put the colon, hit the enter. Looks like it's working. Let's wait a couple of. Perfect. Now we see we are able to access this application from the web server. Again, let's do quick test. One, check out, all working fine. Now what I'm going to do, okay, now we have the domain name for this application, so we're going to map this IP address to the domain. So let's copy this, okay, from here, copy this, and now we are going to test this with the domain name. So what is domain name? The Epicbooks, the Epicbooks here.com. Mostly it's not going to work because we have the wrong IP there. So let's go to root 53. Meantime, let's keep checking here, and domain name, and here we're going to change the A records here, and let's edit this. All done, and actually it's not working. Now refresh this. So mostly it will work, and sometime what happens, DNS updates takes some time, so sometimes we need to wait from couple of hours to even couple of days. Okay, but mostly it's going to work. So let's see here. Well, while it's getting load, let's come to the initial discussion, what I was saying. So in next assignments you are going to deploy this same application, but I want you to create the proper network. So you will have your public subnet, private subnet. In the public subnet you will be creating the virtual machine where you will install the application. In the private subnets you will create the subnets group, and then you are going to create MySQL database from the RDS, and then you're going to get endpoint password from there, and you're going to configure to your application to make it running. So next assignment is going to be very, very interesting, and once again, as I said, please try to complete it, spend some quality time. If you are stucking, that's absolutely fine. If you are not stucking, means you are not learning. And if you get stuck, please go ahead and ask with the chat GPT, take help from the chat GPT. And still if you're not able to fix the problem, do let me know in the Q&A sections with the proper question. Please follow the instruction what I have given to you, and any of from my team is going to help you out. Looks like this is not working. Why is taking that long? Okay guys, so this will not work Because if you remember here what we need to do, so when we created our nginx configuration file, right, that we need to change. So here what we need to do, we need to create the another configuration file with the domain name, right, the epicbooks.com. so let's do that. Copy this. Yes, let's stop here and create this configuration file and hit the enter, and let's copy our this configuration file and paste it, and here will be the domain name, right. So actually we have been not following the instructions, so it's very important we should follow the instruction. So let's put it here. All good, and it's going to work now, and let's start the our application. It's working fine. Now let's test this. Just wanted to make sure we are using HTTP. Okay. Well. Again, we need to restart the nginx as well. Let me close this. Once check the status. Perfect. Now we run the application. Working fine. Now let's test this. Yes, this is going to work. Yes, now we see this is working perfectly fine, right? Let's do the quick test here. Yes, add one more book. One more book. Now check out. Well, perfect. So now here we have deployed our Monolith application on virtual machine, and so in next assignments you are going to deploy this application, and but with the different architecture. So thank you so much. See you in the next session and the next assignments.
Hello students, welcome back. In this video, you will learn what is auto-scaling in AWS, and what are the benefits of using the scaling services. But before we get started, let's see how scaling works in a traditional data center. Well, scaling is reactive and manual in traditional data centers. Reactive scaling means that servers are manually brought up and down as per the changes in workload. That means as the workload increases, we add more servers, and when the workload decreases, we remove the servers. Let's understand this with an example. Suppose there are application servers which are accessed by the users of the application. As the users of this application will increase over time, load on the server will also increase. If the number of users keep rising, there will be a time when your server will reach its full capacity, and there will not be enough memory and CPU to serve the new users. So the administrator of the application needs to monitor server capacity. He can monitor it manually or with the help of any tool. When he sees that the application server has reached its full capacity, he will add a new server and configure the application on the new server again. This process can take some time based on the availability of servers or the availability of server engineers to add the server. Sometimes scaling means buying new servers, and to do so, you will have to get approval from the management, and it can take several months for the servers to arrive. So, as you can see, this is a time consuming process and is not sustainable. Another issue with this process is that once the load on the server goes down, you will have to remove the extra server. Otherwise, it will be running idle. Cloud computing solves all these problems as it is a lot easier to add and remove compute resources depending upon the load on the application. Now, the main question is, how will it happen automatically? Well, it is accomplished through auto-scaling. It is a feature of cloud computing that automatically adds and removes compute resources depending on actual usage and demand. This feature is available only in a cloud environment. Auto-scaling provides flexibility and elasticity to your compute demands. Hence, it is sometimes referred to as elasticity as well. Elasticity means adding or removing compute resources based on uses and demand. If the demand goes up, it will increase the number of resources, and if it goes down, it will remove resources. Auto-scaling ensures a seamless increase in resources when the demand spikes and a seamless decrease when the demand drops. Therefore, it ensures a consistent application performance at a lower cost. Auto-scaling is so efficient that it will only add the resources when demand goes up and immediately removes them when it goes down again. This way, you do not need to keep running the additional resources all the time to match the peak hours demand. Auto-scaling is a general term in cloud computing. Now let's understand what auto-scaling is in AWS. AWS auto-scaling is a service that monitors your application and automatically adjusts the capacity to maintain steady, predictable application performance at the lowest cost. So the key points are that it monitors your application and based on the need, it adds or removes additional capacity to maintain application performance at the lowest possible cost. So how exactly does it monitor your application? AWS Auto-Scaling uses an AWS service called CloudWatch to monitor the application demand, and it raises alarms to scale up or down the resources depending upon your application needs. We will cover CloudWatch in detail in the upcoming module. For now, CloudWatch is a monitoring service and it monitors application metrics like CPU usage, memory, network, and many more. You can set a threshold value and the service will trigger an alarm when it reaches that threshold. For example, if CPU utilization goes beyond 80%, then it will add a server and remove it if it goes below 30%. So auto-scaling uses CloudWatch to monitor the application and based on the requirements, it either adds or removes servers to meet the demand. Now let's look at some benefits of AWS auto-scaling. With the help of the AWS auto-scaling group, we can automate adding and removing EC2 instances to meet the actual demand. This is one of the most important achievements of the cloud. As I mentioned earlier, it brings agility to adding resources and removing resources to meet the customer demand. Hence, it removes all the reactive work of traditional data centers. Another significant benefit is cost optimization. And this is again a big win in the cloud. You do not need to run extra resources to meet the peak demand. It will ensure that you pay for only what is required to serve your customer. You no longer need to pay for unused resources. Last and most important is application performance because it helps you add and remove resources to meet the demand. The application always performs better. Your customer will not face any latency and slowness in the application. So that's all for this session. Hello students, welcome back. We will continue with auto-scaling in this video and understand the elements of EC2 auto-scaling group. So let's get started. So far, you have understood auto-scaling adds and removes EC2 instances. Now let's understand how this works. You need to create an auto-scaling group which will scale Amazon EC2 instances. This is where auto-scaling adds and removes EC2 instances. This means that the EC2 auto-scaling group ensures that you have enough Amazon EC2 instances available to handle the load on your application. And it is done with EC2 auto-scaling group configuration. There are three configurations: minimum size, desired capacity, and maximum size. So based on these configurations, auto-scaling will adjust the numbers of instances within the minimum and the maximum number of EC2 instances. The desired capacity configuration will determine the size of an auto-scaling group. So by definition, an auto-scaling group is a collection of Amazon EC2 instances grouped logically for automatic scaling and management. That's pretty much clear. And this is what we have been discussing so far. An auto-scaling group also enables you to use Amazon EC2 auto-scaling features such as health check replacements and scaling policies. It maintains the number of instances by performing periodic health checks on the instances. If any instance becomes unhealthy, the auto-scaling group will terminate the unhealthy instance and launch another instance to replace it. Another feature, scaling policy, that I will cover in the next session. Now let's understand the auto-scaling group size configuration, as it's crucial to understand from the cloud practitioner certification and interview perspective. Minimum size defines the minimum number of instances that should be running in an auto-scaling group. In this case, we have one. The minimum size ensures that you always have a fixed number of instances running. The auto-scale group will never terminate instances below this number. Desired capacity determines how many EC2 instances you want to run ideally. In this case, we have two. So auto-scaling will try to maintain two EC2 instances all the time. The desired capacity is resizable between the minimum and maximum size limits. It must be greater than or equal to the minimum size of the group and less than or equal to the maximum size of the group. Maximum size is the number of EC2 instances allowed to run. This is the maximum number of instances running in the auto-scaling group. Auto-scale groups will never create more than the maximum number of instances specified. So to summarize, Amazon EC2 auto-scaling group maintains the number of instances and scales automatically. That's all I wanted to cover in this video. Students, welcome back. So far, we have understood that auto-scaling needs auto-scaling group to maintain and scale EC2 instances, right? And this pretty much depends on auto-scaling group configuration, like minimum size, maximum size, and desired capacity. We also understood in the last video that the desired capacity should change based on the load and traffic on your application. Now the question comes, how will this number change? How does the number of instances scale up and scale down? Well, scaling starts with an event or scaling action. It instructs the auto-scaling group to either launch or terminate the Amazon EC2 instances. That's where auto-scaling policies come into existence. So there are different types of auto-scaling policies that are designed for various purposes. So let's understand these. As a note, this is very important topic for exam and interview point of view. So I will recommend paying special attention and making notes. I will also add an additional learning link in the resources section. The first auto-scaling policy is manual scaling, and this is the most basic way to scale your resources. Here, You change your auto-scaling group's maximum, minimum, or desired capacity. Amazon EC2 auto-scaling manages the process of creating or terminating instances according to these updates. If you know when more traffic is likely to flow to your application, you can manually change the size of an existing auto-scaling group. You can either update the desired capacity of the auto-scaling group or update the instances that are attached to the auto-scaling group. The manual scale can be useful when you need to maintain a fixed number of instances. The next is dynamic scaling. In dynamic scaling, we define how to scale the capacity of the auto-scaling group in response to changing demand. It means you can increase the number of instances during the peak demand, also known as scale out, and decrease the instances during low demand, also known as scaling in. Now let's understand with an example. Let's say that you have a web application that currently runs on two EC2 instances. Your goal is to maintain the CPU utilization of these instances at around 50% regardless of application loads. It means you need to add an additional EC2 instance whenever CPU utilization crosses 50%. But you don't know when it will reach 50%. Don't worry, you can configure your auto-scaling group to scale dynamically to meet this need by creating a target tracking, step, or simple scaling policy. Now let's understand these dynamic scaling policies. Step and simple scaling allow you to choose the scaling metrics and thresholds for the CloudWatch alarm that initiate scaling. We will learn CloudWatch in the AWS management module. So you define how your auto-scaling group should be scaled when a threshold reaches a specified number of times. Let's take the same example. Whenever the average CPU utilization of all EC2 instances goes over 50% for 5 minutes, add one EC2 instance to the auto-scaling group. Alternatively, whenever the CPU utilization is less than 30% for 10 minutes, remove one EC2 instance from the auto-scaling group. This is simple or step scaling because we define the trigger point to take action and how many instances to add or remove. You select a scaling metric and set a target value in the target tracking scaling policies. That's it. It is a very easy way of defining a dynamic scaling policy. Now, Amazon EC2 auto scaling will create and manage the CloudWatch alarms that trigger the scaling policy and calculate the scaling adjustment based on the metric and target value. The scaling policy adds or removes EC2 instances to keep the metric at or close to the specified target value. For example, you can configure a target tracking scaling policy to keep your auto scaling group's average aggregate CPU utilization at 50%. Then the ASG will scale automatically to ensure that it stays around that target of 50%. The next is scheduled scaling. Scheduled scaling helps to set up your scaling schedule according to predictable load changes. For example, let's say that every week the traffic to your web application starts to increase on Wednesday, remains high on Thursday, and starts to decrease on Friday. You can configure a schedule for Amazon EC2 auto scaling to increase capacity on Wednesday and decrease capacity on Friday. This is very useful when we know that changes are going to happen ahead of time. So we anticipate scaling based on known users' pattern. The next is predictive scaling. It helps to scale faster by launching capacity in advance of the forecasted load. So the difference is that dynamic scaling is reactive and it scales when the demand arises. On the other hand, predictive scaling scales the capacity based on both real-time metrics and historical data. For example, consider an application that has high usage during business hours and low usage overnight. Predictive scaling can add capacity before the first inflow of traffic at the start of each business day. It helps your application maintain high availability and performance when going from a lower utilization period to a higher utilization period. You don't have to wait for dynamic scaling to react to changing traffic. You also don't have to spend time reviewing your application's load patterns and trying to schedule the right amount of capacity using scheduled scaling. So, predictive scaling uses machine learning to predict future traffic ahead of time. It will look at the past traffic patterns and forecast what will happen to traffic in the future. So, it will automatically provide the correct number of EC2 instances in advance to match that predicted period. It is beneficial when you have recurring on and off workload patterns or applications that take a long time to initialize that cause noticeable latency. Now, let's go back and understand how the autoscaling policy completes the autoscaling process. So, as we know, autoscaling depends on various factors like events, metrics, and thresholds. And based on our requirement, we configured an autoscaling policy. This policy instructs autoscaling to add and remove EC2 instances. So that's it for this session. Hello students, welcome back. So far, we have understood that autoscaling increases and decreases the number of EC2 instances to meet the demand. And as you know, when you launch the EC2 instance, we need to provide some configuration. So we need to predefine this configuration for autoscaling as well. This is what we do with launch configuration and launch template. Let's go ahead and understand this in more detail. So both the launch configuration and launch template define the characteristics of the EC2 instances that we want to launch when the demand arises. AWS introduced launch configuration in 2014, and since then we have been using launch configuration with EC2 autoscaling groups. On the other hand, launch template was introduced recently and it does a similar task as launch configuration. Since the launch template is the latest service, it has some extra features and capabilities to make the job a little easier for us. So let's get started with a launch configuration, then we will move forward to the launch template. A launch configuration is an EC2 instance configuration template where we define configurations of our EC2 instance that we want autoscaling to launch when the demand comes. So launch configuration is the configuration template of EC2 instances that autoscaling will use to launch new EC2 instances. So when we create an EC2 instance either from AWS Management Console or by using AWS CLI, we provide different EC2 instance configurations like AMI ID, the instance type, size, the configuration of the storage which instance uses, and the key pair which is used to connect to that instance. We also define the networking configuration and security groups. They decide the IP address and port from which the instance will be accessible. We can define user data, which is a set of commands or scripts that run while an instance is launched. We can also define the IAM roles, which will be attached to the instance and give permission to access other AWS services. Essentially, this includes everything that we usually define while launching an instance. We can define and save all the settings in the launch configuration, which will act as a template for auto-scaling while launching new instances. Launch configuration is not editable. You define it once and that configuration is logged. If we wish to adjust the configuration of a launch configuration, you need to create a new one and use that new launch configuration. There are some challenges with launch configuration that are improved in the launch template. As we have seen earlier, the launch template is similar to the launch configuration. It provides EC2 configuration, which is used by the EC2 auto-scaling group while launching EC2 instances. Moreover, the launch template can also be used to launch EC2 instances or fleet of EC2 instances directly from the AWS Management Console or AWS CLI. Since the launch template is the latest service, it includes several additional features in addition to the configuration features. Let's have a look at them one by one. It lets us create multiple versions of the launch template through different configurations. We can specify multiple instance types, even instance types, based on instance type attributes like memory, CPU, storage, etc. It has the capability to use both on-demand and spot instances, which further leads to huge savings. It also covers T2 by T3 unlimited features. Placement groups, capacity reservations, elastic graphics, and dedicated host features are available in the launch template, but these features were missing in the launch configuration. It further allows EBS volume tagging and elastic interface. AWS recommends using launch template instead of launch configuration as it offers more architectural benefits. Now let's understand where the launch configuration and launch template fit into the auto-scaling process. If you remember from previous session, auto-scaling depends on various factors like events, metrics, and thresholds. And based on our requirement, we configured an auto-scaling policy. This policy instructs auto-scaling to add and remove EC2 instances. Now, auto-scaling needs the instance launch configuration to launch the EC2 instance, right? So to launch EC2 instances, we use the launch configuration and launch template to provide EC2 configurations to the auto-scaling group. Every time auto-scaling launches an EC2 instance, it refers to the launch configuration which we configure with auto-scaling. That's all for this lesson about launch configuration and launch template. Hello students, welcome back. In the last video, we understood how EC2 auto-scaling would automatically scale up and down your EC2 instances based on demand. In this lesson, we will learn the general concept of load balancing as this will be the foundation for our next video, Elastic Load Balancer. So let's get started. Let's assume you enter into a 5-star hotel for check-in. There are 10 receptionists checking bookings, checking in, and checking out. Most customers are standing in a few lines, which results in an uneven distribution of customers per line, while other receptionists are standing around doing nothing but waiting for customers. Customers are walking in and they have no idea where to go. But if you think about the situation, it would be helpful if we have a host at the entrance. So any customers who walk in needs to know which queue has fewer people and who is efficient, right? Now the customers will be greeted by a host at the door. He will direct them to the appropriate line in the hotel for check-in and check-out. The host keeps an eye on the receptionists and counts the number of people in line each receptionist is serving. Now any new customer will be directed to the receptionist with the shortest line, which is the least backed up. Consequently, there will be even waiting for lines among receptionists, allowing customers to be served as efficiently as possible. Now think about AWS auto-scaling group. You have multiple EC2 instances running the same application. When a request comes in, how does the request know which EC2 instance will handle it? How can you ensure an even distribution of workload across EC2 instances? You need a way to route requests equally to different instances to process these requests. That's where load balancer comes into the picture. It is a networking solution that distributes traffic across multiple servers to improve application performance. Again, this is a piece of software you can install, manage, update, and scale. A load balancer can be installed for two or more EC2 instances, but the problem is the scalability. Let's understand this. You have one load balancer in front of two EC2 instances, and your number of EC2 instances will increase based on load. And especially if you have auto scaling, then there is no limitation on EC2 instances. It can scale from nothing to 100 or even more EC2 instances, right? Now, how will one load balancer handle all requests? It also needs to be scaled, right? That's where AWS provides another service called Elastic Load Balancer. Hello students, welcome back. In this video, we will understand another AWS service which is Elastic Load Balancer. This service works very closely with auto scaling to distribute traffic equally to EC2 instances. So let's get started. What is Elastic Load Balancer? This is an AWS service that is used to distribute the load. It's designed to address the undifferentiated heavy lifting of load balancing. In the previous lesson, you learned about a load balancer that is responsible for the distribution of incoming traffic between available EC2 instances. ELB scales automatically as traffic to your servers changes. If the traffic grows, ELB enables the load balancer to handle the additional load by distributing it. So whenever your EC2 auto-scaling group scales up and adds a new EC2 instance, the auto-scaling service sends a notification to the Elastic Load Balancer that a new instance is ready to handle the traffic. Similarly, when the EC2 auto-scaling group scales in, that means if it initiates the process to terminate an instance, it sends a notification to Elastic Load Balancer. Now, it's ELB's job to stop sending the traffic to the selected instance. After that, it waits for the existing requests to complete. Once all the existing requests get fulfilled, then auto-scaling terminates the instances without disturbing the existing customers. The Elastic Load Balancer automatically routes the incoming application traffic across different instances. It acts as the point of contact for the incoming traffic. So any traffic coming to your application first meets with the load balancer and is then sent to an available instance. It also monitors the health of the running EC2 instances as it sends the traffic requests to the healthy instances only. Alright, as of now, you have learned how Elastic Load Balancer routes external traffic to your EC2 instances. Not only that, but it is also used for internal traffic rerouting. Let's understand with an example of Gmail. Suppose a lot of users are using their Gmail. They open the inbox and then the page acts as a web server. A user compiles the message and clicks on the send button. If we talk about what's happening in the Gmail server, an app server is processing your emails, including storing them to a database, sending them to the respective users, etc. So if more and more users start using Gmail, the number of web servers will also increase. Hence, EC2 auto-scale will have to increase the number of app servers as well. And it should be acknowledged to every web server that a new app server is available to accept the traffic. Now imagine you have potentially hundreds of server instances on both tiers. So we can solve the app server traffic chaos with an internal ELB as well. ELB will direct traffic to the app server which has the least outstanding requests. The web server does not know and doesn't care how many app server instances are running. Only ELB handles directing the traffic to available app servers. This is known as true decoupled architecture. In this architecture, all the computing components completely remain autonomous and unaware of each other doing the instructed task independently. So Elastic Load Balancer is the service we can use in front of a web server to distribute the incoming traffic. It is also called Public Load Balancer. We can also use the Elastic Load Balancer behind the web server to equally distribute traffic to the web server as this is working internally. It is called an internal private load balancer. So students, that's all for this video. Hello students, welcome back. In this video, we are going to understand different types of ELB. So let's get started. AWS Elastic Load Balancing supports 4 load balancers: application load balancers, network load balancers, classic load balancers, and gateway load balancer. Let's understand them one by one. These load balancers work with different OSI models. OSI reference model stands for Open System Interconnection Reference Model. It describes how information is transformed from one software in one computer to another by using a network. This is achieved by dividing the data communication into several layers and giving control over sending data from one layer to another. As its name suggests, application load balancers work at the 7th layer of the OSI model, the application layer. The network load balancer works at layer 4, which is the network layer. The classic load balancer is the oldest and first elastic load balancer service. It is designed to work at both the application and network layers. The gateway load balancer is the newest service in the elastic load balancer family, which works at layer 3 and 4. The next is protocol lister, which means the different protocols where these load balancers can listen. Application load balancer supports only HTTP and HTTPS protocol. The network load balancer handles TCP and UDP protocols. Gateway load balancer only listens on IP. As we mentioned earlier, a classic load balancer can work at both application and network layers. Therefore, it supports both application and network layer protocols like TCP, SSL, by TLS, HTTP, HTTPS. Now let's look at different use cases for these load balancers. The most common use case for application load balancer is for web apps. A web app built on the microservices framework can use ALB as the load balancer before incoming traffic reaches your EC2 instances or the containers hosted for a service. Network load balancer covers the remaining scenarios that ALBs don't. For example, the apps that depend on a protocol apart from HTTP, the time-sensitive apps, the real-time data flow apps, and the apps dependent on streaming audio, video, currency codes, etc. will benefit from using NLB. The gateway load balancer works at layer 3. It makes it easy and cost-effective to deploy, scale, and manage the availability of third-party virtual appliances. The classic load balancer can be used with almost all use cases of application and network load balancer. But as the application and the network load balancer are the newest and are designed for a specific purpose, you use them to get the most out of it. AWS is retiring the classic load balancer on August 15, 2022. So it is not recommended to use. The next is the target type, which means where the load balancer can direct the traffic. It could be EC2 instances, fixed IP addresses, AWS Lambda functions, amongst others. You can simply relate this with the above use cases. The application load balancer supports IP, EC2 instance, and Lambda. Network load balancer supports IP, EC2 instances, and also application load balancer. So it can send traffic to ALB as well. The gateway's load balancer supports IP and EC2 instances. The classic load balancer also supports IP and EC2 instances. We can go into detail in each load balancer, but that is not needed for this course. You only need to remember these 4 types of load balancers, types, protocols, and use cases. That's all for this lesson.
Welcome back. Today we are going to deploy two-tier architecture application in AWS account. It's going to be very interesting. So let's get started. So this is the architecture we are going to deploy in your AWS account. So for that, I believe you must have your AWS account and you will be logging to this AWS account with IAM user who must have administrator permission, because we are going to create all these resources, and to create these resources you need very broad permission. So administrator permission will be good enough. What we'll do here, we will start with networking. So we are going to create virtual private cloud, and within this virtual private cloud we will create two type of subnetwork. One is the public network and another is private network. In public network we will deploy our web server, and here we are going to install our application. Then in private subnet we are going to create a database server where application will store application data. Then we also establish connection between the web server and the application server with help of security group, and we will secure it. And then we'll try to access this application from web server public IP address. And at the end we will map the web server public IP address with the DNS name, and then we will try to access it from the internet. And this is exactly what we do in real-time application. Now I said this is two-tier application because here you see we have web tier, then another we have database tier. So this is layer 1 and this is layer 2. So this is two tier. Okay, so we have application tier and the database tier. Whereas you also had 3-tier application. So what happened? In 3-tier application, we will have the another layer, or you can say another tier. Maybe this could be app server, and because of this is called 3-tier. So basically what happened, your web tier will call app tier and app tier will call the database tier. Okay, so this become 3-tier application. Anyways, now to do this project we are going to follow step-by-step guides that I have created for my AWS mastery program. So this is the solution. We are going to look into that, and this very detailed solution, you see 101 page of the solution we are going to follow here. So if you are here, I believe you have completed all previous topics like AWS accounts, identity and access management, storage, networking, compute, and database, because here we are going to use all this knowledge all together
to complete these assignments. So those are basic building block to complete these assignments. If you have not completed those videos, those lecture, I will recommend please go ahead and complete those, then come back here, so you will get most out of it. With that notes, let's get started. So first things first, as I said, we need to create our networking for this application. But before that, here again, this is again, as I said, this is assignments, is part of my AWS mastery program. So here you need to create your AWS account, and you need to secure your AWS account. For that we have the assignments, then we have to set up budget and alert. So if you're following all those things, then your account is secured enough. So if there's anything out of budget, you get alert. But anyways, coming point to the actual implementation, we are going to start with the networking. So as I said, we are going to create our network, and to create this network, first of all we need to decide where we are going to create this network in our AWS account, and for that we need to select AWS region. So let's go to my AWS account, and here this is my AWS account, and here I'm in my one of AWS account, and this is called Epicbook. And here we need to select AWS region where we want to create this project and deploy this project. And what is important of the region, I have already covered this in first lecture, where I have explained AWS account and global infrastructure. If you have not completed that, once again go ahead and complete that, so you will understand why we are going to select AWS region. Now you see here we have different AWS region, and one of the most important region to use region is that is nearest to our customer. So for this session, I'm going to select Mumbai region. So let's select Mumbai, and then we will go to our networking. To go to our networking, what we need to do, let's go to the documentation, our solution, and in this tab, set up the networking. And here, first things first, okay, before even creating the networking, is very important for us to do the planning and designing of our networking. Okay, so what does mean planning and designing? So in planning and designing, we need to ensure which CIDR block we are going to use. CIDR block means classless inter-domain routing. Again, this is I have explained in very detail in networking session. So please go ahead and watch that. And here we can select different subnets. So for this session, we are going to use /16, means we are going to get around 65,000 IP address. Then we need to understand, we need to decide how many subnet do we need, and for that again we need to select IP address that will be subset of our VPC IP address. So we are going to use this IP address for our VPC. Then for the subnets, we are going to use subset of that will be 10.0.0.0/24, and on that range. Again, if you are confused, again I will recommend go ahead, watch that video, so you will understand. Now we have IP addresses, we know. Then to create VPC, we need to go to the, okay, first things we need to select the region that we have selected. Then to go to AWS VPC dashboard, we need to select here, then select the networking, then click VPC, and then we can create VPC. Let's go to the AWS account, and let's type here VPC. It's loading, and now this is loaded. And now here we see we don't have any resources in this Mumbai region in terms of the VPC and VPC resources. So we can click here to create the VPC, click create VPC, and first things first, we need to select the details of the VPC. We have two options. One is the VPC and more. So this is some automated way and pre-filled details what you see over here, okay? And we are not going to follow that. We are going to create VPC only, and here we will give name of the VPC. So let's give this name epic rates VPC, and again this is very well explained in this documentation, okay? You see, we have to select VPC only, then VPC epic rates. Let's go to the documentation. So I will change this to ensure we are following the documentation, VPC epic rates, and then we need to select a CIDR range 10.0.0.0 slash 16, and then it will be default tenancy and create VPC. Double check the documentation. Okay, name is correct, CIDR is correct. Then scroll down, tenancy will be default and tag will come automatic, and create VPC. We see all things looks good, and create VPC. It will take couple of seconds. Now our VPC is ready. Now let's go back to the documentation. Next we are going to create the subnet. To create subnet, we have to select, go to the subnet tab here, then create subnets. Let's go to the AWS account, select subnet and create subnet. As we know, to create subnet we need to select VPC, because subnet is subset of our VPC network, main network. So we will select our VPC epic rates, and then we will give name, and let's quickly look at the documentation. What is the name here we are selecting? So I'm calling it public subnet 1 epic rates, okay? Then we have to select ability zones, then CIDR range for the subnet, and create subnet. So let's give the name public subnet 1 epic rates. Then let's select the AP South 1. Then VPC block is selected by default. Now we need to select the IP address for our first subnet, and that's something we have seen in documentation. Then give /24, and that's all. Create. So first subnets got created. Then we have to repeat the same steps to create the second subnet, private subnet. Again, steps are given over here, okay? So I will just copy this IP address, so I no need to type there. Let's go again here, create a subnet, select the VPC, then we'll give the name, we'll call private subnet 1 epic rates. Then I will select, again this is private subnet, so private subnet 1, right? That was the public subnet. So again let's select the same subnet, same ability zones, okay? I will tell you in the next project when we'll make this application high available why we are selecting this ability zones and when we select different ability zones. So let's park this question for the time being. Now we selected the CIDR, and let's go ahead and create it. So now if we close this, we'll see we have the two subnets, one the public subnet, one private subnets. Let's go to the documentation, scroll down. Now we have to review the details. All looks good. Now in this screenshot we see there is a multiple VPCs, but we see we have the subnets over here. Scroll down. Now if you have been watched the networking video, we know the subnet which we have created here, saying name as a public subnet and name as a private subnet, they are not either public nor either private, okay? No, they are subnets, okay, but those are public subnet is not public subnet, okay? Now to make this subnet public subnet, we have to do some things. Again, I have explained this in very detail in networking section, okay, networking video. So what we need to do, first things first, we need to set up the internet gateway to the internet to give access of public subnet to the internet. Okay, so how do we do that? Again, all the steps are given over here. We have to go and select the internet gateway and create internet gateway. Okay, it's very simple steps. So let's go AWS account and here internet gateway and create internet gateway. Now let's give this name IGW epic rates and create internet gateway. Is got created. Next step is to attach to our VPC. We have only one VPC. Let's attach it and this part is completed. Now second things what we need to do after that, we need to create a route table for the public subnet. Again, I won't go in the detail. This again very well explained in our networking sections. So let's go in the route table and we see already one route table got created for us, and this will be our private route table. So let's call this private RT for epic rates. So we know this is private route table, and here we are going to create the public route table. So let's give this name public RT for epic rates. Then we'll select our VPC. We have one VPC and create the route table. Next, what we need to do to make this route table public route table, we need to edit the route, and route to what? Route to access to the internet 0.0.0.0/0 where to internet gateway, and we will select the internet gateway what we created and save it. Now following these steps, attaching NAT gateway to this route table, this become the public route table. Now we have created the route table. Now to make this subnet public route table, what we need to do, we need to attach public subnet to this public route table. So we will click here edit subnet association and we will select the public route table, public subnet, and save it. Again, if this is something you are getting confused, so I will say go ahead and watch networking session once again. Okay, I have explained this in very detail. Now let's select the private route table, go to the subnet association. Okay, and here let's edit it and also attach private subnet to our private route table. Now all sets. So let's look at the documentation, and here everything is set as we need. Now review, and everything is done. So here what we have did, we have set up our VPC, one public subnet, private subnet, internet gateway, public route table, private route table, and we associated this respective subnet to the respective route table. So now this is set. When I said set, what does it mean? It means this setup is now completed. I mean this setup is now completed, and we see we have used single ability zone AP South 1A to create public subnet and private subnet. Perfect. Now let's go to our solution document, and here this another steps to create the NACL and security group. We are not going to create NACL, this advanced topic, but we'll create the security group, and these are again part of the networking. Okay, so if you scroll down, you see here security group. So let's create one security group. So by default we have the default security group. When we create any VPC in our AWS account, so we get a default VPC, and technically we should not be using default VPC. So let's create a security group here, and we'll call this web server SC security group. We'll call it allow HTTP and SSH access. Again, if you are getting confused what is HTTP SSH access, I explained this in very detail in EC2 session. So go ahead and watch that and select the VPC. And now
here we want to allow two rules in the inbound. One is HTTP, because we are going to install our application, we are going to access this application on port 80, so we need to select HTTP. From where we want to access, from anywhere. So first rule is set up. Now second rule, we also want to access our EC2 instance for administrative purpose. For that we need SSH. So for that, port 22 is added. From where? So as of now, I'm going to access from anywhere, going to give access for the anywhere. But if you are working for your demo, I will say go ahead and here select my IP address. So by default it will get your IP address. Or if you are working for a company, then select company network. Okay, again this is advanced topic, let's not go there. And create a security group, and we are almost done everything from the networking perspective. Now let's go to our documentation, and now all good. Security group got created. Okay, review it and all good. There are some best practices and everything. Okay, I'm not going to read it here. Okay, but all sets now. Now second is to launch EC2 instance. Okay, again for that all steps are given over here. So I know all those steps, so let me quickly follow it. And again I recommend, if you have not watched the EC2 instance compute session, please go ahead and watch that, because that's very important. I've covered compute in very details. So if you talk about this architecture, so now what we are going to do, we are going to launch this web server, a EC2 instance for the web server, where we will be deploying our application. So let me minimize this. Let's go to the AWS account, and to create a compute we need to go in EC2 service and select EC2. It's loading, and we see we don't have anything running over here other than 3 snapshots, and we have 2 security group. One was default, one we created, and 2 key pair. Okay, so already we have created 1 key pair when I was doing the demo before creating the coming for this recordings. Okay, one is for one of the application. Anyways, now we want to launch EC2 instance. We can click here, launch EC2 instance, and here we'll give name. So let's give this Epic Rates Web Server, and you can add additional tags here. Okay, I'm not going to do that. Again, I've talked this in very detail in the compute session. I will select the AMI. What is AMI? Again, is very detailed. I have discussed in the compute session. I'm going to select Amazon Linux 2, and then scroll down. Here I will select the micro EC2 instance is fall into the free tier. For key pair, I will select the Epic Read. Okay, name is wrong here, but anyways, didn't matter. Let me select that. And for networking, by default I have one VPC, so this got selected, but let me edit here. You see, you can change the, if you have the multiple VPC here, you can also select the subnet where you want to launch this your web server. I want to launch in the public subnet. Also I want to attach auto assign public IP address. Then in security group, I don't want to create security group because we have already created a security group, and we are going to select this web server SC, right? Then for the storage, 8 GB is good enough, and there is some advanced configuration. Let's not go there, it's not needed now, and let's launch this. And whatever step you have seen here, I have explained this in very detail in the compute session. So once again, I will recommend go ahead and watch that. Okay, so it will be easy for you, and you will be able to understand each and every term. Now it will take some time. Once it will be ready, then we are going to connect with it. But meantime, let's look at our architecture. So what we have did here, we have created EC2 instance for our web server. Now let's go to our documentation and see where we are. Okay, so launching EC2 instance, follow all these. then launch EC2 instance. We have done same things. Then select the AMI. What is AMI? You see is completed, explained very in detail in this AWS Mastery program. As I said, this all documentation belongs to the AWS Mastery program. Then yes, select the EC2 instance. Then key pair we have selected. Then we launch EC2 instance as security group. Setup was as expected. Port 22 is open, 80 is open. Why this is open? Again, you see is explained very well over here. Then launch EC2 instance, storage configuration, right? And now we are going to connect with it. Okay, so here is couple of way to connect with it. So let's go there and see if this is ready. Refresh this. Now this is ready. Okay, click on the connect and we can use EC2 instance connect, session manager and SSH and all these options. Okay, so in documentation it's on SSH connection, but here we will use EC2 instance. Okay, why session manager? Again, this is very advanced topic and maybe this is I will cover sometime later because we have another session. Okay, we have another, okay, so we have another assignments given over here. Okay, so that will talk some other times why we should use that. But anyways, let's go back here and go to the AWS documentation, EC2 instance connect, and click on the connect. See if we are able to connect. Sometimes it takes time because EC2 instance was getting initialized and 2x2 check was not passed. You see it's still getting initialized, this 2x2 check, but let's see. Okay, well done, we got connected over here. So let me select that. Perfect, now we got connected. Now let's go to the documentation and we got connected, and these steps we now need to do because we are using EC2 instance connect. If you are using here this option, you select connect this SSH, then you have to follow the rest of the documentation, but just I'm skipping it. Okay, and now what we are going to do, we are going to install the application on this EC2 instance. Okay, and this application is WordPress. Say for this demo purpose we are going to install WordPress, but application is application, right? Is WordPress or maybe any other application. Okay, steps remain the same. Okay, it didn't matter. And if you don't know, WordPress is the CMS software and 80% of the CMS runs on the WordPress. Okay, big applications, big company using WordPress to run their content management system. Okay, so it's very powerful software and you can here do anything from the blogging to setting up the company websites, setting up the e-commerce platforms. Okay, it supports wide range of the use cases. Okay, so when we are setting this WordPress, don't think this is WordPress. Okay, it could be very big application. Again, you have to do some customization once you install it, but here you see installation is the main part. Anyways, now in this documentation we have some common errors. I know what kind of error you get, so again I have documented here. But anyways, and for that again we have the solution and all. But first things first, what we need to do once we connected, we need to run this IAM update to ensure all packages are up to date over here. So let's go here and paste and run it. Looks like everything is updated. Let's go to the next, and next command we are going to run IAM install httpd. So what is httpd? Httpd is the web server that we need to run our WordPress application. So this is what we are installing over here. Now let's go to the next. We install Apache web server. Next step is to start the web server and also check the status. So let's run this command. Now let's copy the next command, and even simply I can go here. I will change this start to status status, and this is running perfectly fine. Now scroll down, we see this was the expected outputs. Okay, from the screen we are quite same. Else we see and then we are ready to, okay, now it's saying go ahead test if this Apache HTTPD is running or not, and for that we need to get public IP address of our EC2 instance. Okay, and here like this, go and run it and ensure you are using HTTP not HTTPS. Okay, so let's go here on our EC2 instance and go back. We'll select here and get this IP address, and let me open the new tab and type HTTP then / and IP address. Now we see Apache HTTPD is running for us. Okay, so all good so far. Now next step is to install PHP and the MySQL. So we have to run this command. Let me copy this and go to our terminal. Let's do the clear and paste the command and see it's running. And now we'll go ahead and copy the next command. We see this should be output. Okay, again this is explain, okay, what packages we are installing and what is used for what. Okay, because you will see here we're running different commands, right? You see different software, so this is explained over here. Anyways, scroll down. Next we are going to install MySQL. Let's copy this, and before that, okay, you have to ensure when you are running these commands, this command is executing as expected. You should not fail it. Sometimes I see just people close their eyes, copy and paste the command. Okay, even something is not working, they feel like, oh, it's working, right? But end result, you're not able to access the application. So ensure when we're running any command, make sure this is running. Now very good example, you see here nothing is got installed here, right? Why? It's saying here we are trying to install MySQL, right? But it's saying this package already got installed when we have installed MariaDB. Okay, this package, okay, in previous command. It's saying it's already installed the latest version. So now check the previous command. Okay, just I use the arrow command. So when you install this software, so MySQL also got installed with the MariaDB. Okay, if you don't know, MariaDB is another flavor of the MySQL. Okay, so that's why I got this message, right? So we need to understand as a cloud engineer, when you are running some command, what is purpose of what and what is happening on the screen. Okay, and if you're new to this, okay, how these commands work, how this is working, okay, so you should, okay, now next step is to, now okay, now we've done everything. Now we need to set up the WordPress. Okay, so we have copied this. Let's go here, cd html www, okay, var www html, and then we need to download the WordPress. So this is the command. Okay, no, so cd, okay, yes, so this is, we are going to get wget to download it, and this downloading, and after that we are going to unzip it, and for that we are going to use this command. Let me copy it. If you go here now, if you do ls, you will see this latest is got downloaded here, right? Let's unzip it, and it will take couple of more seconds, and it will going to unzip this whole application. Okay, now next command is to, we need to go into cd in the WordPress, and we're going to do some configuration here. Okay, so this is still unpacking, but one thing here, if you are confused, okay, what this all command Linux command is, so for that purpose you can check my university. Okay, Praveen Misra in AWS University. So if you type university.praveenmisra.in/learn, you can see all my courses over here. And here this one course, if you see here, Linux for the cloud engineer. So here I have used a real-time application to deploy on AWS account, and I've used all command and explain in very detail. Okay, so if you are struggling with that, you can go ahead and use this course. Okay, you learn all these commands, what I'm running here, and what is meaning of all these commands. Anyways, coming back to topic, let's run the command. Go into the WordPress directory, what is meaning of cd. So those kind of things I have explained on those course. Now what we are going to do, we are going to modify, we are going to create a WordPress config file from this configuration file. So what we are doing, we are copying. cp means copy. Okay, again here all these commands. So to be very honest, to become a successful cloud engineer, okay, you not need to be master in the Linux, but you should have very good understanding of around 40 to 50 Linux command. Okay, and this is what I said I have explained in all these courses, in this course. Okay, but anyways, so now let's copy this, and what we are doing, we are copying this file to this file. Okay, so this is sample file. We are going to create a main file for our WordPress configuration. Okay, so if you go in our EC2 instance, now if you do ls minus al, or maybe if you type double L, okay, sorry, double L, then you see we have this configuration file, right? And this configuration file we are going to copy, or maybe ls minus al. Okay, now you see some, okay, same command. So we see this file is there. So we're going to, from this file we're going to copy, make another configuration file, so that need to be modified. Okay, copy it. If you see, we should have this configuration file wp config, and we need to modify it. But before that, we need to change the permission of this folder with this Apache user and the group, and also we are going to change the permission of this folder. So let's do that and clear the screen. And next we are going to, okay, so all this configuration is done. Now next is to create a database for our application. Okay, and for that we need to go in our RDS dashboard. Now let's quickly recap where we are in the architecture. So here we have launch EC2 instance, and we are installing our application in this EC2 instance. Okay, now we are going to launch this database for our application. Okay, now let's go to our documentation. Is saying go to RDS dashboard, and before we create a RDS instance, we need to create a subnet group. Okay, so let's go to our AWS, okay, AWS account, and here select RDS, and let's open in the new tab, and here you see we have the subnet group. What is subnet group? Again, this I have explained in very detail in our database session. Okay, so please go ahead and watch that if you have not completed. So let's give this name epic reads subnet group, group, and we need to give the description. So this is epic reads subnet group, and let's select the VPC, and here we need to add the subnet. So our private subnet is in AP South 1. Let's select this and go ahead and, okay, select this. Then we need to select the subnet as well. Okay, so here this 10.0.1.0, this one is our private subnet, I remember. Okay, if you don't, you need to go to your VPC, click here VPC. Let's go to the VPC dashboard. So just ensure you are using right subnet. Select this, and this you see this subnet, okay, has this ID, okay, 777, correct, and this IP address. So I have selected because I remember the IP range, so I have used this one. Otherwise you can use this subnet ID, right? So let's go here. Okay, you see 777, this is what I have selected. Let's create it. It's not going to create for you, it's going to give some error. Why this giving some error? You read from here. It's saying subnet group doesn't meet the ability zone coverage requirement because current edged coverage is AP South 1. Add another subnet, at least one more, to make it high available. Okay, again I have explained this in very detail, okay, in database session. So please go ahead and watch that. So what we need to do here we need to create another private subnet. Okay, we need at least 2 private subnet. So it's very simple, we know how to create it. So let's select the VPC and give the name private subnet. Name should be 2, right? Because we have already created 1. Then epic reads, then ability zones will select the AP South 1B because 1 is already in 1A. Second will go in 1B because if one edged AP South 1 goes down, then our application will remain high available. Very important concept, again covered in very detail in the database session. And now IP address will be IP range will be 10.0.0.0 slash, no, it will be 2 here, then slash 24 and create the subnet. So now this private subnet. And one more thing, so what we need to do, we need to add to this the route table. Okay, no, sorry, wrong, we need to add to this in the route table association, sorry, wrong, let me do it this way. Go to the route table, select the private route table and go to the subnet association, and here we want to edit it, we want to add another private subnet as well and save it. Now we have 2 private subnet, okay, associated with our private route table. All set. Let's go to the database once again, and here again select this. Now we have another subnet in AP South 1B. If you select here, now we see we have okay AP1 South A, and here okay. Now this is not selecting, we need to refresh this, and we don't see an option to refresh. So let me deselect all, select AP South 1, AP South B. Okay, let's see if this appears. It's not appearing. What does it mean? It means we need to create from again. Let me copy this. Let's go back here. It's not a refreshing. Okay, so I copied this to save the time. Then this, give the description, this is epic reads subnet group, then select the VPC and we'll select our 2 ability zones, AP South 1A, AP South 1B, and select the subnet. Now we see it appears here, right? So in AP South 1A, this was the private subnet, okay, and AP South B, this one. Again, if you're confused, go ahead here and you can check these IDs from here, okay, ensure. So AD77, I'm selecting right one, so you see AD, right, AD and 77, perfect. All set. Now create, and our subnet group got created, perfect. Let's go back to our documentation, and here now is saying how to create our database. So again, this is very nice documentation to create our database, okay, so you can follow it if you are part of AWS Mastery. But anyways, I know all these steps, so let me do that. So click here, databases, create database, and we'll use the standard one and select the MySQL, and then we will, before that we will select here template free tier, okay, and MySQL version is default, this multiple MySQL version, so let's go with the default one. Then we not need high ability here, database identifier, let it be database 1. So database master user name admin, let the it's auto generate the password. So but this is not recommended for your production workload. And scroll down, we have dbt2 microservice database instance selected. We can also select another one, this dbt4g micro, but it's okay for us. Okay, storage is 20 GB is good enough, and auto scaling not needed. VPC, we have default, this VPC got selected. We have single VPC. Subnet group, again that subnet group, we don't need the public access. And do we need to create the security group? Yes, let's create the security group. And here let's give this epic rates dbsc. Okay, and we'll edit this later, and certificate and all. I think this looks good. And monitoring estimated cost, but here we'll do some advanced configuration. Okay, so let's give our initial database name. So we'll give this WORD WordPress. Again friends, I have explained all these things in very detail in database session, so please, I will highly recommend to watching that. Do we need backup? Not at all. Encryption maybe not needed, but it's recommended for your production and customer applications. Maintenance, auto minor updates, I will untick it. This is a demo purpose. Okay, and that's all. Let's go ahead and create the database. And database creation takes some time. Okay, and he is asking for some another configuration, like for elastic cache and RDS proxy is not needed. Leave it. And here we can get our password. Okay, so let me copy this password and put it in somewhere. Okay, so we are going to use it later. Save, close this, and now if you open this, we are going to get our database endpoint. Okay, so as it's creating, it is going to take some time. But before that, let's go to our architecture and see where we are. So what we did, we have web server, and we have been installing the WordPress application over here. Okay, it still is pending, we are going to follow that. Then we have created our database server, right? And now let's go to our documentation. Okay, Mendem is creating, and see where we are with the documentation. So it's getting created. Okay, select no, all configuration looks good. Okay, nothing is enabled here. Perfect, we did same thing. It's getting created, and in the meantime we will set up the security group for our database. Okay, what does it mean? What we are going to do here? Let's understand from this architecture. So here you see we have this web server, right? And for this web server, we have created this web server security group, right? It means with this security group is acting as a firewall for this web server, right? And we decided who can access our web server with this security group. Same way, we also noticed while creating this database, we have also created a DB security group, right? Epic read DB security group. Now this, okay, now we did all the configuration over here, right? But for this we haven't put any configuration. So here we need to allow inbound rule to let this security group know who can access this database. Okay, so as you see in the architecture, this web server going to access this database, correct? So we need to allow here access of this database from this web server. And again, this is very detailed topic, I won't go in detail. So one good thing, what we can do the security group chaining. So what we are going to do, we are going to allow MySQL access to this DB security group from this web server security group. Okay, this is called security chaining. Okay, so how do we do that? Let's go in our AWS console and let's go to VPC. and let's go to the security group, and now here we see we have DB security group, right? So let's rename this, let's give this DBSC, okay, and this let's give as web SC, web server security group, right? So web server security group is quite fine. We have all inbound rules here. We have already defined who is going to access it, okay, HTTP, SSH, but same we need to do for the DB server as well, right? There is no inbound rule, okay, this already inbound rule, okay, but source is this IP address, this is what we don't need, right? So we're going to modify it. So click on edit, and then let's delete this, okay, let's add the new rule, and here select MySQL Aurora, okay, so scroll down, MySQL Aurora, so we are using MySQL database, so port 83306, and here we are going to use custom, and from where we want to give access of this database to this database security group from our web server security group, okay. So only the EC2 instance or maybe web server which has this security group, okay, that can access our database, okay. So this is called security chaining, and save it, okay. So this is very tightly integration and security layer, okay. Now let's go to the database. We see database got created. Now we also supposed to see endpoint over here. We need this endpoint in our later stage, but let's go and follow our documentation. So we have set up the security group, this all explained over here. Now we are going to configure WordPress over here, okay. But before we configure WordPress, we are going to test if we are able to access. Let me show you. We are going to test here if we are able to access from our web server to our this database, because we have established this security group configuration, right? So for that we are going to follow these steps. Let me delete this. Let's go back to our documentation. We are going to export our database endpoint in our EC2 instance. So now if you go here, this is our EC2 instance, right? This is our EC2 instance, and this is got disconnected, okay. So let me close this, and let's reconnect again, session manager, and connect it. Okay, let me type one command here, history. Okay, I see all the command, perfect. I need this somehow. Now we are going to export our database endpoint here. So let's copy this database endpoint, okay. Here, okay, is set. Let's look at the documentation. Next we are going to connect and test if we are able to connect from our EC2 instance to our database. So as I was saying, now here we are in our EC2 instance, right? So what we are saying, we are going to connect to our WordPress database. So this is database, right? This is database. Where this database is? This database is on our MySQL, okay, where this is the host. This is the host, okay. So we have exported this, and now here going to give username. What was the username of this database? It was admin, right? If you don't remember, go to the database, okay, and if you, okay, we lost here, okay, view the connection details, right? So you see this is the admin is the username, right? So this username what we have setting here, so admin, and what is the password? Password we already copied, but if you don't remember, you see we have copied from here, right? But we can also get it from here, our RDS, okay, this is our database. Let's copy it, go here and paste, and hit enter. Now you see we are in the MySQL. Okay, it means we are in the MySQL. You see, in MySQL, it means we have connected from our this web server to our this database. Okay, so now this connection is fine. Now let's go ahead and follow the next step. Let's go to here. Okay, now here this are additional steps to create the another user in our database. So technically, when you are running a production application, okay, we should not use the same database username like admin what we have used. Okay, so we should create another user. So this is what this step is doing, but this demo, so I'm going to skip this, okay, and exit. Okay, we already did it. Now we are going to configure our WordPress. What we are going to do here in WordPress application configuration, we're going to set up database credentials here, username, password, and the database name and endpoint. So our web server application, WordPress application that's hosted here, it will be able to connect to this database server database. Okay, so that what we are going to do, configure in our WordPress configuration. Okay, so let's put here no. Okay, so that's a mistake. So here we are in the MySQL. We were in the MySQL. We need to exit here. We got exited here, right? So let's do pwd. We are in the not right folder. Okay, here we need to go cd where www.html, right? Here we have the WordPress application, right? Here we have the all configuration. So guys, let's not only just follow the steps but also know what we are doing. So we downloaded our WordPress application where at this pwd. Okay, so again this kind of things I have already covered in very detail in Linux for the Cloud Engineer course. Okay, so if you do ll, so you see the all configuration files are here, right? So we are going to configure this configuration file for the database. Okay, so we already know the command. Open it. If you scroll down here, we see all these details we need to modify here, right? So first things first, we need to modify database name. So what is database name? Database name is WordPress. What is username? I'm going to use admin username. What is password? I'll copy password from here. I can also copy from RDS console. Okay, now what is database endpoint? That's very important. That we can get from our database console, right? This is our endpoint. Copy it. Let's go here, paste it. Now I'm going to save it, and now I remember I did one mistake. This file I supposed to open with the sudo. It's open. Perfect. Let me see it. No, sudo was here. This command was there. Sudo. Perfect. So let's wp config. Okay, config.php. Let's verify our okay, all things are perfect here. Ensure guys this configuration is very important. If you miss any configuration, okay, then you know application is not going to run. Perfect. Now we have to do some small configuration. For that we need to copy this all WordPress salt. Okay, copy here. Okay, then let's go to our EC2 instance. Again we have to open the same configuration and go down, and here we have to delete all these lines and we have to paste what I have copied here. Okay, so here if you have opened this with the vi, then press double D continuous. Okay, without hitting I, okay, and this will get deleted. Now press enter and I, then this command, and again save it. Okay, we have to do on a small configuration here, but if you see, I'm a little bit cautious. I'm not doing all this configuration at one time because there is chance I can miss it. Okay, so I'm doing one by one to ensure I'm missing nothing, and also verifying next time when I'm doing the next configuration. Now you see here, this looks quite good. Okay, now I have to go at end of the file. Okay, and I will again hit int I. Okay, then next arrow, and then insert it, then I will save it. Now we have done all the configuration here. Okay, and all set now. Okay, perfect. Now all set. Now we have to run couple of commands. Okay, install couple of application. One of them is PHP XML. So let's clear the command line, install it. Then again we have to go one command before. Okay, so you see, where is PW? We are in HTML WordPress. Okay, but technically our application on a web server run on HTML, on the HTML. But what we need to do, we have to copy all the application file from WordPress to HTML. I'm going to do here cd. Okay, now we do pwd. We are in HTML, right? In HTML directly. Okay, so now let's again, now we have to do this again, use. Okay, now what we are going to do, we are going to copy all the files from WordPress to our var www.html. Okay, so here do enter. Now if you do ll, you see all configuration got copied over here, right, along with this latest. Okay, anyways, latest is not going to create any problem, but again you can remove from here. Now again we have to change the permission of this HTML, and as we have done a lot of configuration, so now start the HTTPD. Now see the status, status status. Now it's running perfectly fine. Now again restart the PHP FPM. All good. And one thing more I will do here, I will enable our HTTPD. Okay, this command is missing here, so let me enable it. Enable. Okay, something is got created. What does it mean? It means if we restart our web server, then still, okay, then it will also start the Apache as well. Okay, Apache HTTPD. So we need to enable it. If you don't enable it, so when you restart your EC2 instance, okay, then it will be stopped. Okay, so all set now. Now what is saying, now we can go and access our WordPress, and for that we have to use this line. Okay, HTTP, then public IP address of the EC2 instance, then WP admin. Okay, then we have to do the configuration. So let's go here. Let's get the public IP address of our EC2 instance. Reload it. It's saying session is expired, but I hope not. Yes. Select, copy it. I'm opening the new tab. Let's open the new tab and let me bring it here so you can see what I'm typing here. Let me close this. Let me copy the IP once again, and IP once again, open tab, and yes, let me maximize this so you can see. Then http / IP address / wp admin. Okay, now it's loading. Perfect. Now you see here WordPress is ready to install, but sometime, okay, it will take time. Okay, immediately you will try if your instance is very small. Okay, so sometimes it takes time, so don't worry. Okay, you have to wait for that. Now we see this is English, this language what I need, and continue. Here we have to give some configuration. Let's keep this Praveen Misra's blog, and username, let's give this admin. Let me copy this password. Maybe we need it later, not maybe, we need it for the logging purpose. And then email ID, give hello @ Praveen Mishra .in, and install WordPress. I no need to save it. Okay, again here it will again take some times for this installation. We're given this configuration, so what is doing in backend, this is installing the WordPress. Okay, so let's log in over here and give the username admin. Okay, and the password we copied, login it, not save it. Let me make it a little bit bigger. Okay, perfect. Now you see here WordPress is installed. Okay, now you can create the different pages here if you want. Okay, or post. Okay, so let's create one of the new post here. It's loading. I not need this introduction. Type Praveen Misra's blog. Hey, this is my first blog. If you like this video and my work, please do hit the like button, like and comment. How do you like this? And don't forget to subscribe my channel. Subscribe the channel, CHA channel, to get similar video. Perfect. I hope you're following it. Let's publish this. Publish, and you can copy this, also you can view this. Now see, this is running perfect. Okay, congratulations. Now if you go and just use the IP address what you use here, okay, this IP address, you will see our WordPress application is running. This is the default page. Perfect. So now let me put it back to the this tab here. Okay, anyways, let me copy this, close this, and let me open in the another tab. Okay, now let's go back to our documentation. Okay, now we have configured, everything is fine. We also created the first page. Okay, and here is the, okay, now last things what we can do, we can configure domain name to access our application. And no, this is, guys, very important steps. Okay, when you are working for a customer. Okay, so now we are accessing this from my IP address, but if you want to access from the real domain name, how do we do that? Let's go to the AWS console here. Okay, and type root 53. Okay, and I have already domain name, so I will show you. Here I have this domain name, so I will try to open it, edit it, and here I'm going to change this a record. Okay, again, this is very detailed topic. don't, let's go there. Let me quickly set it up here for you and save this. Okay, it got saved. Sometimes it takes some time to DNS get update, but let's try to access it. The Epic books, see if we are able to access. Well done. Now you see we are able to access our application, WordPress application, from this domain name. Guys, if you like this, please hit the like button. Let me in the comment how do you feel it, and subscribe the channel for getting this kind of video. Perfect. Now let's check the documentation, and looks like we are quite good. There's couple of things we can do for the terms of the web, okay, for the our web server security groups. Okay, so let's not follow this. Okay, I'm not going to do that here. And then there's again a lot more things we can do, like securing our EC2 instance. Maybe all these topics I'm going to cover later. Okay, so if you want to hear about all those things, do let me know in the comment section. Again, next video could be on high availability. Okay, how we make this whole application high available. So again, I want to know from you, how did you like it? So that's pretty much for today. So thank you so much. I wish you keep great learning, and see you in next video. Thank you. Welcome back. Today we are going to learn very important skills for the cloud engineer. So if you are following me, what we did yesterday, we have deployed this whole application architecture in our AWS account. So we have started with creating a VPC, then public subnets, private subnet, then we launched web server where we have installed our application. Then we also launched a database for this application. Then we established the connection. Then we use public IP address of our EC2 instance. Then we configured with the root 53, and then we were able to access our application. So what happened this morning, once I wake up, then I was trying to access my application, and my application is not running. So here, see, this is the domain name what we have configured, the epicbooks.com. Now we see it's not running. And again, what I did, I came here and copied this IP address, and then I would try to accessing from here. So maybe it could work. So http / again, this is not working over here. Okay, now what I did, I checked if the IP address is correctly configured with our domain name. Yes, this is. What happened? Yesterday everything was running fine, right? So this is not surprise. This will happen when you work as a cloud engineer, and yesterday we have done everything together, right? So how do we fix it? So these some steps we need to know and we should follow. So let's open first of all the terminal, and this terminal, what we do, we'll try to reach to this domain name and see if this domain name is reachable or not. So for that we are going to type a ping and then the epicbooks.com. Okay, and now we see we are not able to reach to this domain name. So before that, there's two ways, right? One is we start debugging at the domain level, and another we can also debug it at our EC2 instance level, because we know even on this IP address, right, on this web server, we are not able to access our application, correct? So here, even instead of pinging this, we can pick directly the IP address if we see if we are able to reach here. Okay, again, this is not a reach. Okay, so now we see we are not able to see, but one important things we need to know, ping don't work by default. Okay, ping is the protocol that we need to enable on our security group. So let's do one thing to make it work. We'll go on VPC, and we know yesterday we have set up the security group, and this is here in the security, right? Security group, and here the web server, and in the web server we'll go and edit inbound rules, and let's add ICMP. So what ICMP basically do, let me move this here, ICMP before and from the anywhere, and save this. Now let's go to our terminal, okay, and here try to ping our domain name, and now we see this is reachable, we are able to reach, right? Again we can do same for our EC2 instance as well. This is reachable, so that problem got sorted out. Now on this server, right, there was application running, right? So let's see if this application is still running, we are able to access our application, okay? So for that what we do, we'll run curl command, then the epicbooks.com, okay? So if something is running, so what we'll see, we will get the data, what data is over there, right? So let's see if this is correct domain, the epicbooks.com. We see we are not able to get anything from here, okay? Now let's try from this IP address curl, and curl basically gets some data from there, okay? Now we see here we are not able to get any data, so it maybe could be there is something wrong with the server itself, right? So let's close this. Now second thing, so what we do, we can run another Linux command called telnet, okay? Then again run the epicbooks.com. Then on this domain name, right, on port 80 we are running our HTTP server, right, Apache HTTP server. So let's see if something is running. Now we see here is not able to connect, okay? It means maybe server is not running, it's not able to connect. So telnet what do, telnet try to see if something is running on this particular port or not. So looks like nothing is running, let's stop it. So how do we check this? For that we will log into our EC2 instance, right? So let's go to the AWS console, and here is our EC2 instance. So select this and let's connect, and we'll follow the same process and connect here, and let me put it little bit up here. Okay, now we see we are not able to connect. What does it mean? It means there is something wrong in the maybe security group, because we are not able to connect to our web server, correct? And yesterday what we did to access our server remotely, for that we added SSH protocol and the port 22, right? So let's go and see if security group is fine. Okay, here what we see, okay, there's no SSH protocol is here, so maybe someone from my team or someone deleted this, right? So now we need to fix this. Let's open this, and here add the rule, and we add again SSH from where, from anywhere, right? From anywhere, and save this. Okay, now same time let's see here, okay, and now try to connect. If you're able to connect it, just I'm refreshing it, and now we see it's establishing the connection. Now we able to connect it, but before that, if you notice here in web server, again this HTTP security group is also missing, right? So it could be someone deleted this as well. Perfect, now we got some more clue. So now let's go ahead and add another rule, okay? So what was that protocol? That was HTTP and port 80, of course, then from anywhere, and save this. Now we connected with the server, but before that let's go and see if we are able to do curl here. So that was the problem, right? So because of security group, as security group was missing, we were not able to access, we are not able to do curl on our server, because it was nothing was found over there, it was not able to connect, right? So now we fix the security group. Now what is saying, it's able to connect, is connecting, it is trying to get the data from there using curl, but it's saying this nothing is found on the port 80. You see, cannot connect on the port 80. Now it's ensure maybe our server is not running on the port 80, correct? So now let's go to here and we will see here status. Okay, we know this command we use to check the status of our server, and see here nothing is running. Okay, so this is disabled. So let's clear the console, and here we will start our httpd start, then see the status status status. Now this is running. Let's go ahead and run the curl. Now this is able to connect, okay, but we cannot see any data. Still there is some problem. Okay, now let's do the telnet. Okay, we are able to connect but we cannot see the data. There is some problem. Now let's run this. So what telnet is saying, now telnet is saying, okay, we are able to connect, our server is running, but still we cannot see data. Anyways, let's go and again try to see if we are able to get from the browser, if it's able to give something to us. Okay, again on the same IP address, so we know we can check from both places. So this domain name is on top of our IP address, right? So when we are doing some debugging, it's ideal good place to debug at IP level itself. Okay, now we see we are getting a gateway timeout. The gateway did not received a timely response from the server or the application. Okay, again at the this IP we are getting same error. So looks like our server is running, but server is not able to connect to something. Okay, so it's taking a lot of time. So let's go back to our architecture. Okay, so in this architecture, what we see here, we have the web server running on the application, right, on this EC2 instance, and this is working fine. Then to get any data, where is our data? This is a WordPress application, right? And the WordPress application, all default file, all index file, pages what we have created, everything is got stored in our database, right? So maybe web server is running, but when it's trying to connect here, okay, or maybe it's not able to connect. That could be one of the reason. Okay, and other could be maybe there is no data, or maybe this is not running at all, right? So there could be multiple possibility. So see what I'm trying to bring your notice here, attention here. These are the different things we need to think as a cloud engineer. So first things first, what we'll do, let's go ahead and check the security group if you are able to connect from our web server to the database server or not. Okay, this again like our web server security group, is there any changes? So let's go here and again security group, DB security group, and inbound rule, and here we see inbound rules looks quite good. Let me bring it a little bit up. So we see here inbound rule is quite good, is rule is there with this security group, so there is no problem with that. Okay, so now second things coming in my mind, okay, maybe this server is running. Okay, let's go ahead and check if server is running. Let's go here in our AWS console and database, refresh this. We see here our database instance is temporarily stopped. Okay, now we know this database is installed. Now I'll tell you, I got the clue what happened. In my this AWS account, I'm running a script, okay, that what do if when I'm running any resources like database EC2 instance, and I used to give tag there. So if tag is not keep running, okay, then it used to stop the server sometime in the midnight. Okay, and until I will come, I will start it. Okay, so because yesterday I added that tag, so that script stopped my database server here. Okay, so that could be a reason. Okay, now what we'll do, let's go ahead and start it. Okay, it's starting, and then we again check it. But here let me tell you something what happened in real-time customer premises when we work. Okay, this is very real scenarios, and almost with my all customer I worked so far in their development environment, in their sandbox environment. Okay, I have configured, installed instance scheduler. So there is a service called instance scheduler where we can set some rules, and based on that rules, that will go ahead and stop the server if there's no any specific tag, particular tag. Okay, so this is quite common practice that what we follow in the industry. So same thing I did for my account as well, because I have some people work in my accounts. Okay, and sometimes I have got unexpected bill. Okay, so this is a standard process what we do. Okay, so I hope you got some idea what kind of things happen in the real-time customer environment and the scenarios. So it's going to take some time, as we know database always takes some time. So let's wait for a couple of minutes, then we see if this is fixed or we need to do something else to make our application up and running. Okay, perfect. Now we see our database is running successfully. Okay, now let's do one thing. Let's open the browser. Let me bring this browser back here and type the Epicbook and see if this is running, and it's taking some time. It's loading, and meantime also we can, okay, ping. I think that was working completely fine, so you can only check from here. Okay, you can also check with the IP address. Let's go ahead and copy the web server IP address here. IP address, copy it, and let's type this. But we know before that we need to put HTTP as we discussed yesterday, and see if this is running. Now we see this is running, right? Pratibin Mishra blocks, and here this is got loaded. Okay, perfect, super. So here in this session I wanted to just what are the different steps if this application that what we deployed yesterday stop working, and what you should be doing. Okay, there could be one more scenarios here I can introduce. Okay, I can go ahead, maybe delete some data, or maybe I can change the password of the database. Okay, in that case you will get error and database connection error. Okay, so that could be the other problem as well. Again, maybe I can change the security group of the database, right? So these are the different things you should keep in mind when you are working as a cloud engineer. I hope this session was fruitful. See you in the next session. Hey guys, welcome back. Today we are going to continue our session from previous session, where we have deployed two-tier application architecture application in our AWS account. Yesterday we have understood how to debug this application if XYZ reason it stopped working. We looked into security group and also some Linux command like curl, ping, telnet, how to ensure application is running or not running. Then we also look into different aspect of connectivity at database layer as well. We are going to continue this session, and today we are going to make this whole application two-tier application architecture deployment high available in our AWS account. So if you are new to this channel, make sure to subscribe it. Without doing any delay, let's get started. Okay, so this is our application architecture what we have deployed yesterday, and today we are going to make this application high available, and this is going to be the architecture. So what you see here, we are going to make our application high available at each and every layer of our application. So now let's go on our initial architecture and let's understand what is problem is with our current architecture. So let's say in this application, if there is something wrong at our web server, what does it mean? It means your whole application will stop working. Similar, if there is any problem at your database layer, then once again your whole application will stop working. And one of the biggest problem with this architecture is, if you see, everything we have deployed across same availability zone, means if there is anything goes wrong in this availability zone, maybe some disaster or maybe something wrong with the data center itself in the power, electricity, then entire application will go down. So this is not high available at all. So what we are going to do, first things first, in our new application architecture, we are going to ensure our infrastructure, our VPC, is high available. So in previous session, we have created two private subnet, right? And we have one public subnet. So first things first, what we are going to do, we are going to create one more public subnet to ensure our infrastructure, our networking is high available first. Then we look into different layer of this application. We will start with the web server. We'll try to make this high available. And again, we look at the database layer. At the web server layer is making this application high available is not easy. We are going to do a lot of things. It's going to be the great learning. Anyways, let's get started. And first thing first, let's make our network high available. So let's go to my AWS account, and currently I have stopped everything in my AWS account. So nothing is running, as you see. I have stopped because I don't want it to get billed. I don't want it to get billed for that. So we know EC2 instance, we can stop it. RDS instance, we can stop it. Okay, so I've used this feature to stop it, and today I can start it when I need to work on it. Okay, anyways, so this is not needed. We'll see which part of this application do we need. Okay, so first things first, let's go to our AWS dashboard. Okay, and from here we will navigate to our VPC, virtual private cloud. And if you are new to this video or somehow directly coming here, I will recommend please go ahead and watch all previous video from day 1 to day 6, and top of that previous 2-day session where we have deployed this where we have deployed our 2-tier application architecture. So this is mandatory. So let's go to the VPC. So let me type here virtual private cloud VPC. And now this is opening our VPC dashboard. And now let's quickly review our settings. So we have this VPC epic rates, and it has three subnets, 2 private subnet, 1 public subnet. The next, what we are going to do, we are going to create another more public subnet. So we'll select this, and you know how to create it because we have did it together in previous session. So name we will give public subnet 2, then epic rates. Then we'll select the ability zone AP South 1B because our public subnet 1 is in AP South 1A. Okay, so this is again I have explained in very detail in previous session. So this is CIDR of our VPC. Then we need also CIDR for our subnet, and we already used 10.0.0.0, 10.0.1.0 and 10.0.2.0. So next available CIDR in this VPC CIDR is 10.0.3.0/24. Okay, Now let's go ahead and create this. Now if we'll close this, we see we have two public subnet and we have two private subnet. Now as we know, to make our public subnet to public subnet, what we need to do? We need to add this subnet in our public route table. So we will go in the subnet association, and here we will select edit subnet, and we will select, we see already public subnet 1 is part of this route table. We will add public subnet 2 and then we will associate. Perfect. Now let's go back to our architecture, and here we see now our network is high available. So let's go to the original architecture where we have this public subnet and the private subnet, right? Now if we see our this network, so we have two public subnet and two private subnet for the database. So now from networking perspective, everything is good. Now what next? Next, let's start with our web server first. Okay, now what we want to do here to make our web server high available, let's go to our initial architecture. So here as of now we are running one web server, right? So when we are saying high available, what does it mean? It means we want to run multiple copy of our web server to ensure if one web server goes down, other will keep running and keep serving traffic to our end user. So to create any web server and EC2 instance, right, we have to follow certain steps, correct? So what we did in the previous session, when we were creating it, then we went to the EC2 dashboard and we are given all this configuration including AMI, storage, networking, then we created EC2 instance, correct? Now to again create this another EC2 instance, we have to follow the same steps, but this is what we are not going to here, because if each and every time we'll do the same things, then it's going to be the repetitive steps. Okay, this is something we can exclude it. And top of that, on that EC2 instance, let me delete all. On this EC2 instance, it was not just about launching this EC2 instance. After launching this EC2 instance, we have installed so many software. We installed our application and we also did a lot of configuration, right? So if again we need to do same thing for the another server, okay, it's going to take a lot of time. Now what we can do here, we can use AWS AMI feature, Amazon Machine Image feature, and we are going to create copy of this image. We're going to create copy of this image, AMI, Amazon Machine Image, and this will have everything installed. So if you remember in your college time or maybe on your computer, right, we used to take backup of our OS. What does it mean? It means if computer crashed, then we can use this OS to again bring back our laptop back with all software installed. So same things what we are going to do here. So first things first, we are going to create AMI, Amazon Machine Image, out of our existing server to ensure everything is there. Okay, and from that AMI we are going to create another EC2 instance, and this is the great feature of AMI. So now with this AMI we can launch not one, not two, even 1,000 EC2 instances with similar configuration. Perfect. Now let's go to our AWS console, and here we'll go to EC2 dashboard. So type EC2 and let me open in the new tab, and here this is already stopped. Okay, you see in the running instance we have 0 and instances 1. Okay, so if you go here, then we select, then this is not running. You see status check 2 by 2 is nothing. Okay, so it's not running. So ideally when we take snapshot of our instance, we should stop it. Okay, there's some reasons, let's not go on that, but here you see this already stopped, right? Now let's go to the action, then image and template, and click here, then create image. So we are going to click here, and then we have to give some configuration. So let's give this name, sorry, not configuration, some name here. We'll call this our WP application, and we can give some description, running application. Okay, and then scroll down, and by default is taking all the storage configuration from here. Okay, and nothing else. Then here we can create the image, and now this is creating image. It will just take couple of seconds and image will be available, and that's something we can check from our AMI section. If you go here, then we see our WP application. Okay, if you scroll here, this is pending. Okay, so once it will create, it will be available here. Okay, now as you know, this whole project is what we are doing. This is part of my AWS mastery program. Okay, so this is the whole documentation, and I have explained each and everything line by line here, how to create AMI, how to create auto scaling, each and everything I have explained here. This is 29 page of documentation. Okay, so anyways, I'm going to share this document with you. Okay, but I'm not going to follow it because I remember this and I have done multiple times. Okay, so this document I'm going to share with you, so you can use it for your purpose. Okay, along with this video. Anyways, let's go back to the AWS console and I refresh this, and mostly it will be available now. Okay, still this is pending, but no problem. Now let's go back to our architecture once again. So what we did here, now here we have created this AMI, and we know with help of this AMI we are going to create and launch these EC2 instances. Okay, now here we know, because we are going to make it high available, so we are not going to do this instance creation manually. Okay, we are not going to do one by one. Okay, so someone is, or maybe some software is going to do for us. Okay, and for that we need all these steps. So again, let's keep a small pause and try to understand. So when we were creating this EC2 instance for our application, what were the different steps? First we give him the name, then we select the AMI. So that was the base AMI, there was nothing, right? Then we have installed everything. So what we did here, now we have created our own AMI, and now this AMI has our running application. Then we have selected key pair, we have selected the networking, then storage, correct? Then EC2 instance got created. Now here again, to launch this new EC2 instance, we have to do all these steps, correct? So as we want to automate it, then for that what we are going to do, we are going to use another AWS EC2 service feature called launch template. As name suggests, launch template means, so if you want to launch a EC2 instance, and for launching this EC2 instance, we have to give different configuration, right? So this configuration we can define in the launch template. In the launch template, to launch EC2 instance, we are going to create a template, and with the help of this template, we'll be using this or creating this EC2 instance, and then this AMI will be part one of the configuration of this launch template. So next step is to create launch template. Perfect. Now let's go to the AWS console and double check if this AMI is available. And I'm sure it will be available now. We see this is available. Perfect. Now here in EC2 dashboard we see launch template features. So let's click this, and now we are going to create the launch template. And here we have the option to create launch template. Click it here and we will give the name. So let's give this name our to Epic Rates App AMI. So this is our custom AMI. Okay, we give the name. This AMI has working application and its configurations. Perfect. Now here we do again auto scaling configuration, but we are not going to do from here. We will separately, we are going to create auto scaling. Then you can also give the tag for this template, and also we can create this launch template from any existing launch template. But we don't have any existing launch template, so we are going to use this as a base. And next important things we know, to launch EC2 instance we need AMI, right? And for that we are going to use our own AMI which we have created. So here I have the multiple AMI, but we are going to use this WP application, that what we have created. Okay, so now we have selected the AMI, scroll down, and then we can select the instance type. So which instance type we will use to launch the instance from this launch configuration. So that's something we can define over here. So for me, what I'm going to do, I'm going to select T3 medium, but for you, please don't use T3 medium, okay? Because this is not fall into the free tier, and I have some credits, I have some, I can pay some amount, so I'm selecting because I want this instance to be spin up a little bit faster, okay? But for you, you make sure to use T2 micro, okay? We did. Now next things, we can select the key pairs, okay? So we have this key pair here. Then in networking, we can also select subnet, but I'm not going to select subnet here because subnet configuration will select in our auto scaling. But here I want to select the security group from this launch template. So here we know we have already created a security group web server, and again this is going to be the web server, so we are going to use this security group. And if you see the storage, so based on our AMI, it took the default storage of 8 GB. So if you want, we can go ahead and add additional storage if you want, but for this application we really not need it. Then again tag, we can add it, and then this is all. But before that, I want to do one small configuration here. I want to add a small code in the user data. And what is user data? This is I have explained very well in our EC2 session, so please go ahead and watch that. So for that, let's go to our documentation, and here in auto scaling, okay, here we have this configuration. So let me copy it. I'm going to put it here. I will explain what this command is doing. So what this is doing, when it's going to launch any EC2 instance using our auto scaling that we will configure later, so it will make sure it's updating the package, and then it's also restarting the HTTPD, okay, to make sure HTTPD is running, so we'll be able to access our application. So that's all, and let's launch the template. And template creation don't take much time, and it will be available here, okay? Before that, here I want to rename our AMI, okay? So let's rename this, called Epic Rates AMI. Give some meaningful name because we are using for this Epic Read application. Perfect. Now all set here, let's go to our architecture and see where we are. So we have created AMI. Now we have the launch template. Let me remove some of the so many lines we have created here to be a little bit cleaner, and also I can delete from here as well, so it will be a little bit cleaner. Okay, okay, perfect. And this one as well. Now it's a little bit clean to understand, because again we are going to draw something here. Okay, perfect. So idea is we want to launch another EC2 instance. For that we created AMIs, and then this AMI we have used with the launch template, and with this launch template we are going to create this EC2 instance. But we have done some settings. Now we have template. We can go and manually create this EC2 instance. Now this will be a little bit quick, but do we really want to do that? No. Here we will use another EC2 feature. Let me delete this, and this feature is called auto scaling group. We are going to use another AWS feature, EC2 feature, auto scaling, to launch these instances. And auto scaling is going to use this launch template to launch this EC2 instance. So here, if you see, auto scaling is just replacement of, it could be me, could be you, or any system administrator who's supposed to go ahead and launch this EC2 instance. And it has really great feature. Okay, it could launch this EC2 instance even in the midnight, maybe in the morning or the evening, anytime, based on some criteria that I'm going to explain soon. So now what is next? Next is to create this auto scaling group. So this auto scaling group will launch instances for us. Perfect. So to do that, again let's go to our AWS console, and again this feature is available in our EC2. If you scroll down, we see here auto scaling group, right? So let's click here, auto scaling group, and here you can do some readings. Very good document is here. It will help you to understand what is auto scaling, how this works. But for us, let's click here, create auto scaling, and here we have to follow some steps. We are going to do that. Okay, let me bring this is here, and let's start giving the name for the auto scaling. So let's give the name Epic Rates ASG. Okay, and now first thing first, we need to select the launch template. So we'll select this. This is what we have created. Now we can review the all configuration what we have given to this launch template. Okay, and one good thing is that with the launch template we could have the multiple version. So imagine in the previous, not previous, in the current launch template, for this we have used T3 micro, right? And maybe if after some days, if you want to launch this EC2 instance with the new EC2 instance type, so what we can do, we can go ahead and create a new version of this launch template with the new instance type. Okay, so this supports versioning, and this is very great feature of launch template. 2-3 years before, okay, this feature was not available, and for that we were using launch configuration. Okay, so somehow if you know the launch configuration, so now launch template is a replacement of launch configuration, and it has the better feature. Okay, so we can use these features going forward if needed, but for us, for this demo, we have only one version, and that is default one. Now let's go to the next, and here we see instance type requirement. Okay, so here we see based on our launch template, we see the instance type here. Okay, if you want to override this instance type, then you can click here, we can also override here. Okay, but we don't want to do that. We'll go with the launch template defined EC2 instance. Perfect. Scroll down. As I said, here we will select the networking part, right? Because we have not selected in our launch template. So let's select our Epic Read VPC, and here, as we want our application should be getting launched in multiple availability zone, right? So let me scroll down and explain this, because this is very important. Okay, and let's go to the AWS console once again. So here select public subnet 1. Okay, and again we are going to select public subnet 2. What does it mean? It means we are telling auto scaling you will launch EC2 instance in the public subnet 1 and public subnet 2. Why we are doing that? Now let's go to our architecture, and here you see okay, so let me delete this. Okay, because again we need to redraw there, but no problem. So here what we want, so what auto scaling going to do? Auto scaling going to launch one instance over here, it will launch another instance over here. Okay, so if we launch two instances, so it will place one instance in this ability zone and another instance in this ability zones. What is benefit of it? Benefit of it, if XYZ region, this whole ability zones goes down, then still our application will be running because this ability zone is working. So that's why we have to give two ability zone to our auto scaling. Okay, now let's go back, and this is come back here and minimize this. Let's go to the AWS console, and now we have selected our networking. Go to the next. Now next option we see here, load balancing. What is load balancing? Now let's understand this. This is very important concept here. So now in our initial architecture, here we have only one EC2 instance, right? Here we have only one EC2 instance. Then this EC2 instance we have configured with our root 53 domain name, and we were able to access it. Now what you see here, now here we have another EC2 instance, right? Then how do we, and is it possible to add these two EC2 instance public IP address to our route 53? You can do that, okay, but this is not ideal solution. So here, okay, what we are going to do, we need a load balancer. So what is load balancer? As name suggests, this is a software that will balance load on your application. So what will happen here? Okay, let's go to our new architecture, and let's go back a little bit. We delete it here, so it will be cleaner when we come next time to again understand this architecture. Okay, so now if you go here in this architecture, to again understand this architecture. Okay, so now if you go here in this architecture, so now we know we have some sets of EC2 instance here, and again another sets of EC2 instance will be here, right? So technically, even these users accessing our EC2 instance, then they don't know, right, which EC2 instance they need to call. So for that, we need something in between these users and our EC2 instance to balance the load. So basically what we are going to do here, we are going to use the load balancer, and then this request will come to the load balancer, and from here this will get balanced. So some request will go to this EC2 instance and some request will go to this EC2 instance. So this is purpose of the load balancer. And AWS has a service called Elastic Load Balancer because that is elastic in nature. Again, this very detailed topic will not go there. So that's why our auto scaling is asking, do you want to add load balancer here? Okay, for this demo we are not going, okay, now here we are not going to add load balancer now, we'll create it separately. Okay, but yes, we need the load balancer. Now let's go to the next steps. Next step is the health check. Okay, so how auto scaling will know if it's launching EC2 instance, any EC2 instance, this is healthy or not, right? It's need to check the status health of this EC2 instance. Okay, so for that it's going to use EC2 health check. Okay, what is this EC2 health check? So in EC2 dashboard you have seen there was 2 by 2 status check, right? What does it mean? It means one is about, okay, in 2 by 2, one is about if there's any problem in the hardware, then we'll see our instance is not running. Okay, and another is about the software on this EC2 instance. Okay, so if these two things are fine, okay, then we'll see 2 by 2 status check passed. It means our EC2 instance is working fine, there is no any problem. So here this is by default configured, this is always enabled. Okay, so auto scaling will make sure and checks if this 2 by 2 is passing, so it will know, okay, this EC2 instance is healthy. But now one catch here. Okay, so let's say if you go and select the maybe existing load balancer, or maybe you can attach new load balancer. Now if you go here in health check, you see we have additional option to enable turn on elastic load balancer health check. Okay, now if you remember, request is coming to the load balancer, right? And from the load balancer, request is coming to the EC2 instance. Then how load balancer will know which EC2 instance is healthy and which is not unhealthy, right? So EC2 instance also need to understand these instances are healthy or not. Okay, so we can also enable this, and with this it will check these instances are healthy or not. Okay, and for that we have some additional configuration that what we need to do. If you select here, okay, then we have to go and do some additional configuration. Anyways, let's not do here. Let's go back here, go with the no load balancer. Okay, default settings. Then we have some more settings over here, so let it be as it is. Okay, and let's go to the next step. Now next steps is, and most important aspect and the feature of auto scaling is how many instances do we or you want to run in your account or not in your account for this application, right? So for that we have to do some configuration. Okay, so here we see we have 3 configurations. Okay, so one configuration is here desired capacity. So desired capacity means how many EC2 instances you want to run all the time. So this is called desired capacity. Okay, so for these settings we are going to use, okay, let's say 2. So I want to run 2 instances all the time. Then what will be the minimum? Okay, so minimum may be 2, and what could be the maximum? Means when we want to scale, we want to add more instances, when we have the more load, so how many instances maximum it can go? So that's called the maximum capacity. So let's put maximum capacity maybe 4. Okay, now we know this is the capacity of our EC2 instances. Next is the scaling. Okay, not okay, so this was the scaling. Now here is the automatic scaling. So here what you see, this was the scaling, means we are saying 2 EC2 instance will be there. Okay, then minimum 1, maximum 4. Okay, but this is something you can go and add EC2 instance manually in auto scaling. That is the one option. This another option, right? We want to scale, automatic scale it. So this is the feature of the auto scaling, and this is what we want. Okay, so how do you automatically scale these EC2 instances? That's where we use automatic scaling. So you see here we have no scaling policy. Means if you don't want to define, you can manually go ahead, and here instead of this desired capacity 2, once it will start running, you can go and change this 3. Okay, so auto scaling will automatically add one more instance for you. Okay, or maybe after some days you can go again, you can make it 4. Okay, so again it will add another EC2 instance. But this is something you have to do that, right? But you must be thinking, this any way it could be done automatically for you? Yes, that's where we use target tracking scaling policy. Now here what you will see in the target tracking scaling policy, this will get a scale, means new EC2 instances will be get added to our auto scaling based on some EC2 instance performance metrics, and these metrics are average CPU utilization, and we have some more metrics here. So based on that, we'll be able to add more instances. Not auto scaling will add more instances to our for this application inside auto scaling. Okay, so for time being, I don't want to do that. Maybe that we can cover the later. Okay, for time being, we'll do it the manually. Again, there is the more configuration like instance maintenance policies. Okay, let's not go in that detail. Okay, again instance scaling protection, again we can enable it, but let's go to the next step for time being. Okay, now here we have the notification. What is this notification? So if you see here, based on some event type, means when a new instance is getting launched, okay, then if you want to get notified, or maybe on your email ID, or maybe on your phone with the SMS, then we can set up this notification. So what could be the different event you want to get notified? It could be when new instance is getting launched, or maybe instance is getting terminated from your auto scaling, or maybe when auto scaling launching a instance is getting failed, or maybe is getting terminated. So based on this, okay, we can get notified, and for that we need to create the SNS topic and we can configure this, but we not need it here. Okay, let's go to the next. Okay, again you can add some tags here and go to the next and review each and everything and create auto scaling. And now we see here, this is going to launch some EC2 instances for us. Okay, let's select this, and once we select, we see some more details here. Okay, and let me scroll a little bit up, and here we see the activity. In activity we see this is launched to EC2 instance for us. Now let's go to the EC2 dashboard. Now we see we have two running EC2 instances, and now this is getting initialized, right? So our auto scaling is adding more EC2 instances for us. So from auto scaling perspective, this is successful. It was able to launch it, so that's why we see this is successful. Okay, and here we are seeing two EC2 instance is getting launched for us. Okay, now here we can add some scaling policies, that what I was discussing and talking. Okay, then some more configuration you can do here. Anyways, now I was saying, okay, now we see because of our this configuration, desired capacity, minimum capacity and maximum capacity, we have these EC2 instances coming up in our EC2 dashboard, right? So as of now, as desired capacity is 2, right? So that's why we see here we have two EC2 instance. But if you, let's say if you want to make it 1, right, and you want to manually scale in, scale out, so that you can do from here. So let's go here. Okay, and here change this desired capacity to 1. Okay, and update it. And now let's go to the activity, and here we will see, we'll wait for some second and refresh this. What is going to do, it will try to terminate any of these running EC2 instances. And let's go to the dashboard here and refresh here. It's loading. Now we see one instance has gone, right? And if you go here I refresh this. Now you see one instance termination in the progress. Now how this is happening, how this all magic is happening? If you go here in our architecture, and let's see if we are able to bring back our all in sketches what we have did here, right? Yes, it's back now. Now how this is happening here, this auto scaling, this auto scaling, this auto scaling launching this EC2 instances for us, right? And also terminating this EC2 instances for us, the configuration what we have did based on that configuration. Now to launch this EC2 instance, right, this is using this launch template with all configuration. Okay, that's why we need this launch template. Perfect. Now let's go to our high level architecture and minimize this, and here we have created this, okay, auto scaling, right, launch template, everything looks good now. Now what next? Next we want to load balance this traffic, right? Then for that we need this load balancer. Now let's go to our AWS console, okay, and let's go back to our EC2 once again, and here we can launch a load balancer. So we see we have the load balancer option here, okay, and click the load balancer. Now here we can create the load balancer, and here we see we have three types of load balancer. Let's select this, and here I want to show you something. Now let's open this, okay. What is load balancer? Okay, this documentation. Now load balancer has some component. We need to understand this component as a cloud engineer. Okay, what these components are, let's understand this. So we know we are going to create the load balancer, this load balancer, okay, but this load balancer to work, we need target group. We need target group here. So you have also maybe seen these settings here. Let's go in EC2, okay, here, and if we click here, we see here we have option to create the target group. Now let's understand what is this target group and why do we need it. So here what happened when any traffic will come to the load balancer. Now load balancer will send its traffic to some EC2 instances, right? And this EC2 instances is the ultimate target where we want to send the traffic, right? So what we can do, we can create different type of set of instances, okay. Maybe it could be even different set of the applications where we want to send the traffic. Maybe it could be a little bit confusing for you, but don't worry, okay. So for load balancer we could have multiple target group where we want to send the request, and this target group is nothing but collection of EC2 instances. Collection of this target group is collection of our EC2 instances where it will send the traffic, okay. So how load balancer will send the traffic? Load balancer will send the traffic based on some listener rules, okay, that we are going to configure when we configure the load balancer, okay. So before creating this load balancer we need this target group, okay. So let's go ahead and create the target group. Now you understood what is target group, right? So let's go here, and now let's go to the target group instead of load balancer and click target group. So what will be the target for this our application? We know it will be a EC2 instance. It could be also IP address, could be lambda, and could be another application load balancer, okay. But here we know we have already running two EC2 instances, right? If you go here, we have two EC2 instances running. So one EC2 instance is running, right? So this is our target, correct? So let's go here, this EC2 instance, okay, let me bring it here, and then What is target group name? We need to give the name of it. We call it epic reads tg target group. And then on this application, okay, on this target group, we know we'll have this EC2 instance, right? On this EC2 instance, we have a running application, and application is running on which port? This is running on port 80 on HTTP, right? This is what we have configured in previous session, right? So that we need to do. Maybe if this is HTTP or maybe on TCP, TLS, so we have to select the respective protocol and the port over here. But we know for this application we are using HTTP, and that was, this is IPv4, and this IP we are getting from where? From our networking. Anyways, let's not go there. And now again we need to select the VPC where these instances are running, our application servers are running. So it's running in epic rates, right? So protocol is HTTP1. Now scroll down, and here we need to check the health check. Okay, so how it will know application is running, right? So our application is running on port 80 on the slash, or it could be index.php. Currently our application is not running, so we don't know, but anyways I think application is running now on the new instance, right? Let's select this and see. Okay, so now here we see we don't have public IP address, right? So this is missing. Why this is missing? This one things. Okay, so let's fix this. Okay, so you know now. Now let's click here, go to our subnet. Okay, and in the public subnet, when we are launching any EC2 instance, so we want this instance should have the public IP address. Okay, so for that what we need to do, we need to go in the settings and edit subnet settings, and here we are going to enable auto assign public IP address. Okay, and then save it. So this is we did for the public subnet 1, and let's do same for public subnet 2. So what will happen next time when any instances will get launched here, then it will have the public IP address to ensure it has the public IP address, and then you can do our testings. Okay, perfect. Now let me save this. Okay, somehow it's reloaded, not got saved. Save this. Now this is got set. Perfect. Now we know this instance don't have the public IP address. So this sometimes happen. EC2 instance, okay, or AWS management console need to reload it. Now we know this don't have the public IP address, right? How do we need it? How do we get it? So let's do one thing. Now see the magic of auto scaling. We'll go here and select this, right, and edit this. Let's make this maybe 0 again. Okay, let's make it 3. Okay, make it 3, and after some time we'll make it 2. So what it will do, it will delete the, okay, it's going to create, okay, no, let's make it 2. Okay, so it's going to launch one new EC2 instance. Okay, and after that we will come again here, then we will again change it to 1, so it will terminate 1. Okay, now you will see when it will terminate it, okay, something will happen there. Okay, so now we need to know which EC2 instance will be get terminated. Okay, so that's called the termination policy. Okay, so for this termination, AWS follows some rules. Okay, again we need to give all these details here, but no worries. So let's test this first. So let's go to the EC2 instance and see if we are running EC2 instance. So perfect. Now this is launching one more EC2 instance, right? And this will have the public IP address. We see here the public IP address. Let's, okay, but before that let's go and change it again, auto scaling, put it to 1 because I don't want to get charged unnecessarily. Change it, and we're going to change it no. selected the wrong tab. Okay, edit, then this configuration, correct, change it to 1. Okay, and save this, update this, then it will again start terminating one of the instance, and it will terminate the whole EC2 instance. This is some rules. Okay, again this very detailed topics I will cover later. Now go here, go to the EC2 instance and select our EC2, okay, this instance, and copy, and let's see if our application is running over here. Okay, now we see we got timeout. Okay, because we know why we're getting timeout, because database is not running currently. I have a stop database because I don't want it to get charged. Okay, so it means this is working now, right? So now let's go back and refresh this, and okay, one of the instance supposed to terminate from here, it will terminate it. Okay, let's check our auto scaling activities. Okay, so when it's terminate, before terminating it's ensure everything's working fine. Okay, then it's go and it will terminate it. Oh no, actually somehow we have not updated this, right? It's not got updated. So let's edit this and make desired capacity 1. Then let's update this, and let's see if this is number got updated. This number got updated. Now desired capacity is 1. Okay, now let's go on EC2 instance once again, and it will start terminating it very soon. Okay, now you see this is gone, right? Bottom is gone. So anyways, now this is done. Let's go back again to our target group. So let's quickly fill that HTTP, and yes, this was epic reads tg target group HTTP 80. Let's select the VPC and health check. Okay, now I was talking about this timeout, right? So let me show you what I mean here. If you see here, we are accessing this application here on slash, right? So on this we can check the status on the slash, and again you can also check here on slash dot, okay, index.php, because this application has the index file on PHP. So you can put either one, either slash, okay, on slash our HTTPD Apache server is running, or maybe index.php. Okay, so this is where it will check the health of the application. If this is running, it means application is healthy, right? Anyways, let me close this and let's go back here and let's complete this process. Okay, then we can have some advanced health setup settings. Okay, I'm not going to talk here. Okay, so this is some default configuration. Okay, and it has its own meaning, like healthy threshold. Okay, so let me quickly explain this. Healthy threshold means if when this, okay, how load balancer understood this any particular EC2 instance is healthy. So it will check 5 times, and if in each 5 times, consecutive 5 times, it will see health of this EC2 instance is healthy, is passing, then it will assume this is healthy instance. Okay, so it will check 5 consecutive time to ensure EC2 instance is healthy before declaring it this is healthy. Okay, same goes for the unhealthy. Okay, when 2 consecutive time, if EC2 instance health check get failed, then it will declare this EC2 instance is unhealthy. Okay, then you have the interval. How frequently it will check health of the EC2 instance? Every 30 seconds. Okay, and then success. So when it's checking, so success code is 200. Okay, so again it depends application to application. Okay, so this is default configuration, let it be, and go to the next. And now here we need to select our running EC2 instances, right? So here we have this EC2 instance, we'll select it. Okay, and then include here. Okay, so this EC2 instance getting included here in our target group is got added. Okay, now create the target group. Now this target group we have one running EC2 instance, right? Now couple of things here. Now here we see we have 0 healthy instance, right, and 0 unhealthy instance and 1 unused instance. What does it mean? It means this instance is not used as of now, because in this target group, okay, this no traffic is coming, right? It's not able to understand, okay. So what we need to do to make it used, okay, we need to create the load balancer. Once we create load balancer and attach this target group with the load balancer, then this target group know, okay, this is listening to this load balancer, okay, then it will become either healthy or unhealthy based on our this health check configuration what we have did here, okay. Now let's go and create the load balancer. Now before we create load balancer, let's go ahead and start our RDS instance, because starting the RDS instance will take some time, right? We have seen yesterday. So we have one is RDS instance, and this is stopped. Select this and go to the action start, and this is starting. Okay, let's go back and we'll go to the load balancer, go to the load balancing and create a load balancer. And here we have 4 types of load balancer in the AWS. One is network load balancer, application load balancer, then network load balancer, gateway load balancer, and classic load balancer. Classic load balancer not used anymore, okay. So this is got deprecated last year 2022 in the September. But for this application, we are going to use application load balancer. I will create a detailed videos on this load balancers, okay. Let's select this, and here we have to give some configuration, okay. Again, it's very well explained how this load balancer works, so I will recommend please go ahead and read this. This will be very helpful. Anyways, here we'll give name of this load balancer. So let's give this epic rates LB load balancer, and this load balancer could be 2 type, maybe internet facing or maybe internal. But we know this application is web application, and we want this load balancer DNS attached to our domain name. So this is internet facing load balancer. So we'll select internet facing load balancer. If you don't want publicly accessible this load balancer endpoint, in that case you can go for the internal load balancer. There are many use cases we use that, but let's not talk about that. Let's go for the internet facing load balancer, okay. IP address, it will be IPv4 by default, okay. Now let's select the network where this load balancer will get launched, okay. It's a very important topic and complex topic. Let's not go here, okay. So you see in this architecture, our load balancer is somewhere in this public subnet and this public subnet, okay. So we know this load balancer is called elastic load balancer, right? ELB. Either this application load balancer or network load balancer or gateway load balancer, all are ELB, elastic load balancer. It means once we do this configuration, after that our task is done, and AWS will make sure this is scalable. This more traffic, they will create bigger load balancer. If less traffic, it will be a smaller load balancer. So this is elastic in nature. That's why this is called elastic load balancer. So what AWS do? Okay, so we need to tell AWS about where it will launch this load balancer. As this is public load balancer, so we need to give the networking, and in networking we need to give our 2 public subnet details. So that's where it's going to launch our this load balancer, okay. That's why we are selecting the networking there, okay. Let's go back to AWS console and select here. Now it will ask the ability zone where you want to launch this. So we'll know one public subnet is in the AP South 1A, and another is in AP South 1 way. So in AP South 1 way, we see this public subnet got selected by default, so it's good, but this is wrong. We need to change this to public subnet 2. Okay, so in this 2 subnet is going to launch this load balancer. Then again we need to secure our this load balancer, and for that we need the security group. Okay, so we don't need default security group. Okay, and we don't have any security group here, so let's go ahead and create one security group, okay, for the load balancer only. So we'll go here in the VPC and the security group and create a security group called Epic Rates ALB, or maybe load balancer SC. Okay, so we call this is LB, load balancer security group, and we have only one VPC and we need this in this VPC. And what traffic we want to allow? We want to allow which one? HTTP from anywhere, right? And let's go ahead and save this. Perfect. Let's go back here and we will refresh this, and now we will select our Epic Reads LB load balancer, and then listener. What is listener? Where this load balancer is going to listen on HTTP port 80, and when it will listen, where it will send the traffic, right? We have understood from the this design, right, architecture. So on this target group where we have this application running, correct? Now scroll down, we have some tags. You can also add application, okay, web application firewall for the security perspectives. Okay, you can also add AWS global accelerator and many more. Let's skip this. This is for the other times I will cover, and create the load balancer. And this is creating. It will take couple of seconds and our load balancer will be ready. Okay, so select the load balancer, and now here we see this is provisioning, and then we are going to get the DNS for this. Okay, but now meantime let's go to our target group, because target group we want to see this EC2 instance. Okay, how this looks like here, right? Okay, now we see here. Okay, now what I wanted to show you here, we see now it's getting initialized, right? So now this EC2 instance is getting initialized. It was unused initially. Okay, unused initially. So in couple of seconds mostly it will become healthy. Okay, so let's refresh this. It's still getting initialized. It's checking the health, and you know, before it's going to declare this is as a healthy, okay, it's going to check 5 times and interval of the 30 seconds. Okay, meantime now we have started our database. Look at the status of the database. Now this is available. Now I believe if you go to our EC2, now let's go to our EC2 dashboard and get public IP address of EC2 instance and see if this is running. If not, then maybe we need to fix something, but that time we notice it was not able to connect with the database. So I believe that was the problem, but we cannot be sure. Okay, being a cloud engineer, cloud architect, okay, we have to always check if something is running and not running, or what happening over there. Okay, so this is taking some time, so let's wait. And meantime let me close this tab. This tab is not needed anymore. Okay, database is working perfectly fine. Load balancer check. Okay, so it's provisioning. Let's close this, refresh this. So load balancer again takes some time. Now we see load balance is also active, and we should also get the DNS of the load balancer. Okay, so this is the DNS of the load balancer. So let's copy this, and it should also work. Okay, because this is now pointing to our target group. Okay, let me change this to http. Okay, now again here I want to change this to http, and let's wait for some time while it's loading. And now our, okay, this is healthy, load balancer is healthy. Let's see the target group. What is the status of the target group? Okay, still initializing, so we know it's going to take some time, right? Okay, meantime this is getting loaded. Okay, target group here. Okay, we no here, this is still getting initialized, but here we are able to access our application from the IP address. Let me bring it here. Okay, now we see this is working, we are able to access it. Okay, so now application is running fine, but we want to access this application from where? From our load balancer, right? But you see here it's not working, we're getting, is getting failed. Why? Because this is not, health is not get past 8 here, right? Because of that. Anyways, so for that we need to wait here. Okay, let's refresh this. It's still initializing, so yeah, we know it's going to take some time. Okay, perfect. So here we see this is getting initialized. So as I said, this will take some time, but meantime this application is running from our load balancer. Okay, so this is, again, this is something, there is some delay, it takes some time, but we see on this load balancer, right, our application is able to work fine. Perfect. Now this part is done. Now let's go back to our architecture once again. Okay, so you see we have what we have did. Now we have the web server, we have the, okay, now we have this server high available, we have the load balancer, and next we want to add this load balancer to our root 53, and this is something we can do in the next session. Welcome back. So today we are going to continue our previous session where we have started with deploying two-tier application architecture in our AWS account. After that, we started making same application high available at every layer of the application infrastructure architecture. So yesterday we have made our web application layer high available, and today we are going to continue making our database layer high available. So let's get started. Okay, so this is our two-tier application architecture which we have deployed in the previous session, because in between we have multiple sessions. So if you are new to here, I will recommend go ahead and start from the two-tier architecture where we have deployed this application architecture in your AWS account. After that we have did the debugging session. Then yesterday we have made this web application layer high available, and today we are going to continue and make this layer, database layer, high available. So let's go to our architecture, high available architecture, and see how this looks like now. So this is our two-tier architecture, and yesterday we made our web layer high available using different AWS EC2 feature like AMI, launch template, auto scaling, and load balancer, and also we used target group. Now this layer is quite high available application layer, and we have all supporting component to make it running resilient and in scalable way. Now database layer is, we haven't done anything here, so we are going to continue here. So what we are going to do, so when we say making our database layer high available, so there's couple of things we need to consider. First things, we have to make this database itself high available. What it mean? It's mean if this region goes down for XYZ reason, what does it mean? It means our entire application will stop working. So to make it high available, this very small configuration we need to do in our RDS console. But before that, let's understand what will happen. So here, when we make this RDS instance high available, then it's going to create another database instance in our another availability zone here. Okay, and what AWS do? AWS will synchronously able to update any changes. If you are doing any writes in our primary database, so it's going to update those details in our secondary database, and secondary database is just used for being high available. So if tomorrow something wrong happened to our this database, it goes down without any notice from your side or doing anything from your side, this database, secondary database, will become primary, and AWS will start repairing your primary database. So IP address of this secondary database will get changed to the DNS of our database. So as you noticed yesterday, when we created the database, not yesterday, previous to previous session, so we had the database DNS, right? So DNS is somewhere pointing to some IP address, right? So initially this is pointing to this primary database. Now something wrong happened to the primary database, primary instance, then IP address of secondary will get mapped with our DNS, database DNS. It will start sending a write request to our secondary database instance, but it will become the primary one. So this is one way of making our database high available. So that's what we are going to do. So let's do that. Then we talk about the different aspect of the database, what else we can do to make it more scalable. So let's go to the AWS console. Now this is our database, and database is running as expected. So to make this high available, we will select here, go in the action, and you see here we have the option convert multi-agent deployment. Okay, so click here. Once we click here, then we have two options. So one option, so will it make this database available in next maintenance window? So if you notice, in first session of deploying this high available architecture, first session of deploying two-tier architecture, we have set up the maintenance window. So if you select this option, so only that time is going to make this database high available. But here we can select different option. Second option, apply immediately. It means immediately is going to convert and make this database to high available, and it will take couple of seconds, not couple of seconds, couple of minutes. Okay, so it's so simple. So imagine if you are running a database on your EC2 instance, okay, then what level of effort is needed from your side, right? You have to create another EC2 instance, you have to deploy and configure MySQL, you have to do each and everything. So what we need to do to running a database, primary database on EC2 instance, same setup, same configuration you need to do on the secondary EC2 instance again. And most critical part is you have to ensure there should be continuous replication from your primary to secondary database. So that's most critical part, okay, and you have to manage by yourself. But here it was just one click and it's going to create a high available database. Now you see here this is modifying, but if you open here and if you go in settings, no, in configuration, and here we see multi-agent is not enabled, right, as of now. So this is modifying. In some time you will see this will become multi-agent. Okay, perfect. So this is one part is taking care of it. Meantime, let's go back to our architecture. So here in architecture you also see we have the read replica. What is this read replica and what is use of this read replica in this architecture? Imagine on this application there is a lot of read traffic, read request. It means when there is a lot of read request means users going to access data through this application from the database because they're going to access some data, right? So if this more request, let's say 10 times read request as compared to the write request, it means it's a 11x traffic is coming on your database, right? And your primary database is responsible for both read and write. So what about having a separate instance that only do the serve the read request of the database? That's where we use read replica. So AWS Amazon RDS has features called read replica. So what we'll do, we will create a read replica from this primary database, and this will be only responsible for serving the read request of our application. Okay, again this is quite simple. Again, couple of clicks we are able to do that. Couple of points to just to remember and keep in mind. For the normal Amazon RDS, when we create read replica, it supports up to 5 read replica. Whereas if you have Aurora, MySQL or Postgres, it supports 15 read replica. Okay, so now let's go to the AWS console and see if our database multi-agent is ready. If yes, then you can go for the next steps. So this is still modifying and it will take some time. Okay, let me refresh this, and let me refresh from the browser, hard refresh, and see what is the status. And this is not, and I think this is still modifying. We see this is modifying. So we know a database is little bit heavy service, so it takes some time. Okay, now see this is available. So let's click on the database and let's go to the configuration. Now we see here multi-agent is enabled. Okay, perfect. Now let's go back and let's enable the read replica. For that, again we'll select database, on the click on the action. Now you will see here create a read replica option is not enabled. Okay, so there is a reason why this is not enabled here. Okay, so to enable read replica of your database instance, we have to ensure auto backup is enabled for your database instance. And if you remember, when we were creating the database, we have not enabled auto backup. So let's click here and we'll click on the modify, and we need to modify this configuration. Scroll down, and this settings was in here, auto backup. Yeah, auto. Okay, now we see auto backup is enabled. So this auto backup is get enabled when we have made it multi-agent, but that day it was not enabled. So second thing, what we need to do, we have to ensure auto backup retention should be at least more than 1 day for these settings to be highlighted. Okay, we changed that, and now let's go ahead and continue and modify the DB instance. Again, let's tick this. We want to be modification to be implemented immediately, and the click on the modify, and again this will take some time, okay, to make these changes. But before that, let's check here. Okay, so it will take some time, so it will go again in the modify state. Okay, once this modification will be completed, then we'll be able to do that changes. Okay, so let's wait for the couple of minutes. Okay, again we do that. Perfect. Now again we see database available. Now we select this and let's go to the action. Now we see create read replica option is enabled. Okay, so click here, and again this is very simple settings. Okay, so it's asking which database identifier you want to. Okay, what will be the database, this DB identifier for the read replica? So you can just call it database one read replica, and maybe you can use it could be actually should be the same as the name of your database. Then we can use just read replica to ensure we know this is read replica. Okay, and everything will be as it is, same configuration. You don't want to do any changes here, and create a read replica, and again it will take couple of seconds. Okay, and this will be ready. You see now this is creating. Now let's go back to our architecture. Now here we see in this architecture, now again we have created this. Okay, now database is high available, and we also created a read replica, and again we have this working high available web server. We have the load balancer, and now everything is fine. Now last things what we need to do, we need to change the load balancer DNS name to our root 53, that what we have configured last time, right? Because last time in this architecture, let me delete it. In this architecture, we have configured IP address of the web server to our domain name, right, in root 53. So now we know this architecture is high available. Then we know we will have the multiple databases, multiple web servers running, and this is all servers are load balanced with this load balancer. So actually this load balancer DNS will be configured in our root 53. So let's go ahead and do that. So let me close this. Let's go to the AWS console. Okay, now let's go here, and before that let's go to the EC2 dashboard, because what I did, I have changed our auto scaling configuration because nothing was running overnight. Okay, so let's go to our auto scaling. When you go in auto scaling, select auto scaling, and you see here desired capacity is 0 and minimum is 0. Okay, because nothing was running. So again what we'll go ahead and edit this. Let me select this, and let's make desired capacity 1 and our minimum capacity 1. So it's going to create one instances for us. Okay, then this will be balanced with the load balancer. Meantime, let's go ahead and check our EC2 instances. You see this is a previous EC2 instances. So first EC2 instance. Okay, so still we need to wait before new instance will come. Now we see this instance is come up. Now let's go ahead to the load balancer, and load balancer will copy the DNS of the load balancer here, and let me check it. So it will take some time to this working. We see we are getting 503 error because nothing is running as of now behind the load balancer, as EC2 instances is still getting initialized. Okay, and now let's go to root 53 and open, and again we will open the DNS name, and here we are going to do these changes. So again check from here if something is running, and mostly not, because this public IP address of instance already got changed, and here I see is loading nothing. So let me bring here. Okay, it's loading nothing. Okay, let me type once again. So it's not loading because there's nothing is running, right? So that's where we are going to change the DNS of our load balancer. So select this, and here we are going to edit this. Okay, open, then first records. Okay, edit. Okay, so here we will go ahead and change this to this route traffic to the another IPv4 or some AWS resources, right? Because load balancer is another AWS resources. Okay, so we'll select this one and select alias, and here we see the different services, right? And one of them what we see here, scroll down, alias to application or classic load balancer. Select this, and then we select the AWS region where our load balancer is running. We'll select the Mumbai, then we see this is coming by default, this load balancer DNS, and save this. Okay, now we know DNS updates takes some time, but now let me go ahead again, type here once again the Epicbooks. Okay, and it will take time, but meantime you can check if this load balancer DNS is working. So still is showing unavailable because it will take some time. If you go and see the EC2 instance, so this is all good, but before it also need to be healthy at our target group, right? If you go here, select, so we know it's going to take some time. Let me refresh one more times. Sometimes though we see it's getting initialized, but we will be able to access application from here. But meantime, see the database if this is got modified. Not, this is still modifying, but now we see here we have another database read replica. This is available. Now, good thing is that what will happen? Now, inside your application, as of now, you have noticed we have only configured one database endpoint, right? And we have used this database endpoint inside our application, this database endpoint. So now what you can do, you can select this one, and this one you will see we have, this is different DNS. Why difference? You see here, this is coming with the read replica. You see database one read replica. So this is different endpoint. So in your application, you have to do this settings. So all read request you can send to this DNS name. So all traffic when you send to this DNS name, then this will come to this database read replica. Okay, now you see here this is healthy. Okay, so now let's go back and check at our application load balancer, and also we'll check at our domain name. Okay, domain name is still failing. Okay, but this is getting loaded name. Okay, now see application is running fine, so all good. Now we see everything is ready. So what we did, let's look at our original architecture. So here this was our original two-tier application architecture which you deployed in our AWS account, and here from the last couple of sessions we was trying to make this whole application architecture high available at every layer. Okay, every layer. But guys, okay, anyways, let's go back to the now new architecture. So this is our new architecture. Okay, but guys, there's a lot of problem in this architecture. Okay, I'll be very honest with you. The architecture what we have deployed earlier, it was good enough. Okay, but this high level architecture is fine, it's running, but from the security perspective and the industry standard, there's a lot of loophole, a lot of problem. Okay, so again, there's so many things need to be improved here that I'm going to cover slowly one by one. Okay, perfect.